Hey all dear friends, I Abhinav Negi welcome you all on BYJU'S exam prep guys. In these marathon sessions, I'm now coming with soil mechanics plus foundation engineering. In the same link, in the single chart guys, the complete soil mechanics plus foundation engineering will be done guys. The highest weightage of all subjects, that is soil mechanics, will be completed today guys. So lots of students, yes, Sushil Bhatt, Swapnil, okay, Traversing Dream, BYJU'S, so many students are watching these marathon from last 3 days. And let me tell you guys, in today's session, complete geotechnical engineering plus some interesting questions, okay, all topics, everything, concept plus numerical, everything will be done in the same link and from the same studio. Okay, those who are new here, let me introduce myself. My name is Abhinav Negi. I have 12 plus years of teaching experience, done my MTech from IIT Delhi in geotechnical engineering only. Okay, so subject which I'm teaching today, okay, the subject which I'm teaching today, the same subject guys, I have done my MTech also from IIT Delhi, that is geotechnical engineering. Thank you team MCQ. Nandu, Swapnil, welcome guys. I got All India rank 164 in 2012. You have to score better rank than this. Mentored more than 20,000 students in offline. Okay, these are the other things. You can also join me in my Telegram group. Okay, already guys, I guess 5,800 students have joined here. You can also join me in Civil by Abhinav sir. Okay, now guys, in this marathon sessions, let me tell you guys that in the description box now, if you want quiz, yes, we will be doing the live practice here along with concepts. But if you want quiz guys, then in the description box, kahan gaya quiz? Okay, in the description box guys, you will be getting the link of quiz also. Okay, click here, acha ye to raha. Click here to attempt the soil mechanics quiz. After this marathon, this will be open. And also guys, if you want one-to-one interaction, then this is a link guys of our counselor. You can get one-to-one interaction with our counselor about anything you want to ask about GATE or about courses. Okay, and you want to download the app, then this is the link guys from which you can download the app, where you will be getting the notes of technical subjects plus non-technical subjects plus PYQ of GATE, EC, ESE, ISRO, BARC and all. Okay, so this is the marathon guys. Now one change is here, that this will be now at 6 p.m. Okay, this Sunday marathon of surveying will be now at 6 p.m. Okay, so SOM is done, FM is done, environment is done, today is soil, then tomorrow will be hydrology irrigation, then surveying guys. Okay, now guys, there is a scholarship test on 14th of Jan. You can give this test and get up to 90%, 80%, 70%, 60% discount depending on whatever you score you are getting on that scholarship test. This is a free scholarship test on our app. Hi Prince, hi Saugata Ganguly, welcome guys. There is also a workshop, 7 golden rules to ace GATE 2025 in first attempt. That will be Rakesh sir. It will be on 17 Jan at 7:30 p.m. and it will be on app guys. Please do register this workshop for 17 Jan. Now guys, mega mock challenge is there. From 13th of Jan to 20th of Jan, a full length mock test is available on our app. That is again free of cost. Okay, so anytime from 13 Jan to 20 Jan, you can give this test exactly as GATE pattern. Now this will be tomorrow guys at 10 a.m. Okay, the hydrology and irrigation complete marathon. And guys, let me again tell you, the surveying marathon will be at 6 p.m. on Sunday. Okay, this will be 6 p.m. on Sunday, day and night match. Hi Ritesh, Rahul, Anwar, Prince, Saugata Ganguly, welcome guys. Okay, and vision courses are available in English and Hindi. You can join them. Okay, the 2025 and 26 courses where we are teaching from the basic level, from the zero level guys. Okay, so ready guys, everyone, please put a heart sign on the comment section guys. Everyone, come on guys. Please put a heart sign on the comment section. Akash, Rahul, Anwar, Prince, welcome dear students. Swapnil, okay, Anwar is also here. Ready? So what you are getting in this marathon, I am telling you again, all concepts, all topics, soil, foundation, numericals, MSQ, everything will be in this single session guys. Okay, please, my humble request that watch, make your screen full screen. Apart from whenever you want to ask your doubts, you can make a full screen. Yes, Mulli Karthik is also here. Okay, that is why I'll be taking foundation today. Okay, so everything you'll be getting. Now let me tell you about the weightage, guys. Yes, everyone knows this is the highest weightage of all the subjects. Okay, even more than engineering mathematics. So it is coming around 15 to 14 marks in both the sets. Okay, it is coming around 15 to 14 marks in both the sets, guys. If I tell you the last 3 years for all subjects, this data you can get it. Okay, so it is coming around every year 13 to 14 marks. In fact, last year 2023, it is of 16 marks. Okay, now in this is 2015 to 2023. In soil mechanics, which chapter is mostly asked? Oh, sorry, this is the complete gate. Geotech, you can see, is the highest weightage. Around 15 to 16 marks it is coming. Okay, then environmental and FM plus OCF, that is hydraulics. These are the other subjects. But let me tell you this survey. Where is highway? Highway is equally important because here even the marks are not as much as soil, but also syllabus is very less, na? So there is an alpha factor in gate exam. What is that alpha factor? We don't have to check the weightage, but weightage by syllabus. So weightage per unit syllabus of survey is much more higher than of soil mechanics. Okay. Now guys, let me tell you, in 2021, the last update of the gate syllabus has been done. In that syllabus of 2021 was the last change. In that, lateral capacity of pile has been added in the gate syllabus, and origin of soil and soil structure, that is kaolite, illite mineral, tetrahedral unit, silica unit, that has been deleted from gate syllabus. In engineering service, it is still there. Okay, people are thinking that Darcy's is also removed. No, guys, even Darcy law is not written in. The Darcy law is not written in soil mechanics syllabus, but guys, if seepage is written, then itself it means then a Darcy is there. If seepage is written, then itself means that Darcy is there, guys. Okay, so what is deleted in the last update syllabus? Last update of gate syllabus has been done by IIT Bombay in 2021. Okay, so last update, origin of soil is deleted, Westergaard is deleted, and soil structure, that is kaolite, illite mineral, that is also deleted. Okay, guys, everyone. Okay, now the correct sequence of studying soil mechanics, guys. This is the correct sequence, and in fact, we will be taking the marathon in this session, in this series only. First chapter will be this, and again here, guys, 30 to 35% of complete soil will be taken in the first chapter. Okay, 30 to 35% of complete thing will be done in the first chapter. Okay, so 30% time of the complete soil mechanics will be taken by this chapter. Then these are the other chapters that we are going to do, and in the same sequence we will be doing. Okay, so can you tell me which is this condition in soil? Good morning, good morning. Sophia, Susil, can you tell me which is this condition called? Please. What is this condition called? A person is drowning here in the soil. What is this condition? Okay. So this condition is called as quicksand condition. This condition is called as quicksand. What is the other name of quicksand condition? Other name of quicksand condition is piping failure. Okay. Quicksand condition. Here, particles are in no strength. Okay, so we'll study this here. We'll derive this also. This quicksand condition, little this is very important slide, guys. And let me tell you guys, till now, I've started teaching. If I ask you the most asked PDF in my mail throughout the year, guys, throughout the year, then this one. I have made a video on YouTube. And for every subject, I have made this. Syllabus, which is common in GATE and ESE. Syllabus only in engineering services. Syllabus only in GATE. Sometimes for most of the subject, there is no part here. Anything which is in GATE, not in ESE, for most of the subject, that is empty. But for soil, it is there. Little capacity is in GATE, not in ESE. Guys, let me tell you, more than, I guess, I have not counted exactly, but more than 800 students have mailed me on my mail ID, abhinav.negi@BYJU'S.com, about this PDF. If you also want, you can also mail me. Okay. You can also mail me at abhinav.negi@byju's.com. Okay. This complete PDF for all subjects. Okay. Every second day, guys, I got three mails from this. Okay. So this is the syllabus which is in GATE and ESE both. Lateral capacity of is only in gate. And only origin of soil is only in AC, geotextile is only in AC, designing of retaining wall is only in AC, Westergaard equation for vertical stress is only in AC. Boisengu is in gate, but Westergaard is only in this. Okay. So guys, ready for chapter 1? Everyone guys, come on. Please let me know. Please let me know. Please, ready? And one small request from my side, guys. One small request from my side. Everyone, guys, please share the session. Let everyone get benefited from this. Please share one. This whole team has done a lot of effort to make this session possible. Okay. Please share it, guys. And like the session as well. Like the session as well, guys. Okay. फिर start करते हैं. Copy pen निकाल के रखना. Calculator का तो थोड़ा जरूरत. Calculator it will take some time. And guys, make it 100. Yeah, 90 people are watching. 90 people are watching. Make it 100. Make it 100, guys. Come on. Okay. So chapter 1 will be origin of soil and property. Okay. Now origin of soil I am teaching because some part of that is related to the gate concepts also. Now in origin of soil, you don't have to do anything. Okay, just make your mobile full screen. Okay, just relax and you have to listen the story only. Okay, listen the story only. In origin of soil, you don't have to write anything. Okay, you don't have to do any question. Just you have to listen the story and at the end I will be taking your doubt. Okay, just for next 12 minutes. Next 12 minutes I'll be telling you a story. And guys, you just have to listen. Okay. Now guys, ready? 1, 2, 3, Jai Shri Ganesh. Let's start. Guys, anything, listen the story now, guys. Now no need to share anything. Just listen to story, make it full screen. Share, like, subscribe, we'll do later on now. Okay. Share, subscribe, we'll do later on now. Just listen to me. Guys, first of all, anything which is less than 80 mm, and guys, please don't, in this whole marathon, now whatever is written here, don't see that. Okay, I will be connecting the things. Okay, I will be connecting when I have to teach this, when I have to teach this, when I have to teach this, I'll connect this. Maybe particular this line I'll teach after 2 slides. So I will connect the things. Okay, don't worry about that. Okay. So first of all, guys, anything which is less than 80 mm is soil. Suppose, guys, please don't read. Student's mind, or in fact, human being mind is that whatever we told him not to do, they will be doing that only. Okay, so this is a sieve. This is a sieve. Now, this size of this opening is 80 mm. Size of this opening is 80 mm. Okay, this is a square shape. All these openings are square shape. And size is 80 mm. Okay, now, size is 80 mm. That means if anything we are throwing on this, okay, any part of soil we have taken and anything we are throwing on this, so whatever is going down, okay, whatever is going down, that will be soil. Okay, whatever is going down, that will be soil. Okay, whatever is going down will be soil, and whatever retaining it, even if the stones are also going down, that will also be considered as soil. Even if stone is also going down, it is also considered as soil. Okay, and if anything which is retaining in here, even the soil, that is not considered as soil. That is not considered as soil. So anything which is less than 80 mm is soil. Now, process of soil formation is called as pedogenesis. Okay, and how the soil is formed, I will be telling you. I'll coming in these 2 points later on, guys. Now, how the soil is formed, I'll coming these points, guys, later on. Please see, listen the story now. Everyone, you have to listen the story. Beautiful story, guys. There are 2 types of soil. Organic soil. There is 2 types of soil. Organic soil and inorganic soil. Now, inorganic soil and organic soil are 2 types of soil. Organic soil is formed from decomposition. This is formed from decomposition of organic matter. Decomposition of organic matter like plants and trees. Like plants and trees. Okay, plants and trees will be decomposing for hundred of years. Then the soil is formed as organic soil. And let me tell you, as a civil engineer, we all are civil engineer. We don't like this soil. Why we don't like this soil? I'll tell you. Inorganic soils are formed from decomposition, you can say. You can say erosion. You can say weathering. You can say weathering of rock. The rock, triple H. Okay. So from rock, there is disintegration. Might be air is acting on it. Might be water is acting on it. Okay. Might be anything, chemicals are acting on it, and rock is disintegrated into small particles. Rock is disintegrated into small particles. Okay. After 100 years, 200 years. That soil is inorganic soil, and we love inorganic soil. We love this soil. We hate this soil. First of all, this love and hate, I'm telling you, for civil engineers. Okay, might be agricultural engineering from Pant University. There is a very famous university of agricultural engineering, Pant University, in my hometown, Uttarakhand. Might be they are loving this and hating this. Might be they are loving this and they are hating this. But guys, we civil engineers hate this and love this. Now, what is the reason of hate and love? Guys, this soil is not suitable for geotechnical work. This soil is not suitable for geotechnical work. It is large settlement here. Settlement of this is large. Compressibility is large. If you make a building, hi Shivani, hi everyone. If you make a building in the organic soil, if you make a building in organic soil, might be the third floor becomes the first floor after 10 years. Okay, might be the third floor becomes the first floor after 3 years, 5 years or 10 years. Large settlement, large compressibility of organic soil. But in organic soil, the compressibility is limited. Okay, so the definition of this is I told you, the definition of soil is different for geologist. Geologist is more interested that up to what depth below the ground level is sand, up to what depth below the ground level is water. Okay, agriculture is more interested in finding out the chemicals in the soil. Okay, are the chemicals are good for the crop requirement or not? But guys, we are not this chemistry man here, or we are not this survey man or chemistry man. We are the related to physics. This civil engineering is related to the strength of soil. Okay, for foundation it is good or not? Can it, the bearing capacity, it is good or not? It can take load or not? So guys, agriculture will be dealing with the chemistry of soil mechanics. They are dealing with the chemistry of soil mechanics, but civil engineers dealing with the physics of soil mechanics. And of course, guys, 90 or 95% of engineers love physics and hate chemistry. Okay. So, guys, thank you, Shivani. Thank you. Aapne certificate de diya. Okay. So, we are not much interested in organic soil, the decomposition of organic matter. We are interested in inorganic soil. Okay, organic soil is formed from this. Guys, don't read this. Whatever I am teaching, everything will be covered. Even whatever written is more than that will be covered. Okay. Now, guys, anything which is, ek to yaar galat so ke na, here it is paining. Might be due to bad position of my sleep. Now, guys, this is not soil. This is not soil. Listen the story, guys. I have not finished the story. Now, this is soil. Less than 80 mm. Now 80 mm to 4.75 is gravel. Okay, and 4.75 mm to 75 micron. What is 75 micron? What is 75 micron? 0.075 mm. Okay, what is this 2 micron? 2 micron is 0.002 mm. Okay, now from 80 to 4.75 mm, that is gravel, and 4.75 mm to 75 micron is sand. Coarse, medium, fine. This further classification is not required. Okay. Shivani, mail me, I'll tell you there. Okay, this is coarse grain soil, CGS. Okay, and from 75 micron to 2 micron it is silt, and less than 2 micron is killed. 2 micron is clay, less than 2 micron is clay, and that is fine grain soil. Coarse grain soil I will be representing as CGS. This I will be representing as FGS. Okay, this I will be representing as CGS. This I will be representing as fine grain soil. Less than 80 mm is soil. Now, how to find out that where it is gravel, sand, silt? So guys, first of all guys, if I have a 75 micron sieve and I throw the soil on this, if I have a 75 micron soil and I throw the soil on that, okay, so whatever is retaining on that, that will be coarse or fine? Tell me. Whatever is retaining on that, that will be coarse or fine? Okay. Tell me this. Whatever is retaining on that, that will be coarse grain soil. Above 75 micron is the Lakshman Rekha, na? 75 micron is the Lakshman Rekha. Above that is coarse grain soil. And of course, it should not be more than 80 mm. Otherwise, it is not soil. It should not be more than 80 mm. Otherwise, it is not soil. Okay. Now, whatever is coming below this, okay, that will be, whatever is coming below this, that will be fine grain soil. Okay. Okay, sir. Got it, sir. Okay, sir. Got it, sir. Okay, sir. Got it, sir. Okay. Now, everyone, this is coarse grain soil, this is fine grain soil. Now, okay, this whole story I'm telling you, this whole story, this is not soil, this is coarse grain soil, this coarse grain soil, this is fine grain soil. Okay. Now I want to tell a story to my students. Give me some blank page. यहाँ होता था ना, कहाँ गया, नहीं आ रहा. Give me some blank page. Okay, this is the blank page. Okay. So, you understood that it is a organic soil. Okay, one is a organic soil. Okay, this is asked in 1 marks, guys. This is a huge compressibility. We don't like this. Okay, and another is inorganic soil. So we as a civil engineer deal with inorganic soil in sites. Okay, because organic soil is a large settlement. Now, organic soils are formed from decomposition of plants. Now, how inorganic soil is formed? Everyone, please now listen the story. This is a parent rock. Guys, from these concepts, the questions are asked in the GATE exam, guys. 1 mark question. 1 mark question in the GATE exam. Everyone. Okay. So, this parent rock is there. Now, this parent rock decomposition is there. Okay. So, there are 2 types of decomposition. One is physical weathering. Physical weathering. Weathering means decomposition. Weathering means erosion. Weathering means disintegration. Okay, and one is chemical weathering. One is chemical weathering. Weathering means erosion. Weathering means disintegration, anything. Okay. So, hi MVS, hi Swapnil. Guys, this session might be only live. So, don't try to miss it. This session will be only live, guys. Okay. Now, physical weathering, we got coarse grain soil. What is first of all physical weathering? When the rock is acted by air, okay, this rock is acted by water, okay, rock is acted by air and water for 100 of years. Air is coming, water is coming, it is in river, water is coming, and it is coming into small pieces. It is coming into small pieces. Okay, that is the physical weathering. Chemical weathering is, this is acted by sulfur dioxide, this is acted by carbon dioxide, this is acted by acid rain occurs, okay, alkali, some chemicals are acted. Okay. Now, when physical weathering, disintegration, this all is happening in 100 or 200 years. From here we got coarse grain soil, and from here we got fine grain soil. Coarse grain soil means big shape. Coarse grain soil means big size. Fine grain soil means small size. Okay, it's very small. Very small. Okay, guys, here the shape is 1 mark question. It is asked in GATE exam. Here the shape is angular. Here the shape is flaky. What is flaky shape? What is flaky shape? Flaky shape is like this. Okay. Now, depending upon the weathering is physical weathering or chemical weathering, the properties of this coarse grain soil and the properties of this fine grain soil are very different. Okay. The property of this coarse grain soil and the property of this fine grain soil are very different. Let me tell you the properties. Coarse grain soil, fine grain soil. Okay. Now see, everyone. Guys, coarse grain soil will retain the property of its parent. Iske pitaji kaun hai? Who is the father? Okay. Who is the father? From where the soil is coming? From where the soil is coming? Soil is coming from parent rock, na? Soil is coming from parent rock, na? Soil is coming from the parent rock, na? Yes or no? Yes or no? Yes. So if soil is coming from parent rock, and here there is no other chemical is acted, okay, no other chemical is acted, only air and water. So property will be same as parent rock. Yes or no on the comment section, guys? Yes or no on the comment section, guys? Everyone! Okay. Now here some chemicals are also acted. Foreign agencies, some chemicals are also acted. So here properties will be changed. Obvious. Story is very obvious. Here the size is big. Here the size is less. Okay. Here one void. Void means this air or the gap between. One void will be less. Here one void will be lesser. Okay. Here the size of one void is this empty space in between. Okay. The void is empty space in between. So that empty space is big. Here the empty space will be small. One empty space. But here, guys, let me tell you that there is a term called E. E is void ratio. Guys, these all concepts are asked in 1 marks in GATE exam, guys. Void ratio. Void ratio is volume of voids by volume of solid. Here one void is bigger. Here one void is bigger. Here one void is bigger. Here one void is smaller. But if I talk about void ratio, then void ratio here is smaller and void ratio here is bigger. Oh my God, sir. Oh my God, sir. What are you saying? You are saying one void is bigger in coarse grain soil. You are saying one void is bigger in coarse grain soil. Yes, one void is bigger in coarse grain soil. You are saying one void is smaller than here. Yes, one void is smaller there. But guys, sir, how then void ratio is smaller here? If void is bigger, then how void ratio is smaller here? Guys, in fine grain soil, voids are very small. Thin, 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 thin. Voids are very small. Thin, 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 thin. Voids are very small. Thin, 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 thin. Okay. Voids are very small. Thin, 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 thin. Okay. But number of voids are very much. And they are in such a way. The total volume of voids is more here. Volume of voids is more here. Understood? Voids are very small. But number of voids are so much. The total volume is more here. Everybody give me a yes or no. Put a heart sign if you got it. Put a heart sign if you got it, girls. Come on. Come on. Come on, girls. Everyone. Tell me. Tell me. Tell me. Okay. Guys, just cancel all your meetings. शाम को मिल लेंगे. शाम को भी कैसे मिल लेंगे? मैराथन चलेगी. कहना कल मिल लेंगे. रात को बात करेंगे आज. अभी पढ़ लो. मजा आएगा. मतलब मैं ये नहीं कह रहा कि 15 मार्क्स में से you will get 15 marks in soil. But whatever marks you are deserving, you can get a bit more than that. You can get a bit more than that. Okay. So here void ratio is smaller. Here void ratio is bigger. Okay. Now here permeability. Permeability is more here. Permeability is less here. Okay. The permeability is the speed, water speed. Okay. The permeability is the water speed. Okay. So if in this bottle na, if in this bottle I fill the big gravels, okay, big size particles, then if I throw the water, it will come very fast. If I throw the water, it will come very fast here. Okay, but if I fill with clay, very small particles, then I throw the water here, it will not come very fast. Okay, but in gravels, if I fill with gravels, throw the water, it will come very fast. Okay, got it? Size of the, yes, it is less. It is less. Okay, so these properties have you understood? Now there is a term called specific surface area, SS. That is surface area per unit volume. So here the specific surface area is less. Here the specific surface area is more. Let me tell you a real story. Guys, my hometown is in Uttarakhand. Let me tell you a real story. My hometown is in Uttarakhand. Okay. And it is a real story of my cousin, guys. This is a real story of my cousin. In Diwali, in my hometown, guys, there is no road. So he was going from one house to another house. Only 30-40 house in mountain, Uttarakhand. This is a real story, guys. You can search him in my Facebook also, Sudeep Negi. So he was going from one house to another house, and there is in between a 100-meter space and little bit of trees and jungle. My whole village is in jungle. This is a real story, and I will explain you here this. Okay. So when he was going now, so a tiger come and tiger attacked him here and attacked him here. And by chance it is Diwali, so some pataka, some cracker burst or rocket comes, so tiger afraid and he moves away. Then there is a 3-hour journey in our village to go to the top, and where we can get a jeep and then go to hospital further 5 hours away. So after 8 hours he was stitched and he was saved. Later on, one more friend in the same day, Diwali, one more cousin, eat poison. Okay. And in the same jeep, he was also sent to the doctor in the same place. And I don't know how this coincidence happens. And he was saved. He was saved because he has eaten the complete tablet. If somebody wants to do suicide, should he eat a complete tablet, or he should do it in piecing, chakki piecing, and make it fines? Okay, if he make it fines, this powder, if he make the poison tablet not as a complete tablet, as a powder, then in A case or B case, in which case he will die first? If he eat the complete tablet or if he eat the pieces? Tell me. If he eat the complete tablet or if he complete the pieces? Tell me, guys. Everyone. Okay, tell me. In B case, because here the reaction will be faster, na? Here the reaction will be the faster, na? Here the reaction will be faster, na? Okay, because there is so much surface area. So in fine grain soil, the surface area will be more, na, per unit volume as compared to coarse grain soil. Give me yes or no for this concept. Give me yes or no for this concept, guys. Everyone, everything I'm writing here. Everything I'm writing here is a 1-mark question, guys. And now you don't have to remember. From making the logical combination of concepts, you can solve everything, guys. Have you understood the concept? Yes or no? Okay. So understood. Okay. So this is about inorganic soil. From parent rock, guys, both are inorganic. Organic we have left now. Guy, bye-bye. I don't like you. These both are inorganic. So why it is retaining the parent property? Because there is no chemical actings. Here, chemicals are acting, so parent property is not removed, not getting. Yes or no? Okay. So now, as the property different from parent rock, we have studied. Okay, soil is formed fine grain, here coarse grain, we have studied. Okay, chemical weathering caused by chemical oxidation, hydrocarbon is acting, or some chemicals are acting. These act water, ice or wind. Okay, more wide ratio, here less wide ratio, we have studied. Everything we have studied here. Permeability is more, we have studied here. Less surface area, we have studied here. Okay, one more thing. One, this is we have not studied. Now, again, this I'll tell you with logic. This 7th point. Guys, coarse grain are neutral particles. This coarse grain soil are neutral particles. There is no charge separation between them. Okay? Yes, guys. So, guys, everyone in the comment box, one of the finest faculty of computer science with lots of logic, Anurag sir is here. Okay, my dearest friend from Chandigarh. Everyone please put a heart sign for Anurag sir, one of the best faculty across the country in computer science. Okay. Of course, guys, we'll request him to join the BYJU'S as well. Everyone please put a heart sign, guys, for Anurag Purwal sir. Everyone. Okay. So, guys, this is coarse grain soil. Okay. And there are no charge separation in them. Okay, there is no charge separation in them. Okay, so they are neutral. There is no cohesion. Okay, they are cohesionless. No attraction between the particles. No attraction between the particles. But in fine grain soil, okay, in fine grain soil, they are flaky shape, na? Okay, I am showing them in a but when we zoom them, it will be like this. But when we zoom them, it will be like this, zooming them. So in fine grain soil, especially clay, the plus and minus charges are separated. Okay, the plus and minus charges are separated. So one plus will be attracted to other minus. So there is cohesion between the particles. There is cohesion between the particles because there is charge separation. One plus may be attracted by other minus. Okay, and here usually the attractive force dominates the repulsive force. So there is attraction between the particles. Okay, now guys, here everyone listen to a story now. Here now, what I want, let me show you two types of things. One soil, coarse grain soil is this. Both are coarse grain soil. One coarse grain soil is this. Okay, another coarse grain soil is this. Then some medium particles. Then some medium particles like this. Okay, then small particles. But the smaller is also in the coarse range. Okay, the smaller is also in the coarse range. The smaller is not in the fine range. They are also more than 75 micron. So guys, A soil is good or B soil is good? Tell me on the comment box. A soil is good or B soil is good? Everyone on the comment section, guys. Everyone. Everyone. Chalo, bolo. Which soil is good? Which soil is good? The B soil is good. So guys, here I don't want all particles are of same size. I want different size particles. So that if there are smaller particles, medium particles, so they can fit in the voids. And when they can fit in the voids, their density will be more. They are more stronger. Less voids means they are more stronger. Less voids means more density. More density means more stronger. So here gradation is important. Okay, size distribution. I don't want all size of same. I want different sizes. Okay, so here grain size distribution is important. Guys, now for the fine grain soil, if the fine grain soil are of same size, if the fine grain soil are of same size, if the fine grain soil are of same size, if the fine grain soil are of same size, if the fine grain also are of same size, you cannot say them poor. Generally, we call them well graded coarse grain soil, and this is poor. But in fine, we cannot call them poor because you are saying all particles are of same size, and you are calling them poor. But when you see it from near, there is cohesion between the particles and they are acting as a strong unit. So you cannot call fine grain soil poor on the basis of, the voids in between, on the basis of size, because they may be very strong. Because of the cohesion. It is the kahani like, it is a story like, दूर से देखा तो गंजे खेल रहे थे, पास जाके देखा तो अंडे उबल रहे थे. Let me tell you in English. From very far away, if I've seen, it was like bald people are jumping and playing. But when I see near, actually the eggs are boiling. दूर से देखा तो गंजे खेल रहे थे, bald people are playing, jumping. But when पास जाके देखा तो अंडे उबल रहे थे. When I go near, it is eggs are boiling. So दूर से देखा, it is poor. It is poor. But in fine grain soil, when I go near, oh yeah, there is attraction between the particles. So fine grain soil cannot be judged on the basis of size. So their gradation is not important property. There, the water content is important property, because in fine grain soil, a little fluctuation in water content, there is a lot of change in the properties of soil because of the interaction of this plus and minus, which H plus and OH minus, that we'll see later on. Everybody till now, have you got the concepts with 100% clarity? Give me yes or no. Give me yes or no, guys. Everyone, come on. Come on. Getting the things? Okay. Now, guys, now see, if this is parent rock, Pitaji, father, okay, this parent rock, and soil is here only, okay, soil is formed here, after 100 years it is formed here, it is called residual soil. Residual, it is not going to America, it is in India only. Now, some water is coming, river is coming, wind is coming, and that soil is transported somewhere. So that is called transported soil. It is gone to America for placement. That is a transported student. If a student is with his mother, father only, that is a residual student. Okay, so if the soil is near the rock, it is residual. If it is transported, that is transported soil. If it is transported by river, it is alluvial soil. If it is deposited somewhere else by lake, it is lacustrine soil. If it is deposited by seawater in the seabed, that is marine soil. If it is deposited by winds, by some other place, by wind it is deposited some other place, alluvial soil. If it is deposited by glacier, then it is called glacial soils. Okay, this is just a theoretical thing that I'll provide you in the notes. So what? This is over. This is over. Guys, how was the experience? How was the experience of the introduction of the soils? Course, fine. How was it? ठीक ठाक पढ़ा लेता हूँ मैं. How was the introduction, guys? How was the introduction? How was the introduction, guys? चल जाएगा मेरा काम गेट फील्ड में. चल जाएगा काम गेट फील्ड में मेरा. Okay. Yes. And now let us start the second part. Everyone, guys. Everyone. Everyone, guys. Please write down your cities. I want to see from which part of the person, which part of the country the students are watching me. Everyone, please. Everyone. Don. Yes, Mayank. कैसी है तुम्हारी ओपन जीप? दिल्ली, सोफिया दिल्ली हो गए. कर्नाटका, कोलकाता, जम्मू कश्मीर, Nellore, Jammu Kashmir, which place? Mysore, Hyderabad is that Mia Bhai song, na? Chhatrapati Shivaji, Nagpur Santra, oranges. Kolkata, Mishti Doi. Karnataka, Rahul Dravid. Maharashtra, Mumbai, Amchi Mumbai. Jammu, okay. Andhra Pradesh, VVS Lakshman and Rajuddin, Vijayawada, Varanasi, Modi. Nagpur, oh Prince, I know you. Godavari, Pune, Vizag RK Beach, Balaghat, MP, Kolkata. Little Rock, USA. From USA also the students are watching me. But in their university, the units are not SI units, na? They do use FPS. Tamil Nadu, Jalalita, Hyderabad, Prayagraj, Sangam, Pune, weather, Agra, Pagalkhana and Taj Mahal. Okay, chalo. असम, काजीरंगा, नेपाल से भी देख रहे हैं. शिमला हिल्स, Nivaran, I'm from Uttarakhand, but I was born in Shimla. Jakhu was my school, Kendra Vidyalaya Jakhu. Bhopal, MP Nagar, Guntur, East Godavari. Okay, now let's start. Guys, suppose, first of all, guys, people think one mistake student do, that they think void is only air. No, void is air plus water both. Now, when I'm showing you this soil, leave, I'm not showing you here. Okay, suppose I'm showing you here. This is soil. This is soil. Okay, so these are solids. These are solid particles. Okay, in between, this is solid particles. In between the gap, it is air, and might be some gap is filled with water also. Some gaps are filled with water also. So air and water both are voids. Actually, solid, air, water, everything is mixed. But I am representing in phase diagram like this. I am representing in phase diagram, it is like this. Okay, this is water. Actually, it is solid. In between, it is air, and this is water. This white, they have shown the water with white. So this is a three-phase diagram. Generally, we represent weight on the right-hand side and volume on the left-hand side, but there is no logic. You can represent weight left and volume right also. Okay. So guys, in whole soil mechanics, whenever I'll representing small w, that will be water content. What is water content? I'll tell you next slide. And capital W, I'll be writing as weight. Small w, I'll be writing as water content or moisture content. In whole soil mechanics, please do follow this in this whole marathon. Okay, so this is weight of solid. Capital W means weight. This is weight of water. Okay, and this is weight of air. Weight of air in soil mechanics we consider to be 0. This is volume of solids. This is volume of water, and this is volume of air, and this total is volume of voids. This total is volume of voids. Okay, now everyone, please see here, my commandos, my champions, everyone, that if this soil, which is water also in between, if I oven dry it, okay, if I dry it, oven dry, so oven dry, it will go here, water will be gone. So everything will be now air. Okay, and if rain comes with sufficient amount, then all this white is actually water. Then all void is filled with, all voids are filled with water. So everything is water, that is saturated case. So this is dry case. When I put this oven dry, this is called partially saturated. A new name is also given to this in recent 4-5 years. In civil engineering, guys, the 5 years is also called as new. In computer science, this 1 week is called new. Okay, and this is a saturated soil. All voids are filled with water. Guys, remember one important concept: the solid will be constant. Solid is equal weight or volume of solid will be constant. Suppose now there is a soil. Okay, I take this soil here and I put that soil in my pocket and compress it. I put that soil in my pocket and compress it. The solids will be same. Might be total volume is reduced. If this is a soil, I excavate the soil from here and I compact it here. So might be the total volume of soil is reduced, might be the total volume is reduced, but the solid will be same. Air can be reduced, water can be expelled out, but solid has to be constant. Give me yes or no. Have you understood this? Give me yes or no. Have you understood this? Everyone? Everyone? Okay. So this is water and that is also this. So solid will be same. Weight of solid will be same. Okay, if nothing soil is added, then no weight of solid will be added. Yes, total volume may be reduced. If I compact, volume may be reduced, but solid will not be going to change. Now, guys, water content or moisture content, that I'll be writing with small w. Okay, what is water content, small w? It is weight, capital W is weight of water by weight of solid in fraction. If you want percentage, then multiply by 100. If you want in percentage, then multiply by 100. Many cities, I'm right now in Noida. Okay. This water content is less than 100%. Okay, sorry. Water content can be greater than 100%. Water content can be greater than 100%. Guys, there is a bentonite soil, which is a type of clay. In bentonite, now what happens? There is solid is less and voids is very big. If that all voids are filled with water, then weight of water is more than weight of solid. So water content can be greater than 100%. Okay. Void ratio. What is void ratio? Volume of voids by volume of solid. Guys, there is one more term, porosity. Okay. What is porosity? Porosity is volume of voids by total volume. Guys, have you heard about void ratio more or porosity more in the formulas? Void ratio more or porosity more in the formulas? Tell me. Have you heard about void ratio more or porosity more? Void ratio. Why? 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 Because guys, void ratio denominator is volume of solid and that is a constant thing. Okay, it is more stable parameter because here numerator of both are same, but here denominator is a constant thing, na? Here denominator can also change. If you compact the soil, total volume is reduced. If you compact the soil, total volume is reduced. Okay. So that is why. Good. Okay. Now, porosity is done. Degree of saturation. Degree of saturation is represented by S, and S value is volume of water by volume of void. Now, can you tell me the value of S here? I am writing here again. Saturation is volume of water by volume of void. So, what is S here? Tell me, please. Tell me, please. What is S here? And what is S here? So, S here is 0. Volume of water is 0. For dry soil, saturation is 0. What is S here? Volume of water and void both are same thing. Water is this, void is this. S is equal to 1. And what is S here? 0 to 1. Volume of water and volume of void. It is fraction 0 to 1. Have you understood? Have you understood? Guys, come on. Chalo. Okay. चलो ज़्यादा टाइम वेस्ट नहीं. Air content. So air content is equal to volume of air by volume of void. Guys, tell me the value of S plus AC. ये गलत हो गया. What is the value of S plus air content? Tell me in percentage, tell me, or in fraction, anything you tell me, please. तब तक मैं टाइम में जाता हूँ. Tell me this value जब तक मैं टाइम में जाता हूँ. Na. What is Na? Next topic. Tell me this. Guys, S111. Okay, S plus AC is equal to 1. Because S is volume of water by volume of void. Air content is volume of air by volume of void. And if you take LCM as volume of void, volume of water plus volume of air is volume of void. So either you can say 1, or if you want in percentage, it is 100%. Give me yes or no. Give me yes or no. Everyone please. Everyone please. Give me yes or no. Okay. And what is percentage air void? What is percentage air void? What is percentage air void? It is volume of air by total volume. If you want in percentage into 100. Guys, which will be more? AC will be more or Na will be more? AC will be more or Na will be more? Air content will be more. Air content will be more, na? Because here denominator is smaller. Because here the denominator is smaller. Volume of void, their denominator is bigger. Their denominator is bigger. Confirm me, please. Confirm me, please. Everyone. एवरीवन प्लीज. ओके सर, आप लेजेंड हैं सॉइल के. कोई लेजेंड नहीं होता है, कोई कुछ नहीं होता है. जिसने अपने आप को लेजेंड समझ लिया उसी दिन से उसका पतन चालू हो गया भाई. ओके परसेंटेज अवॉइड हो गया. आ स्टूडेंट्स आर वेरी कंफ्यूज्ड इन दिस. Students are very confused in this. What is unit weight of water? Okay, what is bulk unit weight? Okay, what is unit weight of solid? Okay, what is dry unit weight of soil? Students are very confused. Let me tell you guys one thing. For next 5 to 6 minutes, give me just 16 to 5, 300 seconds. Just give me 300 seconds. In 300 seconds na, everyone, in next 300 seconds na, I will make it this topic complete for you forever. Okay, एक बार फटाफट से शेयर कर दो यार सबको. 98 है, एक बार 100 से ऊपर पहुंचाओ इसको. Everyone. Okay, now see. Everyone, in next 300 seconds this topic will be clear for you forever. What is density? Mass by volume na. Density is mass by volume. Guys, what I think na, this background is I guess better than black, better than white. Okay, not ekdam completely blue. It will be spark, it will be in eyes, it will not be good. So it is good. And gamma is equal to weight by volume. Gamma is equal to weight by volume. अपने टीम के लिए समोसे मंगा देते हैं यार. ओके चलो. Gamma is equal to weight by volume. Only you have to remember that gamma is equal to weight by volume. Okay, only you have to remember that gamma is equal to weight by volume. Density is mass by volume. अरविंद भाई एक बार स्टूडियो नंबर 1 पे आना प्लीज. ओके okay, so gamma is equal to weight by volume, density is equal to mass by volume. Till here clear? Till here clear everyone? Yes, so only this has to be remembered, nothing else. Cash निकाल लेते हैं भाई. Okay, so density is mass by volume. Okay, gamma is weight by volume. तो मिलने ले आओ 2 रेड बुल. 2 रेड बुल, वो आप उसको बोलोगे संदीप को समझ जाएगा. 2 रेड बुल ठीक है. और बाकी अपनी टीम के लिए और वीडियो टीम के लिए पूछ लो क्या लाना है. समोसा समोसा पूछ लो उनसे. ठीक है, अभी पूछ लो सबसे क्या लाना है. अभी सर बोलो. ओके, नाउ डेंसिटी इज मास वॉल्यूम. गामा इज वेट बाय वॉल्यूम. दैट्स इट, नथिंग एल्स हैज टू बी डन. गामा इज वेट बाय वॉल्यूम, नथिंग एल्स. Okay, gamma is weight by volume, nothing else has to be done. Now, unit weight of water. What is gamma? Weight by volume. What is gamma? Weight by volume. So, it is weight of water upon volume of water. Gamma W, if nothing is mentioned, you have to take 9.81 kilonewton per meter cube. In examination, if nothing is mentioned, you have to take 9.81, not 10. Okay, यहाँ 2 marks तो बचा लो. Save 2 marks here. Otherwise, you take 10 and it is an NAT type problem, your answer will be out of range. Instead of +2 you'll get 0. In NAT there is no negative marking. So unless mentioned in any subject, you don't have to take 10 gravity value. You have to take 9.81. Okay, now what is bulk unit weight? Unit weight is weight by volume. Bulk unit weight is weight of total weight of soil upon volume of soil. Weight by volume yaar. Weight by volume yaar. Weight by volume yaar. So weight of soil upon volume of soil. What is unit weight of solid? Weight of solid upon volume of solid. Weight by volume. Weight by volume. Now bulk unit weight may be any case. Okay, bulk unit weight is a general thing. Bulk unit weight can be defined for this, bulk unit weight can be defined for this, bulk unit weight can be defined for this. People think that bulk unit weight is this. No, no, no. Bulk unit weight means whatever is the condition, weight of that condition upon volume of that condition, total weight of that condition upon volume of that condition. Okay. Now, what is dry? Dry. So weight of solid. In dry case, what is the weight of soil? In dry case, what is the weight? So weight is only solid, na? Air is 0. In dry case, it is weight of solid upon, but this is of soil, guys. So weight of soil is weight of solid upon volume of soil. Okay. Now, guys, wait. I'm telling you a very interesting thing. Saturated unit weight means gamma sat. It is weight of the saturated condition. Weight of the saturated condition upon total volume of soil, and gamma submerged is equal to gamma sat minus gamma W. Sir, what is gamma sat, sir? I am not getting, sir. Let me tell you, forever it will be clear now. Forever it will be clear. Let this be a soil. Let this be a soil. Let the volume of soil be V. Okay. Okay, let the volume of soil is V. Now I am putting this soil in a container. I am putting a soil in the container and I am filling the container with water. Okay, so this will be saturated soil now. 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 Yes. So let me draw the free body diagram of this. So it is inside water, so it will be saturated. So downward weight is gamma saturated into volume. Gamma into volume is weight. Okay, and upward is beyond weight. Beyond weight is the weight of displaced liquid. So weight of liquid is gamma W into V. So net weight is gamma sat into volume minus gamma W into volume. This is net weight. So net weight by volume is gamma submerged. Net weight by volume is inside the water. Net weight by volume is gamma submerged. That is gamma sat minus gamma W. Now the question is, sir, where to use this, sir? Let me tell you. This is water. I'm putting water here. In my legs also. I'm putting water. Here. Everywhere I'm putting water. Guys, my weight will be increased or decreased. If somebody wants to lift me now. Weight will be increased or decreased. If somebody wants to lift me now, weight will be decreased or increased. Tell me. Weight will be increased or decreased. Tell me, guys, everyone. Weight will be increased or decreased. Increased, na? And suppose I am going in swimming pool. Inside swimming pool, my weight will be increased or decreased? My weight will be increased or decreased inside swimming pool? No, my weight means somebody wants to lift me. So it will increase now because the water is also here. If I go in swimming pool, somebody can lift me easily. Guys, you cannot lift Vidya Balan. But you can lift Vidya Balan inside the swimming pool because of the beyond weight. You cannot lift Vidya Balan. But you can lift Vidya Balan. Inside the swimming pool because of beyond weight. Okay. So guys, where to use gamma sat and where to use gamma sat and where to use gamma summer? This is ground level. This is water table. Now here is the soil and suppose all voids are filled with water. Okay, and here is also soil. Of course, here is also filled with water. So for this you will be using gamma submerged. But for this you will be using gamma sat if all voids are filled with water. Guys, beyond weight only acts. When somebody is displacing the liquid. So that liquid wants to come its own place. So it will be applying a beyond weight. When somebody is not displacing liquid, then no beyond weight is acting. When somebody is displacing liquid, then only beyond weight is acting. When I'm going in swimming pool, when Vidya Balan is going in swimming pool, she is displacing some liquid. So beyond weight is acting. But here in the studio, if I'm doing like this, everywhere water, I'm not displacing any liquid. So my weight will be in fact increased. Everybody on the comment box, if you understood this concept, everybody please put a heart sign. Please put a heart sign on the comment section, guys. Ask me doubt. Now I am writing one more thing. Let me see who can understood this. If you understood this, if you understood this single line, That means you understood this. That means you understood this. If you understood this, it can be confirmed if you understood this single line, including these equal to signs. Including these equal to signs. So this all is equivalent to this. Everyone. Everyone. Guys, maximum will be gamma S because this is not density. Guys, all these are density of soils. Okay, this is not density of soil, this is density of solid. So the lighter material, water and air is not here. This is density of only this thing. This is density of only this thing. So of course it will be maximum, yaar. Of course it will be maximum, yaar. Okay, of course it is maximum, yaar. Because here the lighter materials are not coming, and when soil is coming, maximum will be saturated because no air. Minimum, this will be less because it is everywhere is air, and this will be least because beyond weight is also acting. And why equal to sign? Because gamma T is a general case. Gamma T can be saturated, gamma T can be partially saturated, gamma T can be gamma dry. Have you understood? Have you understood? Have you understood? Please, 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 give me a sonona. Give me a sonona. Come on, please. Come on, please. Come on, come on. Come on. Come on. Okay. Now, what is specific gravity? Guys, specific gravity is gamma of a substance with respect to gamma of water. Suppose I am saying the specific gravity of a substance of this marker is 2. Suppose I am saying specific gravity of this marker is 2. That means the density of this is 2 times more than water. Suppose I am saying the specific gravity of this specs is 3. Then that means the density is 3 times, or this unit weight is 3 times more of water. Suppose I am saying the specific gravity of this mic. Specific gravity of this mic. Okay, from which my voice is coming. Specific gravity of this mic is 1. Specific gravity of this mic is 1. That means density is same as water. Suppose I am saying specific gravity of my brain is 0.5. Suppose I am saying specific gravity of my brain is 0.5. Okay, that means my brain's density is half of water. Understood? Arey, upar chale ja bhai. Okay. Okay. So now this is specific gravity of solid. It is represented by GS. It is represented by G. Guys, in whole soil mechanics, wherever G is used, it is maximum time this. And this value is around 2.6 to 2.7. Okay, that is specific gravity of solid. So G or GS, it is gamma of solid with respect to gamma of water. And GM is specific gravity of soil, complete soil. Okay, so that is density of soil. Gamma T is a general case upon gamma W. Which will be bigger, GS or GM? Which will be more, GS or GM? Which will be more? Tell me. Which will be more? Of course, GS will be more. Denominator is gamma W, but gamma of solid will be more, na? Gamma of solid will be more, na? Correct? Correct? Okay. Chalo, ये तो अभी करा ही था. We have just done this, so leave this. Now relationship of all parameters. Now this is water and this is water. Okay, this is water. This is water. Now see, relationship of all the things. First of all, guys, I'm not going into deriving in this. Weight of solid is equal to total weight upon 1 plus W. Small w is water content. Okay. If you divide this by volume, this by volume. So this by volume is gamma D, weight of solid by volume. And total weight by volume is gamma T, 1 plus W. So this is one more. Another is N is equal to E upon 1 plus E. And E is equal to N upon 1 minus N. Okay, sir. Got it, sir. Now, SE is equal to WG. Okay. SE is equal to WG. ओके नाउ और भी कुछ थे क्या, और भी कुछ थे क्या? मैं अपने फर्रे भी लाया हूँ, कुछ बच्चों का छूटना नहीं चाहिए, कुछ भी बच्चों का छूटना नहीं चाहिए। ओके और वो गामा टी वाला तो है ही, उस पर अभी आऊँगा। दैट गामा टी इज देयर, इन दैट आई विल बी कमिंग। ओके इन दैट आई विल बी कमिंग। अच्छा इसके बाद एक और है, दैट इज गामा डी इज इक्वल टू 1 माइनस NA, NA इज परसेंटेज एयर वॉइड, इंटू G गामा W अपॉन 1 प्लस WG। ओके नाउ अच्छा एक है गामा T इज इक्वल टू G प्लस SE इंटू 1 प्लस E इंटू गामा W। सो व्हाट इज गामा ड्राई? फॉर गामा ड्राई S इज इक्वल टू 0, so that is G into 1 plus E into gamma W. What is gamma sat? Gamma sat S is equal to 1. Gamma sat S is equal to 1. So G into E upon 1 plus E into gamma W. Okay. Now, what is gamma submerged? What is gamma submerged? Gamma sat minus gamma W. If you take LCM, the final expression will be this. Okay. Now, in this case, guys, SE is WG, na? SE is equal to WG. So, gamma T is equal to G. Instead of SE, I can write WG. Okay. Gamma W upon 1 plus E. So, it is gamma T. Here G common, gamma W common, 1 plus W into 1 plus E. And let me tell you, all these formulas are equally valid for density also. All these formulas are equal, like if I divide by gravity. So, it is rho T. Divide by gravity there. So G plus SE 1 plus E into rho W. Similarly here rho D, everything same rho W. Rho sat, rho W, everything is same there also. Yes, that is also. The total volume is volume of solid plus volume of voids. Volume of voids is this. Okay. Now one formula that might be you have not done. See guys, everyone. This is a soil. This is a soil. Okay, and same soil is here, exactly same. Now here the voids are filled with water. All voids are filled with water. This is water. So what is the density? Gamma sat is equal to G plus S. S is equal to 1. Is equal to this. But now here, guys, all the voids are filled with kingfisher beer. Okay, this is filled with beer. Beer की जो भी spelling होती है. Guys, gamma sat here will be same or different? Gamma sat here will be same or different? Please tell me. Please tell me. Please tell me. Please tell me. Okay, it will be different because weight will be different. Suppose these voids are filled with jam, Kisan jam. Okay, Kisan jam. So weight will be more, na? Weight will be more. So here the density is more. I have done the derivation many times. This is G plus E into G dash. Here the formula is different, where G dash is specific gravity of this liquid. And this question has been asked in GATE in 2 marks. This question has been asked in GATE in 2 marks in effective stress chapter, where water is filled with, voids of a sand bed. Voids of a sand bed are filled with seawater. And seawater has a different density than water because salt is there. So it has a different density. Okay. It has a different density. Okay. So it is asked in 2 marks. Everybody give me yes or no. Have you understood? ओके MSQ करोगे? चलो करो, देखता हूं कौन कौन फोड़ता है इसको। एक MSQ से 4 चीजें हमारी सॉल्व हो जाएंगी भाई। 4 things will be solved. And be ready guys, some more interesting numericals will be coming. Everyone, every commando, everyone, Let me see who will do it fastest. Okay, let me see who do it fastest, guys. I want to see. Please tell me. Please tell me. Everyone. Come on, come on, come on. Come on. Okay. See, what is rho d? Rho d is rho t into 1 plus w. Okay, so what is rho t? 2.1 upon 1 plus w, that is 1 plus 0.15. So what is the value of rho d? What is the value of rho d? Is it coming? Is it coming 1.826 or this? Find the value of rho d. Now second is degree of saturation. So SE is equal to WG. Okay, so W is given, G is given, but S and E is not given. Okay, so rho D, leave this. Do it from here. Rho D, I just told you, it is rho T upon 1 plus W. So rho D is known. Okay, rho T is from here known. So find W from here. Is W coming? What is W coming? Tell me the value of W, someone. Someone please tell me the W. W batao. Swapnil, Prince, Mayank, Sarvan, MVS, Saugata, Swapnil. What is the W? What is the W? .15. Okay. So W is 0.15. So from here, S, W we got, है ना? So E is also not known. W, अच्छा water content तो दे रखा है यार. Water content तो दे रखा है. Water content दे रखा है. Do this, apply not this formula. Gamma rho D is equal to G rho W 1 plus E. So G is also given 2.7. Rho W is 1 gram per cc. Okay, from here find out the value of E. From here guys, the value of E you are getting as 0.48. Okay, then apply N is equal to E upon 1 plus E. You are getting this. You are getting this. Okay, S E is equal to WG. So E is known now, W is known, G is known. So S you are getting as this. Give me yes or no. From one question, 4 things are cleared. From one question, 4 things are cleared. Everyone please give me yes or no. Everyone please give me yes or no. Everyone please. Okay. So the water content of fully saturated soil is 100%. So S is 1. Water content in fraction is also 1. So that means E is equal to G. So the void ratio is equal to the specific gravity. Void ratio is equal to specific gravity. Got it? Okay. So these all I'll be giving you in assignment. Now let me go to the very important topic from which last 2 years the questions are asked. Okay. So let me go here, water content determination. So there are various methods, and guys in last 2 years the questions have been asked from this. So most chances the question is asked from oven drying or picnometer, but we do all. Okay. So what is oven dry? Let me tell you here, guys. Come on. Okay. This is a soil. Let this be moist soil. Let this be moist soil having weight W1. Now this moist soil is put in oven put it oven for 24 hours and the temperature maintained is 105 to 110 degrees Celsius. So when we put it, we got a dry weight, that is W2. What is small w? Small w is water content. Small w is water content, that is weight of water. So what is removed? What is the difference? W1 minus W2, that is weight of water na. Upon what is left, that is weight of solid. I hope you understood. What is the difference here? W1 and W2. What is the difference here? W1 and W2. The difference is weight of water. Okay. And whatever left here is, that is weight of solid, W2. Got it? Got it? Got it, guys? Now the question comes here. In MSQ, a statement-wise question may be expected. Then why it is 105 to 110 degrees Celsius? Okay, not 150, not 125. Because, guys, if we heat it more than that, if we heat more than 105 or more than 110, then the structural water is lost. And the structural water is lost, so that means the properties of soil is changing. Now, sir, what is structural water? What is structural water? Let me tell you guys, there are 4 types of water. Structural, adsorb, capillary, and one is gravity water. One is gravity water. Now, what are those waters? Let me tell you, leave this. Adsorb water is, suppose it is a dry soil. What is adsorb water? Suppose there is a dry soil. Okay. Now in that dry soil, you put it at atmosphere. Like in Chennai. Chennai is so much humid. Visakhapatnam, I have taught there also in offline. There is a lot of moisture. Okay. So guys, everyone, if we put a dry soil in atmosphere, and from atmosphere it is absorbing the water. Okay, if you put a dry soil in atmosphere and from atmosphere it is absorbing the water. So whatever the water is absorbed from the atmosphere, that water is called adsorbed water. Now what is capillary water? Guys, suppose this is a soil, ground level, and in this ground level, suppose this is water table. Now this water table goes in small voids above. Okay, due to capillary action. Okay, due to capillary action, the water goes above in the small void. That is capillary water. What is gravity water? That rain comes. Okay, and water is going down from the soil. Water is going down from the soil. Water is going down from the soil and it goes to the water table. Water is going down from the soil. Water is going down from the soil and it goes to groundwater table. That is gravity water. Now this is used for irrigation because this is going down. It is not in the root zone. This is going down. So this is used. Capillary water is used by the irrigation people. Okay. Now this is, you understood, water absorbed from the atmosphere, water stuck in the voids, water going down to the groundwater table. This you understood. Now what is structural water? That water which is attached to the crystal lattice, of soil. Okay, and it is attached to the water with molecular level. If that water is evaporated or it has removed from the soil, okay, if that water is evaporated or that water is removed from the soil, guys, in that case, the property of soil changes. The whole property of soil changes. Okay, so my friends, structural water should not be gone because it is attached to the crystal lattice. Whole property is going to change if this is removed. So that is why we heat it only up to 105 to 110 degrees Celsius. That is why we heat it up to only 105 to 110 degrees Celsius. If we heat more than that, then structural water is lost. Even guys, in organic soil, we heat it only up to 60 to 70 degrees centigrade. Why? Can anybody tell me? Let me see who is the intelligent person here. Let me see who is the intelligent person here. Let me see who is the intelligent person here. Tell me please. Tell me please. Guys, why in organic soil it is heated only to 60 to 70 degrees centigrade? Why in organic soil it is heated to 60 to 70 degrees centigrade, not more than that? because in organic soil, if we heat more than 62 to 70 degrees centigrade, then guys, organic compounds oxidize. Okay, if we heat more than that in organic soil, organic compounds oxidize. And we are thinking that W1 minus W2 is weight of water, but actually there it is not weight of water, it is some compounds also oxidized. Okay, due to that. Give me yes or no? Give me yes or no? Okay. Now guys, there is a torsion balance method. Of course, not very important, forget. That is, I am going very fast here. In this, what's happened? Heating and measuring of weight is done simultaneously. Here what we are doing heating, then we are taking the sample from the oven, and we are taking the sample from the oven, and then we are measuring. Okay, so when we are taking the sample from the oven and then we are going to measuring, we are taking the sample from oven and then we are going to measuring. So in that process, might be some water is absorbed. Okay, in that process might be some water is absorbed. Okay, so my friends, in torsion balance, heating and weighing is done simultaneously. Okay, so here in sand bath method, what we do? We put the soil here, we put a stove, and after some time weight is measured. So whatever is the reduction, that is weight of water. Whatever is the reduction, that is weight of water. Suppose here the weight is W1, total weight of tray and soil. Here it is W2. So whatever is the reduction, weight of water, and that is the weight of solid. This W2 minus weight of tray is weight of solid. Okay. Now calcium carbide method is, this is CaC2 plus water. It gives calcium hydroxide and acetylene gas. Okay, it is calcium C2, water is 4, okay, oxygen is 2, balanced. So guys, when we add calcium carbide to the water, this is formed. This is acetylene gas. So when we throw calcium carbide to soil, so soil has water. When we throw calcium carbide to soil, soil has water. So that water is reacted with calcium carbide. And acetylene gas is formed. By measuring the acetylene gas in a chamber, PV is equal to nRT, not required for us. By measuring the acetylene gas, we can find out that how many number of moles of water is there. Because 1 mole of acetylene gas is produced by 2 moles of water. So suppose we got 25 moles of acetylene gas. So that means 50 moles of water is there. And 1 mole of water is 18 gram. So 50 moles will be 50 into 18. Okay. So now this is the radiation method, guys. Why I'm going fast here? Because that is not very important. So what is here? It is a radioactive material here, generally cobalt. Okay, generally cobalt. And guys, this radioactive material emits the radiation. So when it emits the radiation, okay, when this radioactive material emits the radiation, okay, so that is a detector which is receiving it. Okay, then there is some programming fit in the computer. So if this much rays are coming, of this much we can see, this much wavelength, this much intensity. So this is the water content of this soil. Okay, so we are throwing some rays, and we are from detector we are getting some rays. Now the properties of these rays will be defining the water content of this. Okay, by some computer programming. Similarly, unit weight can be find out. So if these rays are coming like this, then unit weight is this. If the intensity of these waves are this, then unit weight is this. So unit weight and water content, everything can be done from the pre-established relations. Now again guys, important are only two, water content and pycnometer. Now let me go into the pycnometer. This is a pycnometer. This is the empty weight of pycnometer. In this empty weight, we put the moist soil. This is not dry. We put moist soil. And remaining soil, this is moist soil. And remaining soil we filled with water. We put here moist soil. Okay, this is the moist soil we put. And remaining thing is we filled with water. And in one more case, we filled everything with water. Okay, we weighed this. And one more case, we filled everything with water. In one more case, we filled everything with water. We measured that also. Okay, so different weights are W1, W2, W3, W4. Now what is water content? Water content is weight of water. Water content is weight of water by weight of solid. Correct? Water content is weight of water by weight of solid. Got it? Everyone. Okay. So, water content is weight of water by weight of solid. Now, what is weight of water? Okay. Weight of water can be, see how I am writing the weight of water. Everyone. It is, weight of water is from W2, if I remove W1. From W2, if I remove W1. So, weight of pygnometer is removed. So, that is only weight of soil. From that, if I remove weight of solid. From that, I removed weight of solid. From that, if I remove weight of solid. So, that is only weight of water. From W2, if I remove W1. From W2, if I remove W1. So, from removing from W2, if I remove W1, the only moist soil is removed. Moist soil is left. From that moist soil, if remove the weight of solid. So, only weight of water is there upon Ws. Correct? Everyone, please give me yes or no. Everyone, please give me yes or no. Now, guys, see W4 if I want. From W3, if I want W4. From W3, I remove this solid part. Volume of solid into density of solid. So, density of solid is G into gamma W. Guys, this you have to learn it here. Come on. G is equal to G of solid is gamma S by gamma W. So, what is density of solid? G times of gamma W. Anything density is G of that material into gamma W. So, W3, how I will reach W4? From W3, I removed solid. From W3, I removed solid. Okay, from this part, I removed solid. Weight of solid is volume into density. And how much solid I removed, that much water if I add. How much solid we have removed for the same volume, I add water. How much solid we have removed, add that much water, then it will be W4 na. Then it will W4 na. So from here I am not doing into Vs gamma W. If you find, take Vs gamma W common here. Take Vs gamma W common here. It will be W3 minus W4 upon G minus 1. Guys, in single step here. Take Vs gamma W common here, it will be G minus 1. And here it will be W3 minus W4. Now put that Vs gamma W here. Okay, because Ws is, what is Ws here? What is Ws here? Vs into gamma W na? What is the weight of solid here? What is the weight of solid? Weight of solid is volume of solid. Volume of solid into density. Okay. What is the weight of solid here? Volume of solid into density. Okay. So put that Vs gamma W there. Put that Vs by gamma W there. Whatever you obtain from here, put it there. The final expression will be water content is equal to W2 minus W1 upon W3 minus W4 into G minus 1 upon G minus 1. Give me yes or no. Derivation I have done, just calculation has to be done, guys. Derivation I have done, just calculation has to be done. Give me yes or no, guys. Soon we are coming some beautiful numericals and that grain size distribution curve. Have you got it? Everyone? Please? Everyone, please? Okay. Okay. Now, guys, one important thing I want to see, those who are my students, they will be knowing this. Why it is written air sucked out? Those who are my students, they will be knowing this. Because this nobody teaches. Why this is written? What is the significance of this in this derivation? What is the significance of this in this derivation, guys? Come on, everyone. Come on, everyone. What is the significance of this in this derivation? Everyone, please. Everyone, please reply. No, Sandeep. No. Okay, Srishti Sarvan. Okay, no, Shravan. No, Swapnil, let me tell you. Very beautiful concept, guys. Guys, if air is something, na, then you have to write here weight of air. Sorry, if air is something, na, then you have to add one more thing here, volume of air into gamma W. But this is 0 due to that thing. This is 0 due to that thing. Understood? Guys, how you find go to W4? W4 you found, from W3 you removed solid. From W3 you remove solid, add water. If air is something, so that much air is also filled with water here, na? So that much also has to be added, na? So that is why it is air sucked out here. Otherwise this step is not fine. Give me yes or no. Yes, MBS. Understood, guys? Understood? And this is dry soil. So G here, that I'm writing only the G. Okay, I'm not going in the derivation of this. W4 minus W1 minus W3 minus W2. That is the value of G. That is the value of G. Okay? Okay? Guys. So guys, now please tell me, should I increase my speed or it is fine? Like the session, guys. Come on. Like the session. Come on. My speed is fine, or should I increase my speed or decrease my speed? Please tell me increase, Akshay is saying. What about others? Everyone's answer I want. Everyone answer I want. Come on. Increase, decrease, or it is fine as it is? Increase, decrease, or it is fine as it is? Okay, so some people are saying, so little bit increasing, not more, little bit increasing. Okay. Okay. So guys. Now the measurement of unit weight. So what is unit weight? Weight by volume. So guys, in this whole measuring the weight is not very difficult. Measuring the volume is difficult. Measuring the weight is not much difficult. Just measure the weight. Okay, volume is difficult. So what do we do here? We insert the core cutter. Inside the ground level, we insert the core cutter. Okay, we rotate it and we come out. Okay, so whatever is this much weight we have find out, or let it be whole core cutter is inserted. Okay, now we rotate it. So guys, this way we come out with this. We throw the soil here, so we can find out the weight. Okay, and density will be the weight of the soil which we come up with core cutter upon volume of the core cutter, because whatever is the volume of the core that only we have taken only that is the volume. Now guys, can you please tell me then why it is not suitable for cohesionless soil? Why it is not suitable for cohesionless soil? Come on. Okay. Okay. Okay, yes. Because if it is cohesionless soil, so when we are rotating and we are coming up, it will not be there. Harvin. Red Bull. हाँ दो. हाँ भैया रेड बुल दे दो ना तो. अच्छा वही दे दो प्रीटर 4 दे दो. नहीं हाँ वही 4 दे दो. हाँ Okay. Yes, because if it is cohesionless soil, then when we are rotating and we are coming up, when we are rotating and we are coming up, so all soil will slip. Okay. When we are rotating and we are coming up, so all soil will slip. Okay. बिल्कुल बिल्कुल आप जा सकते हैं soil. No worries. Okay guys, let's move. Now this is sand replacement method. This is also done in highways also. Okay. This is also done in highways. So what we do here, from the ground, we cut the soil. We cut the soil and we take it here. We take it here. So what is the weight? What is the weight here? W1. What is the weight? What is the weight here? W1. Now how to find the volume? How to find the volume here? Let me tell you. Guys, this is a thing. Okay, and here it is something cone. Now this is a container and here the sand is there. Suppose initial volume is Vi. Okay, now we put it here and there is a lever also. We open the lever, sand comes down. Okay, so sand comes, is filled here. And here also a cone like. Now after, once we throw the soil here, so the volume now is Vf. Now first of all things are why it is empty like cone. Okay, from here, why it is empty like cone? Can anybody tell me this concept? Or only you know the things like formula and all? Why it is cone? Okay, why it is not a simple structure? Why it is a hollow cone here? Why it is a hollow cone here? Can anybody tell me this? Can anybody tell me this? Why it is a hollow cone here? Because if it is not cone, okay, then guys, when I'm opening and cutting the shutter, okay, here is the shutter. When I'm opening, if this is not cone, then whole soil has to be cut, yaar. Whole soil has to be cut. And that requires a large area. If it is cone, then only small area has to be cut. Swing. Very easy. Very easy, guys. Very easy. If it is not cone, then whole area has to be cut. If it is cone, then easily it can be done. Okay. If it is cone, then easily it can be done. That is why it is cone. So what is gamma? Gamma is weight by volume. Okay. So what is volume? So volume of soil plus volume of cone is equal to Vi minus Vf. Okay. Volume of soil plus volume of cone. This is soil, this is cone. This is soil, this is cone. So Vi minus Vf. Okay. Vi minus Vf is volume of soil plus volume of cone. So from here find the volume of soil because this is known, this is known, this is known. Find here the volume of soil. Okay, so from here you can find out the volume of soil. You can find here, from here, find the volume of soil. Have you understood? Have you understood? Okay. Now same thing is done in this water displacement, water balloon method. Okay, one is water balloon method. Here for finding the volume now, instead of this we put a rubber membrane here and put the water. Okay, instead we put a rubber membrane here and put the water. So water will be coming and we can find out how much is the volume of this pit. Okay, Vi is the initial volume of that jar in which sand is there. And Vf is the final volume. After filling the sand here, the volume will be reduced, na? Okay. Now water displacement method, guys. Suppose this is a soil. Okay. Suppose weight is W1. Now this soil, which weight is W1, is coated with paraffin wax. Okay, this is coated with paraffin wax. This is coated with paraffin. Now weight is W2. Okay, now weight is W2 after paraffin wax. Now this is a container. This container is filled with water. This container is filled with water. Now we put it here. Okay, now this soil which is coated with paraffin, now this soil which is coated with paraffin, I have put it here. So guys, what is gamma? Gamma is weight by volume, so weight is W1. Now volume displaced from here. Okay, so from here some volume is displaced V. From here some volume is displaced V. Okay, so V is the volume of soil plus paraffin. V is the volume of soil plus paraffin. Actually we want gamma is weight by volume, so weight of soil and volume of this only. So this is total volume minus volume of paraffin. So weight of paraffin is W2 minus W1 upon gamma paraffin. Okay, so this is guys volume of soil. This is the total volume minus volume of paraffin. What is volume of paraffin? Weight of paraffin upon gamma of paraffin. Give me yes sir. Everyone please. Everyone please. Please my dear friends. Please my dear friends. Please my dear friends, everyone. Everyone. उनको वीडियो टीम को समोसे दे दी दे दिया ना सबको जो चाहिए था ओके मेरे को 1-2 घंटे में चलो अब तो मैं लंच ही दे दूंगा थोड़ी देर बाद ठीक है आप अपने लिए भी ले आए ना समोसे बाकी दोनों तीनों के लिए ठीक है ओके ओके guys, can you tell me why the Leaning Tower of Pisa is tilted? Why the Leaning Tower of Pisa is tilted? Tell me. Just coming in 2 minutes. So guys, some surprise to you. The biggest. Somebody asked me ना in क्या कहते हैं उसको when I was taking SOM कि सर हाईवे नहीं दिख रहा. And if you have seen this, what is this? 18 Jan Highway Engineering Marathon. So whatever you wish na, we fulfill it that. Okay. So Highway Engineering will be 18, and guys, who will be taking it? The champion himself, the commando himself, Mr. Okay.
Hi guys. So एक बार फिर से welcome you all. Yes, please. All right. So how are you all, everyone? So what we will be doing is we'll be covering the highway engineering. Sir, English में चल रहा था ना session?
English.
Okay. So how's everybody? Missed me or not? All right. So I'll be here with you on 18th of January. Be ready with the highway engineering, whatever notes you want to make. And what I'll be doing for you is I'll give you each and everything. This is going to be very different marathon. I'm not saying that I'm going to do something different from other faculty members of this organization or any other organization. I'm going to do something different from what I do, right? So I will be taking this marathon, highway engineering marathon, like my paid classes, okay? So I don't know, maybe not a lot of people will be happy with this. Obviously, I'm not talking about students, but yeah, what I'll be doing is I'll be teaching each and everything here and won't be leaving even a single topic, right? So I am going to give you whatever I have in my head related to highway engineering, and I'll be solving questions as well with you. So be ready with that, and I hope you all have seen that movie Bhag Milkha Bhag. So there is a dialogue also कि ये आपके जीवन की आखिरी रेस भी हो सकती है. So इसका जो रिप्लाई था वो यही था कि मैं दौड़ूंगा भी वैसे ही. So it's similar to that only, that I'll be taking this highway engineering marathon as if this is the last marathon of my life. Okay, so that's what I have to say. Rest, if you have any doubts, you can also ask me regarding highway engineering or fluid mechanics or environmental engineering or maybe irrigation engineering if you have any. Or if you're preparing for engineering services examination, then energy environment if you want, that also I can do for you. And ICT also I can do for you. And what else? Current affair I can do for you. That because I like, I really love current affairs and everything. I'm very into this geopolitics and everything. So whatever, if it is required, just let me know. I'll be doing that for you. Okay. I can't see a lot of hard science today that I usually used to see when I was taking regular classes, right? But yeah, I'll be back soon, and I'll start with 18 January of highway engineering. Cool? All right. So we have the champion of the champions back with us, Abhinav sir, and he will be coming here, and he is taking the class after turning AC on at 22 degrees. I don't know why. And also he is in half t-shirt. That's the power, the energy of the ninjas, brother, elder brother.
सर बता दिए ना आपको.
सर मैंने बता दिया.
करंट अफेयर भी मांग रहे हैं सर बच्चे.
और मैंने सर ये भी कह दिया है कि ये जैसे भाग मिल्खा भाग में डायलॉग था कि ये जीवन की आखिरी रेस हो सकती है, तो वो कहता है कि मैं दौड़ूंगा वैसे ही. तो मैं भी बोला, मैं कहा ये लास्ट मैराथन होगा, बिल्कुल ऐसा इस उसका साल का बिल्कुल लेंगे भी वैसा ही,
मचा देंगे.
18 जनवरी. और ये ऊपर से नीचे तक भी आई कैन सी लाइक मचाया हुआ है. ईच एंड एवरीथिंग इज बीइंग गिवन बाय द फैकल्टीज टू यू. सो प्लीज टेक द एडवांटेज. एंड सर if I am wrong, correct me. Last year and last year we have started this trend of taking the marathon. I mean full-fledgedly. Especially we used to come from houses to this office, and because of that only we saw a lot of toppers talking about this in our podcast. Spotlight में.
बिल्कुल.
Right? Okay guys, so I'll take your leave sir now, and thank you for showing the love. I'll see you again on 18th of Jan again. Okay sir.
Okay, thank you sir. So लीनिंग टावर ऑफ पीसा का आंसर आया किसी को? कहाँ गया लीनिंग टावर? कहाँ गया? Why लीनिंग टावर ऑफ पीसा is tilted? बता दो. Why लीनिंग टावर ऑफ पीसा is tilted? And guys, let me tell you one more thing, that in Pisa na, Red Bull, no, this is not, this is the Red Bull, some sasta Red Bull, but this tastes better than Red Bull. And guys, let me tell you, Red Bull doesn't give me energy. Okay, Red Bull doesn't give me energy. I like that taste, or that taste of cough syrup and whatever, I like that taste. I didn't find that energy something. Might be you will have it first time, might be some energy, but personally I didn't find any energy from Red Bull. आजकल एक और नया वाला आया है, ऐसा वाला कुछ, इसका टेस्ट उससे भी अच्छा है. Okay, guys, let me tell you that in Leaning Tower of Pisa na, this is not only one tower that is tilting. Okay, this is not only one tower that is tilting. There are other towers as well. Okay, there are other towers as well which are also tilting. There are many towers, and of course you all are correct. That is tilting due to the differential settlement. But what that is the case na, what everyone is knowing that is tilting due to differential settlement. But my answer is, first of all guys, in soil settlement is not difficult. Settlement is not big problem, because if this whole tower settles like this, if this whole tower settle like this, it is perfectly fine. No, okay, it should not be much settlement that second floor becomes the basement, but it is fine. That is why settlement is not a very big problem if it is in the limits. But differential settlement will do what? It will cause a movement also. If this is the P now, so this will cause a movement. That will cause additional stress. So differential settlement is here difficult, is more challenging, not the settlement. Now guys, I want to ask you that why it is differential settlement? Why it is differential settlement? Why the differential settlement is happening there? Tell me. Why the differential settlement is happening here? Guys, because the land there is marshy and that uneven properties or the strength or the void ratio of the soil, even with very going 20 meter away, the property is different. 30 meter away, the property is different. 40 meter away, the property is different. So property of one side of the Leaning Tower of Pisa and the property of other side is different. So settlement of this is different, settlement of this is different. That is why it is differential settlement. Have you got it? Have you got it? Give me yes or no. Tell me. Tell me. Do this question. Let me be little below. चलो क्या है in a soil three phase diagram. Okay, 1/4 of volume is filled with air. This is air. 1/3 is filled with water. Okay, in a soil three phase diagram, 1/4 of the volume is filled with air, V by 4. 1/3 is filled with water, and this is solid. So V minus V by 4 plus V by 3. So V minus 12, 3 plus 7V by 12. Okay, so this means this whole is 7V by 12. Okay, and this will be 5V by 12. है ना? Now, what is the void ratio? What is the void ratio? Volume of voids by volume of solid. So volume of voids is 7V by 12 and this is 7V by 12. So 7 by 5 कहाँ गया? A option. Understood everyone? Okay. Now the next property, what is relative density? It is represented by RD. It is represented by ID. It is represented with DR. Okay. So DR, here also I'll tell you a very interesting concept. It is E max minus E upon E max minus E minimum. Okay. Okay, E max is the maximum void ratio. E minimum is the minimum void ratio. So E max is 0.91 if nothing is given. E minimum is 0.35. Now E max is cubical array. E max is cubical array and this is prismoidal array. Okay, and E is the actual void ratio. E is the actual void ratio. Now, my friends, why it is 0.91? Let me tell you, the cuboidal array is like this. When we place the soil exactly over each other, then it is the maximum void ratio. Now, yaar, see the feeling, guys. See the feeling, guys, everyone. When we put soil exactly over, that means we don't want to occupy the voids, yaar. Because if you want to occupy the voids, okay, if you want to occupy the voids, okay, if you want to occupy the voids, then how you should be making? Now see, you should be putting the second layer here like this, exactly at the gap, so that the voids can be filled. You can put the layers exactly like this. Okay, you can put the soil exactly in the gap, so that you can occupy the voids. Okay, if you are putting exactly over, you don't want to occupy. You don't want to occupy the voids. So you are putting exactly here at the gap. This is prismoidal array, guys. Minimum void ratio 0.35. Everybody on the comment box, give me yes or no. Everybody on the comment section, please give me Yes or no? Everyone, please. Have you understood? Have you understood? Everyone? मेरी आईडी से ही कमेंट हो रहा है. Have you understood, everyone? Done? Okay. Now, guys, this is relative density, but what is the feeling here? What we have to do with this? Okay. What we have to do with this? Tell me. What we will be doing this? Guys, if relative density is more, that means E is less. That means it is densely packed, more degree of packing. So if the two soils are compared, then with larger relative density means void ratio is lesser. And when void ratio is lesser means that is more powerful soil, more strength, more degree of packing. If dr is less, that means E is more. That means it is loosely packed soil. Guys, can you please tell me from all the concepts that I have told you till now, that it is more significant for coarse grain soil or fine grain soil? Come on! If it is more significant for coarse grain soil or fine grain soil, tell me. Tell me, please. It is more significant for coarse grain soil, guys. Fine grain soil, even if dr is less, E is more voids, still you cannot say it is poor, na? Still you cannot say it is not having strength, na? Because might be more voids. Might be voids are more, but still they can have attraction. Due to cohesion. Everybody give me yes or no. So this property is more towards the coarse grain soil. Everyone. Okay. Now, moving ahead, the index properties of soils are those properties. Index properties are those properties which are defining the engineering properties. Okay. Which will be helping us for finding out the engineering properties of the soil. Now, let me tell you the first property we are seeing, the grain size distribution. First, grain size distribution is important for what? Coarse grain or fine grain? Coarse grain soil. I want to know, guys, what soil I want. I told you at the beginning. This is a soil. Of all particles are almost same soil. This is good soil. A soil is good. Or this is also a soil. Here medium particles are also there. Here small particle, but this small is also in the coarse grain range, not in the fine grain. Small particles are also there. So which soil I like, A or B? Which soil you want, A or B? B, that is, guys, a well-graded soil. Well-graded soil. This is a poorly graded soil. Because in void, there are not smaller particles that can be filled in the voids. Smaller particles are not there, guys. So it can be filled in the voids. So here the density will be less. Voids are more. Strength will be less. Okay. So to this, I want to check for coarse grain soil. Because in fine grain soil, even this can be good because of cohesion. So that is why this property is more related to coarse grain. We put different sieves. Bigger sieves, smaller sieves, then smaller, then smaller, then smaller, then smaller, like this. Bigger, smaller, like this. Different size of sieves are present here. In these sieves, we throw the soil. Generally 1 kg, 1000 gram. And after throwing the 1000 gram, we shake it. mechanical shaking or by motor, electrical shaking, anything, or manually shaking, anything. So we shake it. After 15 minutes of shaking, we take all trays and measure the weight. So of course here is the bigger particle. After measurement, whatever here it is smaller, 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 like this. Got it? Okay. So guys, generally the bigger, then smaller, then smaller, then smaller. Generally we have these number of sieves, 11 number of sieves. Okay, these are 11 number of sieves. And let me tell you a beautiful data, guys. If you understood this, everything will be cleared. Okay, total soil is 1000 gram. Total soil is equal to 1 kg. Guys, understood this? A beautiful explanation. 1000 gram. Okay, everyone, please see here. Okay, ready? Okay, so we take 1000 gram of soil, and when we are taking 1000 gram of soil, those soil, guys, this session will be only live, don't miss it. Don't miss it, guys. Okay, PDF I will provide. This session will be only live, guys, don't miss it. Now if the soil is 1000 gram, and in 1000 gram there are different sizes, 80 mm, 20 mm, 10 mm, these total 11 sieves, and at 11 different sieves we get different weight. Okay, at different sieves, by shaking it, when we are shaking it and when we are measuring it, so after measurement we get different weight. So first is cumulative weight. This is 100, this is 150. Now see how I will play with this. 160, 200, 400, 700, 800, 850, 865, 875, 900, and this is 1000. Okay, now percentage cumulative weight, total weight is 1000 gram na? Total weight is 1000 gram. So what is the 100 percentage of 100 of 1000? 10%. 150 of 1000 is 15%. 160 of 1000 is 16%. 200 of 1000 is 20%. 400 of 1000 is 40%. 700 of 1000 is 70%. 800 of 1000 is 80%. 850 of 1000 is 85%. Okay, 865 is 86.5%. 875 is 87.5%. 900 is 90%. 1000 is 100%. Get it? Now percentage finer will be, if it is 10, how it is 90%, I'll tell you later on. 85%. Okay, here it is 84%. Here it is 80%. Here it is 60%. Here, guys, now for next 10 minutes now. Now for next 10 minutes, if you understood every word that is coming from my mouth, for next 10 minutes, if you understood every one word that is coming from my mouth, guys, you will be getting the complete knowledge of this topic. For next 10 minutes, don't miss anything. For next 10 minutes, don't miss anything. Now, guys, sir, how it is percentage final is 90? We understood this calculation, guys. Sir, I also know how to add. Sir, I also know how to do the percentage. I also know how to do 100 minus. I know this, sir. But how it is 90% final, sir? I'm not getting that, sir. How it is 85% final, sir? Sir, I'm not getting that, sir. How it is 84% final, sir? I'm not getting that, sir. Okay, so I'll tell you. I'm here, guys. I'm here for that only. Okay, I'm here for that only. Okay, see, everyone, if this is diameter 80 mm and above 80 mm 100 gram particle is there, actually this will not be soil. More than 80 gram will not be soil. If it is 100 gram above 80 mm, if it is 100 gram above 80 mm out of 1000, Total 1000 soil is there. So how much is lesser? If 80 out of 80 mm above is 100, so 900 is finer. If 100 gram is retained, that means 900 gram is going below. So 90 is smaller, so 90% finer. If above 20 mm, 50 is retained. 50 is retained. 50 is retained here and 100 is already retained. 100 is already retained, 50 is also retained. So that means 150 is more than that, having diameter more than this. 100 is already retained, 50 is retained, so that means going below is 850 gram. Going below is 850 grams. So that means percentage final is 85%. That is how we have done this. That is how we have done this. Understood? Now, I want to make a column. Okay, I want to make a graph. First of all, sir, why it is semi-log? It is arithmetic scale, 100, 90%, 100% final, 90%, 80%, 70%, 60%, 40%, log D. Sir, why it is semi-log? Because guys, diameter is a huge variation. Okay, percentage final is only 0 to 100. But diameter is 80 mm to 75 micron. 75 micron. That is a huge difference. In 10,000 difference, guys. 10,000 times. So diameter is ranging huge, guys. Okay, from 0.075 mm to 80 mm. 0.075 mm to 80 mm. So there is a huge variation. So counter that huge variation, we use log. Guys, because see, this is 1, this is 10, this is 100, this is 1000, this is 10,000. So this is a huge variation. But if I make it log, leave this. If I make it log, 1, 2, log 1003, log 10,000 is 4. So variation is now reduced. So that is why when there is a huge variation, then we use the log scale. Now, guys, generally, diameter decreasing there, bigger diameter here and decreasing to right hand side. Not any here bigger diameters, then smaller diameters. Okay, then smaller diameters, then smaller, then smaller. Okay. Now guys, can you tell me this graph will be increasing or decreasing? This graph will be increasing or decreasing? Can you tell me? Can you tell me? This graph will be increasing or decreasing? Of course, this will be a decreasing graph. Of course, this will be a decreasing graph because for bigger diameter, percentage particles smaller will be more. From bigger diameter, percentage particles smaller will be less. From lesser particles, small particles, percentage finer will be smaller. For even smaller particles, the percentage smaller will be lesser. Bigger particles will be more percentage now, which is smaller than that. Understood? Understood? Like, let me show you what is D60 here, which 60% particles are finer, 4.75 mm. 60% and sorry 2 mm. From 2 mm 60% particles are finer. From below 2 mm 60% are finer. Okay, so 60% finer below 2 mm, log 2. Similarly, 30% particles are finer than 1 mm. 30% particles are finer than 1 mm. So this is log 1 mm, and from log 1 mm 30% particles are finer. Correct? Correct? Like this is the graph. Now guys, it is dn means diameter below which n% particles are finer. Diameter below which n% particles are finer. Okay, suppose what is D32? What is D32? What is D32? D32 is diameter below which 32% particles are finer. D32 means diameter below which 32% particles are finer. What is D86? Diameter below which 86% particles are finer. What is D20? 20%, the diameter below which 20% particles are finer. So from here, guys, there is a CU and CC. D60 by D10 and CC is D30 square by D60 into D10. This I'll be telling you. Wait. First of all, guys, there may be a data when 60, 30 and 10 is not coming. Okay. there may be a data when 60, 30, 10 is not coming. So in that case, we have to do interpolation. But let me tell you, that question has never been asked in GATE, has never been asked in AC. They will take such a values that 60, 30, 10 will be coming. Although there may be values where 60, 30, 10 is not coming. In that case, you have to do interpolation, but that is not asked in the exam. Okay. Okay, Pranav, done. My commitment. Now, CU is this, CC is this, coefficient of uniformity, coefficient of curvature. Now, everyone, please don't study this here. Whatever I am teaching here, please study that. Okay? Whatever I am teaching here, please study that. Percentage final and log D. Don't see this. Now the graph can be like this. Okay? The graph can be like this. Okay, the graph can be like this. Okay, and the graph can be like this. This is C, this is A. Now guys, beautifully I will explain this. You will learn this for lifetime. So any graph can come. Any graph can come from our experiment. Now see the A graph. A graph will be well-graded soil. Bigger particles, some medium particles, okay, some medium particles, and some small particles also. Okay, some small particles also to fill all this. This is well-graded soil. This is very good. Okay, how I know that this is a well-graded soil? A, because A graph is horizontally expanding very high. A graph is horizontally expanding very high. A graph is horizontally expanding. So this here, the data is here also, 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 data is here also. So we have bigger particles also, smaller also, or more smaller also. Okay, so we have a huge range of sizes there. Okay. Now, for this orange one, this orange one is AB, is a gap graded soil. Gap. Because from this diameter and this diameter, below which the percentage final is almost same. Okay, n%. So this diameter also, the smaller, let this n be 20%. So from this diameter also the percentage final is 20%, and for the small diameter also the percentage final is 20%. So from both these diameters the percentage final is 20%. So that means there is no particle here. Guys, suppose I say in my company the teachers who are earning more than 2 lakh per month are 30 teachers, and the persons who are earning more than 3 lakh are 30 teachers. That means between 2 lakh and 3 lakh there is no teacher. I'm again saying, the person who are earning, or the person whose salary is less than 2 lakh is 30. The person whose salary is less than 30 lakh is 30 teachers. That means there is no person between 2 lakh and 3 lakh. So from this diameter the percentage final is n%. This diameter the percentage final is n%. There is gap grading. Okay. So there are particles this and this. Okay. So particles are here and particles are here. So that means the big particles are here and the small particles are here. But the medium, that in that range the particles is not there. That is gap. And the C soil is having particles only in this range. There is no particle here, there is no curve here, there is no curve here, there is no curve here. So the C is poor. Okay, C is poor. So all particles are of same size. All particles are of same size, poor. This C is also called as poor, poorly graded soil, or uniformly graded soil. Uniformly graded soil is poor. Uniformly graded soil is poor. But guys, all these things is for coarse grain soil. All these things is for coarse grain soil, because because in fine grain soil you cannot call it poor. In fine grain soil you cannot call it poor on the basis of, you cannot call it poor on the basis of diameter. Gradation is not important there. Gradation is not important there, guys. Okay, so either you draw the graph or find this, or guys, if find the CU and CC range. Okay, no need to draw the graph. Take the soil, make this table, because this table is for one data. For other data table will be different. Okay, so draw this data and find the value of CU and CC. Draw this data, find the value of CU and CC. Okay, from this table, find the value of CU and CC. If CU and CC is in this range, it is well graded. If for sand CU greater than 6, CC is this, it is well graded. For gravel, if CU greater than 4 and CC is this, it is well graded. Otherwise, if only one single, if both the datas are matching, then it is well. Otherwise, it is not well. It can be poor or it can be uniformly. There is no such values to distinguish between them. Okay, or either make a chart. Okay, everybody please put a heart sign. Yaar, Josh is reducing. Yaar, come on. Your Josh is reducing. Everyone please. Everyone please. Come on, Sosham Josh यार. Come on, make it 100 people. अभी एक बार आप भी शेयर करो यार. अब मैं भी व्हाट्सएप पे तो लगा दिया आपने. एक बार आप भी शेयर करो भाई. एक बार शेयर करो आप लोग. मैं भी शेयर करता हूं. मैं भी शेयर करता हूं. शेयर कर दो एक बार. कैसे व्हाट्सएप में तो कैसे करते हैं? लिंक से या मेरे फेसबुक पे है क्या शेयर? कैसे पता चलेगा? फेसबुक पे शेयर है क्या? फेसबुक पे है शायद, है ना? मैंने कुछ ना कुछ, मेरे को आता नहीं है. मैंने कुछ किया था तो हो गया था. मैंने कुछ वहीं से यूट्यूब से लिंक कुछ किया था तो हो गया था. लेकिन अब इसको शेयर दिख तो रहा नहीं है यार. दिख तो रहा नहीं. इसको स्टेटस पे कैसे लगाएंगे? उसके नहीं है भाई. अच्छा है. अब इसको स्टेटस पे कैसे लगाएंगे? एडिट पोस्ट, सेव पोस्ट, पिन, टर्न ऑफ लिंक है. स्टेटस पे लगाने का नहीं आ रहा. शेयर करता हूँ योर स्टोरी. हाँ ठीक है, शेयर कर दिया योर स्टोरी पे. अब मैं यूट्यूब पे गया और यूट्यूब पे जाने के बाद शेयर का बटन दबाया, है ना? इंस्टाग्राम पे कभी यूज़ नहीं करता पर देखते हैं. इंस्टाग्राम पे आप मेरे देखना भाई. इंस्टाग्राम पे कैसे शेयर करते हैं यार? इंस्टाग्राम पे कैसे शेयर करते हैं? मैंने शेयर द बटन दबाया यूट्यूब से. आई पुट ऑन शेयर बटन फ्रॉम यूट्यूब एंड देन देयर आर सो मेनी ऑप्शंस. ओके, देयर आर सो मेनी ऑप्शंस. जैसे आई गो टू यूट्यूब, देन आई डू दिस शेयर. सो व्हाट्सएप आई हैव शेयर्ड, फेसबुक आई हैव शेयर्ड, ब्लूटूथ से तो नहीं. अब इंस्टा पे गया मैं. इंस्टा पे क्या एक ही लोग को शेयर करूं? सबको नहीं कर सकते एक ही बार में. सबको नहीं कर सकते क्या? तो मेरे को फिर इंस्टाग्राम पे जाना पड़ेगा क्या? एक बार आप लोग भी शेयर कर दो यार. मैं इंस्टाग्राम पे गया, फिर इंस्टाग्राम में जाने के बाद क्या करूं? शेयर पर जाइए एंड स्क्रॉल द ऑप्शन वेयर देन यू. हाँ, इंस्टा तो आ गया ना, पर इंस्टा में कैसे करूं? बायो क्या होता है मेरे को क्या पता यार. प्लस दबाया, इंस्टाग्राम पे गया मैं. इफ आई गो टू इन इंस्टाग्राम, मैं वो यूट्यूब छोड़ो. इफ आई गो टू इंस्टाग्राम देन आफ्टर दैट, इफ आई गो इन इंस्टाग्राम देन आई हैव टू ऐड प्लस बटन. प्लस एडिट एज स्टोरी, न्यू पोस्ट करना है कि स्टोरी करना है, यही नहीं पता. मैं चाहता हूँ उसमें बच्चों को लिंक भी मिल जाए ना. यू कैन सी रील प्लस आई हैव पुट एड स्टोरी और हाईलाइट्स. पर कैसे करते हैं हाईलाइट? चलो को 2 पोस्ट हो रखी हैं, किसी ने डाल रखी है पहले की. अब न्यू पोस्ट पे करता हूँ. चलो अब न्यू पोस्ट पे करूँ. तो वही तो आ नहीं रहा, रुको जोशी सर को बुलाता हूँ। जोशी सर वो तो इंस्टाग्राम के एक्सपर्ट हैं। जोशी सर एड स्टोरी, एड ए स्टोरी सर। चलो वो उनको आएंगे, वो बताएंगे। अभी तो फ़ोन ही नहीं जा रहा उनका। अच्छा रुको, मैं गया नहीं, मैं ये कह रहा हूँ कि ये इंस्टाग्राम पे मेरे ये आ रहा है, इसमें कौन सा बटन दबाना है? मैं फर्स्ट टाइम यूज़ कर रहा हूँ। कौन सा बटन दबाना है? ये कौन सा? मैंने इंस्टाग्राम यूज़ नहीं किया भाई। प्लस दबाना है, ये दबाना है, ये दबाना है। प्रोफाइल, ये प्रोफाइल दबाया। अच्छा रुको सर, जोशी सर कहाँ पे हो आप? मतलब मेरे को ये बताओ, इंस्टाग्राम पे मेरे को सेशन शेयर करना है तो कैसे करते हैं? हाँ रुको, मैं लाउड स्पीकर में कर रहा हूँ ना बच्चों के सामने। हाँ अब मैं इंस्टाग्राम खोलूँ अपना?
हाँ जी,
मैं अभी लाउड स्पीकर कर दिया है ना। अभी पहले मैं लिंक कॉपी कर लूँ यूट्यूब से।
हाँ सर, लिंक आप YouTube से कॉपी कर लीजिए।
हाँ
उसके बाद आपको ऊपर अपना वो दिख रहा होगा फोटो, उस पे आप क्लिक करेंगे तो आप अपना स्टोरी लगा सकते हैं।
एक
उस स्टोरी के अंदर आपके पास ऑप्शन आएगा लिंक को पेस्ट करने का।
रुको 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 रुको, मैंने लिंक कॉपी कर लिया। अब मैं इंस्टाग्राम पे गया तो नीचे होम आ रहा है, सर्च आ रहा है, प्लस आ रहा है और एक रील।
टॉप लेफ्ट कॉर्नर पे क्या है सर? आपकी फोटो आ रही है टॉप लेफ्ट?
हाँ आ रहा है, योर स्टोरी आ गया। हाँ
है ना, उस पे क्लिक किया।
हाँ
क्रिएट आ रहा होगा उधर एक लेफ्ट में।
सेटिंग का वो गोल सा सेटिंग का साइन आ रहा है।
नहीं, लेफ्ट में क्या क्या ऑप्शन है सर? लेफ्ट साइड में,
लेफ्ट साइड में तो जब
बता देता हूँ ना अपने, मैं भी इंस्टाग्राम खोल लेता
मैंने योर स्टोरी खोल दिया है ना
सर। ये यहाँ पे लेफ्ट में क्रिएट लिखा है, डबल ए के बाद।
अच्छा ऐड स्टोरी किया, हाँ क्रिएट किया, हाँ क्रिएट किया, क्रिएट किया।
बस क्रिएट पे जाइए, ऊपर एक सेंटर में एक स्माइली वाला
हाँ
साइन बना होगा,
आ गया,
उस पे क्लिक कीजिए।
आ गया। वो लोकेशन मेंशन ये सब आ रहा है। लिंक,
इसमें एक सर लिंक आ रहा होगा,
लिंक कर दिया।
बस उसमें लिंक पेस्ट कर दीजिए।
लिंक पेस्ट कर दिया। डन कर दूं?
डन कर दीजिए।
डन हो गया।
बस अब वो शेयर हो जाएगा, 24 आवर्स तक रहेगा।
कुछ सेंड वेंड का मतलब एक बार चला गया होगा ना मतलब?
बस अब सब देख सकते हैं आपकी स्टोरी को। जो स्टोरी खोलेंगे उनको आपका लिंक मिलेगा।
ठीक है ठीक है ठीक है।
ओके सर।
ओके ओके भाई, देख लेना हो गया क्या? गाइज यू कैन चेक माई इंस्टाग्राम, सो आई हैव टू टेल यू माई इंस्टाग्राम ID ना। व्हाट इज इंस्टाग्राम ID, हाउ टू फाइंड दैट? you will lose your followers. स्टोरी हो गया शायद, कुछ कुछ तो हो गया है। हो गया है, हो गया। मेरा इंस्टाग्राम ID में आपको कैसे बता? अभिनव नेगी 1989 है शायद। प्रोबेबली माई इंस्टाग्राम ID इज अभिनव नेगी 1989। रील्स नहीं देखता मैं, आई एम माई सेल्फ अ रील। माई इंस्टाग्राम इज पब्लिक प्राइवेट, आई डोंट नो, आई डोंट नो। ओके लीव, लीव। चला गया होगा यार शायद, कुछ गया तो है स्टोरी में। इट्स समथिंग गोल गो राउंड राउंड इट इज कमिंग, समथिंग राउंड राउंड इट इज कमिंग। चले, लेट्स मूव फॉरवर्ड। Okay. So this guys, for fine grain analysis na, hydrometer and pipette have never come in gate, so I'm not doing that. Okay, might be for engineering services we can do that after gate exam, but hydrometer and pipette have never come in gate. Okay, now let me tell you one more thing guys. For fine grain soil you cannot do grain size distribution. Guys आप भी शेयर कर दो यार एक बार इंस्टाग्राम पे, आप भी प्लीज शेयर इट guys. You can all do a favor to me, you can all do favor to me. Okay, now ये चेयर भी दे रखी है यार, इसका कुछ सदुपयोग करें। ओके, नाउ टेल मी वन थिंग। क्या पूछ रहा था मैं? शेयर कर दिया? सोफिया हैज डन इट शेयर, ओनली सोफिया हैज डन शेयर, नॉट अदर्स, नॉट अदर्स। I was asking something. I forgot, yeah. Huh. Oh, yes. Guys, fine grain soil cannot be done from this. Fine grain soil cannot be done from grain size distribution. Can you tell me the reason? I also never don't use. Can you tell me why fine grain soil cannot be done? Like here. Prashant has done. Shaumik has done. Mayank has done. Okay. तो फिर खड़े हो जाता हूँ, आप लोगों के दोस्त आ रहे होंगे, फिर वो कहेंगे कि मास्टर बैठा हुआ है. Yes, guys, with fine grain soil we cannot do this because in fine grain soil the particles join together and make a flock. In fine grain soil, the particles join together and make a flock. Okay, and once it makes a flock, then guys, it is not coming below and we are thinking it is a big particle. Okay, we are thinking it is a big particle, but actually it was a small particle. Okay, we are thinking it is a big particle, but actually it was a small particle. So fine grain soil doesn't give result in sea analysis. Therefore, we do hydrometer and pipette, but not required for gate. Do this. No, not this one. This one. Please. Percentage cumulative weight, percentage finer. Gravel, anything which is coming more than 4.75 mm is gravel. Sand, anything which is 0.075 mm is sand. And this is 0.002. Okay, anything which is above 4.75, that is gravel. Okay, anything which is more than 0.075 mm is sand. Anything which is more than 0.002 is silt. Okay, in my YouTube it is only showing 13 likes, but leave. Do it. So guys, here the percentage is 40% gravel, which is retaining here will be gravel now, which is retaining here will be sand, which is retaining here will be silt. So this is 40, this is 90, this is 100. So percentage final is 60, this is 10, 0. What you want to find? Cu is equal to D60 by D10. So what is D60? 4.75. What is D10? 0.075. From here it is more than 60 now. 63, 67 something is coming. Yes, 63.33. Have you got it? Have you all got it? Okay. So now, yes. Guys, do you know, have you seen this first of all? Okay. Have you seen this dotted line? And if you've seen, I want to check that who can tell me that why this is dotted line. For others, I am telling you. Guys, the volume is dry, solid air. So it is VD. This is this case. Green case. Then I am drawing the orange case here. In orange case, solid will be same and some water is coming. Okay, but volume is still VD. Actually, soil is not dry, but volume is VD. After that, I am doing this blue case. This is shrinkage limit. WS, this is small ws, small wp, small wl. That is this blue case. The blue case is all is filled with water. It is not dry, but volume is equal to V dry. So it is constant. Once you add water, air is replaced by water, but volume is constant. It is not dry, but volume is constant. After that stage, I take any other stage. Now, after this, if I add water, volume start increasing. So here it is constant, then it is increasing after shrinkage limit. WP is plastic limit, after which soil behaves as a plastic. Means here if you draw the stress strain diagram, it is like this. And WL is a liquid limit, after which soil behaves as a liquid. Here you draw stress strain diagram, so it will be like this. Without stress, strain is happening. Here at constant stress, strain is happening. Ws is the shrinkage limit, Wp is the plastic limit, Wl is the liquid limit. Wp is the stage after which it behaves as a plastic. At constant stress, strain is happening. W is the liquid limit after which soil behaves as a liquid. Here it is solid stage, semi-solid stage. Why it is dotted line here? Can anyone tell me? Yes, Ravan. Excellent. Yes, Ravan. Excellent. Why it is dotted line? Because actually, suppose this is solid particles. Suppose this is solid particles. This is solid particles. Okay, so what we are thinking, when it is actually total filled with water, when it is total filled with water, then volume start increasing. When it is total filled with water, then volume starts increasing. We are thinking like that. Theoretically, it is correct. Theoretically, it is correct. When it is filled with water completely, when it is filled with water completely, when it is filled with water completely, then the volume start increasing. But might be some space is left and water is not having the way, the roads are not there, so it can go here. So even with full, without prior to full saturation, this is prior to full saturation, volume start increasing because that particular void is cannot, the water is not getting the way to go there. So initially even it starts increasing before that, but yes, theoretically it starts after the shrinkage limit. Now guys, shrinkage limit can be defined in two ways. One is, it is the highest water content. It is the highest water content at which if reduction in water content is done, volume is same, Vd. It is the highest water content at which volume is Vd. Out of all these, volume is Vd, it is the highest water content. And guys, can you tell me what is saturation here? What is saturation here? What is saturation here? What is saturation here? 1. There is no air, na? Whatever is here is also saturated. Volume of water by volume of void is 1. Here also volume of water by volume of void is 1. Okay. So, guys, in all the cases, saturation is 1. So, it is the minimum water content at which saturation is 1. So, Ws, shrinkage limit, is the minimum water content at which saturation is 1. And Ws is the highest water content at which volume is Vd. Everybody on the comment section. Everybody on the comment section. Give me yes or no. Come on. Guys, break will be at 1:45 p.m. Break will be at 1:45 p.m. Okay. So understood. Guys, this WP, na, plastic limit, is sometimes also written like this. WL is the liquid limit, is also written like this. Okay. Now, this is IP, plasticity index. Okay, this is IP. This is WL minus WP. Okay, liquid limit minus plastic. This is the region of plastic region. Okay, this is the plastic region. WL minus WP. मैं रिचार्ज करा रखा है ना आज डाटा का ज्यादा. Liquid limit minus plastic limit. That is IP. That is IP. Okay. If IP is more for clay. For clay, the plasticity index is more. It is more plastic. It is more plastic. Everyone got it here? Everyone got it here? Please give me yes or no. Guys, first chapter here will be around 30 to 35% of complete marathon. First chapter here is approximately 30 to 35% of complete marathon. Okay. Now see. How to find, okay, bilkul mahang. Now, how to find the liquid limit? How to find out the liquid limit? Please see. Everyone. There is a cascade apparatus in which we put the soil. There is a cascade apparatus in which we put the soil. Leave. There is a cascade apparatus. Acha, it can be done. There is a cascade apparatus in which we fill the soil. Now, from a groove we cut it from here. Okay, from a groove we cut it here. This becomes empty. Okay, now we rotate it like this, and this will go above and come back. We rotate it like this. This will go above and come back. This we rotate like this. This go above and come back. Okay, this will go above and come back. Okay, now after, when it is hitting here in the standard rubber pad, it is hitting, so this is coming closer, it will attach. It is coming closer, it will attach. So we find out the number of blows when it is attaching. So this graph will be, this is not percentage final, this is percentage water content. This graph will be like this. This is log n. N is the number of blows, at which it is attaching to the number of blows at which it is attaching the soil is attached. Okay, now water content is more. When water content is more, even less number of blows will help. When water content is more, even with less number of blows, it will come together. And when water content is less, it is dry, so more number of blows are required. Okay, more number of blows are required, correct? So this graph is like this. This log n2. Okay, this graph is like this, straight line. Okay, the slope of this straight line is called as flow index. The slope of this straight line is called as flow index, IF. What is IF? Y2 minus Y1, W1 minus W2 upon X2 minus X1. That is log N2 by N1. Log N2 by N1. Okay, Y2 minus Y1 upon X2 minus X1. Log N2 minus log N1. So it is log N2 by N1 ho gaya. Okay, so what this IF represents? This IF represents, larger is the flow index, lesser is the shear strength. If IF is more, shear strength is less. If IF is more, shear strength is less. नहीं, अरविंद को बोल दो कि 1:45 पे डोसा लेके आना है. IF is more, shear strength is less. IF is more, shear strength is less, correct? Okay. Now, friends, till now I have not discussed what is liquid limit here. What is liquid limit? I have not told. From where? From here. अरे बंद हो जा. Where is liquid limit? Where is liquid limit here? Okay. So, guys, when the number of blows are 25, now go to log 25. Go to log 25. Here the water content is liquid limit. Okay, when it is log 25, here the water content is liquid limit. Give me yes or no. Give me yes or no. चलो जल्दी बताओ. चलो चलो चलो. Okay, so this is one way, or at 25 number of blows, whatever is the water content, that is liquid limit. Now guys, how many points are required to draw a straight line? Tell me, how many points are required to draw a straight line? Tell me. How many number of points are required to draw a straight line? 2 points. Now guys, there is an empirical method also. From single point. Okay, from 1 point you can find out. From 1 point you can find out, that is WL is equal to WN upon N upon 25 की power X. Where the X is a constant 0.086 0.086 to 0.121. Okay, and Wn is the water content at which the number of blows are n. So only with one point. Wn is the water content at which n blows are required. From here you can find out. This is empirical, guys. Okay, but IS code, this can be asked in 1 marks in gate. This can be asked in 1 marks in gate. IS code doesn't follow the Casagrande apparatus, doesn't follow this empirical method. Okay, what IS code does? IS code follow the cone penetration method. IS code follow the cone penetration method. There is a weight, there is a standard cone attached. Okay, and that standard cone of standard weight is attached and this is dropped. So here is the soil field. Okay, here is the soil field, at which point the soil is going 25 mm below. That water content is liquid limit. I am saying there is a standard cone attached at standard height. There is a standard cone attached at standard height. And from that cone, the water, it is put in the soil. It is put in the soil. Okay, now from that cone, it is put in the soil. Now, my friends, everybody, this cone will be penetrated somewhere here, sometimes here, sometimes here, sometimes here with different water content. If water content is more, it will be going downward. If water content is less, it is going here. If water content is medium, it is going here. More slurry the soil will be, more it is going downward. More slurry the soil it is, more it is going downward. Okay, so less water content, it will go less. Add the water content when it is going 25 mm. Add the water content when it is going 25 mm. Then, guys, that water content is called as liquid limit. That water content is called as liquid limit. Everybody give me yes or no. Everybody give me yes or no. Everybody give me yes or no. Please. Please. Have you understood? Have you understood? Tell me. Everyone got it? चले चले आगे. Okay. Now plastic limit. Guys, do you want 10-minute break? What is your lunch time? Can you please tell me all? What is your lunch time? Lunch time is 1 or 2 or any time. Can you please write down? Either your lunch time is 1, your lunch time is 2, your lunch time is 1:30, or it is any time, okay, or it is hostel or whatever. Please tell me. Otherwise, we can take it early also. Shaumik is 2 p.m. Sama is 2 p.m. 1, 2. 1. Anwar is 3:30. 1:30. Okay. Then let us take a 5-minute break. 5-minute break we can take, na? 5-minute break can we take? Then after that we'll take 1:45. 5-minute breaks can we take? But it is you have to do promise that you will come back. You have to promise that you will come back. Okay. Will come. Resume at no dot 1:45 तो डोसा ब्रेक है. Okay. Okay. So we'll resume at 1.5 or 1.7. Okay. Okay. चलो, कहाँ गया मेरा चप्पल? Okay. I'm here. Here. I'm here, guys. So 3 questions I have asked in the comment section. Can E greater than 1? Yes, E greater than 1. Okay, perfect example is it may be possible in a bentonite clay. Okay, it is possible in a bentonite clay. Yes, E can be greater than 1. In a bentonite clay, I told you solid is this and total is voids. Now, most active is montmorillonite mineral, least active is kaolinite mineral. In kaolinite mineral, the bonding is hydrogen bond. In montmorillonite mineral, the bonding between the particles is the water bond. Okay, and van der Waals forces, the van der Waals forces here, and in light it is the ionic bond. Okay. Now, okay guys, keep sharing. फटाफट से बता दो बच्चों को कि आ गए वापस हम. Okay. Now plastic limit is the water content at which when we are making the 3 mm thread starts fumbling. Okay. When we are making the 3 mm thread and it starts fumbling, that is water content is plastic limit. Usually one more thing, guys, when void ratio is more then liquid limit of that material is more. Guys, this is very important. This is a very important concept. From here hundreds of objective questions will be done. From here hundreds of objective question will be done. When void ratio is more if void ratio is more, that means that soil has a lot of voids, so very much water content, a large quantity of water will be poured in it for making it fully saturated. Okay, just to make saturation is equal to 1, large amount of water is added on it. Okay, and then further more water is added. Water is added to make it plastic and liquid. So if void ratio is more, then it can accommodate more amount of water. That means liquid limit will be more. And when liquid limit will be more, it means void ratio is more. That means settlement will be more. Soil which has more void will be having more settlement. Of course, shear strength will be less. And of course, if more voids for same size of soil. Okay, we are comparing clay. Okay, so if there are 5 clays, then in the clay which has more voids will be having more permeability. Okay. Now guys, of course, when we put the water, this is the Sinclair limit. Consistency index is WL minus W upon WL minus WP. Okay, so this is WL minus W. Liquid limit minus plastic limit can be called as plasticity index. Liquid limit minus plastic limit can be called as plasticity index. Got it? Liquid limit is W minus WP. This W is natural water content, whatever is the existing condition. Maybe 0, maybe more than WL, maybe less than WS, maybe between WS and WP, maybe between WP and WL, whatever is the condition. And let me again write it. What is IC? Liquid limit minus W upon WL minus WP. Guys, can you tell me what is the value of IC plus IL? IC is consistency index and liquidity, IL is liquidity index. Then after that, I'll be telling you the physical meaning of this. What is the value of IC plus IL? Come on, sale wise here. Samaraya, Swagata Gangli, Mayank, Jia. What is the value of IC plus IL? What is the value of IC plus IL? The IC plus IL value is equal to 1. Okay, when you add this, then W1 minus WP is denominator. W minus WP plus this, so it will be 1. Now what is the physical meaning of this? See here. Let me again write what is the value of IC. Here, please be little sight. IC is WL minus WL minus WP. What is IL? IL is natural water content minus plastic limit WL minus WP. Now here guys, everyone please concentrate. What is the physical meaning of this? Okay. I'm here. Okay, my mobile is running behind. Now guys, if IC value is less than 0, if IC value is less than 0, that means if IC value is less than 0, that means the natural water content is greater than liquid limit, because this is always positive, na? This is always positive. If IC is less than 0, that means this W is greater than liquid limit. So soil is in liquid state. So this is of significance. If IC is less, that means W is more. So W is more, it is liquid. So as IC increasing, so W is decreasing. Okay, so as IC is increasing, W is decreasing. W is decreasing, so it is going to the dry. And in dry, it becomes brittle. At dry, it becomes brittle. And it is reverse here. So that is the significance. That is the significance. Everyone got it? Please tell me. Okay. So toughness index is IP by IF. Okay, the toughness index is IP by IF. So toughness index is IP, that is WL minus WP upon IF, that is the flow index. Okay, that is the flow index. And let me tell you more further, not directly I am writing the result. Okay, IT is also equal to log of shear strength at plastic limit upon shear strength at liquid limit. So shear strength at liquid limit is 2.7 kilonewton per meter square. Shear strength at liquid limit is 2.7 kilonewton per meter square. So if toughness index of a soil is more, that means shear strength of that soil at plastic limit is more. Okay, if toughness index is more, that means the shear strength at plastic limit at the soil is more. This we have already done. Okay, thixotropy is the gain in strength. Suppose a soil is there, okay, and we throw that soil. Okay, suppose a soil is there and we throw that soil. Now guys, everyone, please see, due to its self weight of soil, due to the self weight of soil, it is going in the dense state, na? Due to the self weight of soil, it is going into the dense state, na? And when it is going into the dense state, it gains its strength, it gains its density. So strength is regained. That regained property is thixotropy. Sensitivity is the unconfined compressive strength of undisturbed soil when it is not disturbed upon the remolded soil. If more is the suppose sensitivity is 1. Suppose sensitivity is 1. That means the strength when it is not disturbed, remolded means disturbed. Both are same. So that is insensitive soil. So either we are disturbing this or we are not disturbing this. Okay, either we are disturbing this or not disturbing this, strength is same. So that means insensitive. Okay, that means it is insensitive soil. Activity is IP. What is IP? Liquid limit minus plastic limit upon percentage of clay particles. Okay, now this is the property. This is asked in various state exams. So I have made a table for this. In last 8+ years, whatever the questions, theoretical questions are asked, I have made a table from this. From this, you can be solving. Okay, so now guys to chapter 2, that is soil classification. Let me again tell you, my Telegram group is Civil by Abhinav sir. The marathon series is going on. The quiz of this session, guys, you can get it here. After the class now, in the description box, you will be finding a quiz after the marathon. So you will be getting that quiz. Okay, if you want to one-to-one counseling session with our expert, you can click here. And guys, if you want to download app for the free notes of all technical and non-technical subjects, you can click here. So everything is in the description box. Okay, everything is in the description box. Okay, now this is the marathon by ma'am. It will be tomorrow 10 a.m. and this is serving. Time is changed. Now this will be at 6 p.m. Sunday. Okay, the time is changed for this. This will be 6 p.m. Sunday. Shall we move? Shall we move, guys? Classification of whole soil. Now I will explain in this page. I will explain in this page. The whole classification chapter will be, and I will be telling you in this single page only. In this single page, I will be telling you the complete soil classification in one single page. Okay. Everyone, please let me know. Ready? In one single page. In the description box, it is there, na yaar. In the description box, the quiz is there. Okay. Ready? All of you, please confirm. Only because when you give me the permission, I'll move forward. Only when you give me the permission, I will go move forward. Ready, guys, for the soil classification chapter? I'm again telling you, in one single this क्या कहते हैं इसको, in one single slide I will tell you all the things. Okay. 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 Now let me tell you some name. When it is G, it is gravel. When it is S, it is sand. Now for S we have used for sand. For silt we cannot use S. Okay, so silt we will be using M. For clay it is C. For organic it is O. For peat it is PT. In suffix, guys, W means well graded, P means poorly graded, M means silty, C means clay. Liquid limit is less than 35, it is low compressible. 35 to 50 it is intermediate compressible, and greater than 50 it is high compressible. It is very obvious. It is very obvious. When liquid limit is low, that means void ratio is less. When liquid limit is low, that means void ratio is less. When liquid limit is low, that means voids are less. That is why in less water it becomes liquid, na? So it is low compressible. When liquid limit is more, that means more voids are there. It can absorb more water. So it is more voids means high compressible. In this single slide, guys, I will teach the whole second chapter. Also, guys, I want to make my own line. Na? Here some beautiful questions also will be doing. Here some beautiful questions also we will be doing. I want to make my own table. Okay, don't see this question. See this chart. Here it is liquid limit. Here it is IP. Okay, there is an equation of A line. What is A line? See this. A line is IP in single page, guys. I will teach that single page, whole chapter, and I'll do it like this that you will never ever forget. And 3 questions I'll be teaching, and from that 3 questions, every question can be solved. Okay. So A line is equal to IP is equal to 0.73 WL minus 20. So this is IP, this is WL. So A line will be like this. When liquid limit is 20, it is 0. Okay. Then here it is 35 and here it is 50. Now you cram the things like as it is. I will explain this. The people says that above A line it is C. Below A line it is it is silt or organic. Below A line it is silt or organic, M or O, M, or it can be O. First question, why above clay and below silt? Those who are my student can reply. Why above A line? This is A line. Okay, this is A line. Why above line clay and below silt? Why above A line it is clay and below silt? Can anyone tell me? Can anyone tell me? Please. Please. Guys, because clay is more plastic. Yes. Because clay is more plastic. So y-axis of clay will be more. Y-axis of clay will be more. Y-axis of clay will be more. It is more plastic. Okay. It is more plastic. Okay. So IP value is more. So it is CH, CI, CL, LLIIH. So H reason I told you. Everything I am explaining logically. Okay. Why it is above clay? Because clay is more IP value. Clay is more plastic than silt. Why it is H there? H there? Because when the liquid limit is more, voids are more, it is highly compressible. When liquid limit is less, voids are low, it is less compressible. Now second question in your mind, sir, if it is below, okay, we find it, if it is above it is clay, if it is below it is M, but how you will distinguish between these two? First thing, if nothing is mentioned in the question, you should always be writing ML, MI, MH, not OL, OI, OH. By default, if nothing is mentioned, we'll be writing the answer as silt. Practically, in real life, how you will distinguish? You have to distinguish is on the basis of visual classification. Organic soil is dark in color. Even if visually you cannot distinguish, then guys, both the soils you heat, MO, MO, MO. In organic soil on heating, the large weight is reduced because not only the water but also organic compounds also oxidize. Not only the water but also organic compounds oxidize. Okay. So, my friends, this is how you classify. But in exam, in theoretical exam, if nothing is mentioned, we'll be writing answer as M. Got it? Okay. Now, moving forward. Sir, how you will find that point is where? Let me tell you. Suppose the question is asking WL is 40 and IP is 17. Name the soil. So, A line is IP is equal to 0.73 WL minus 20. So it is 0.73. WL is 40. 40 minus 20. So 20 into 0.73 is 14.6. That means the point here is that WL is 40 na. So between 35 and 50. So point is here. So on A line the point is 14.6. On A line the point is 14.6. Our IP is more 17. Our IP is more 17. Our IP is more 17, so it will be C. It will be C. And it is, the liquid limit is 35 to 50, between 35 to 50. So it is CI. Similarly, if our IP was 13, less than 14.6. Our IP is 13. Okay, so it will be M. Give me yes or no, everybody on the comment box here. Come on. Come on. Come on. Everyone. Come on, guys. Understood? Any doubt here? No. Here is the dual region also. There is a region where it is dual. It behaves as CL and ML both. Okay, 4 to 7. When IP is 4 to 7. Now, see here, guys. In single slide, I am teaching all. In single slide, the complete chapter 2. See, everyone, every commando, every champion. See, guys, anything which is less than 80 mm is soil. Anything which is less than 80 mm is soil. Correct? Now, it will be coarse grain soil if the coarse grain fraction is more than the fine grain. it is a fine grain soil if out of the soil fine grain fraction is more. Let us assume I take 1 kg soil. That means 1000 gram soil. Okay. So we can put the soil from 75 micron. So whatever is more than 75 micron is coarse grain soil, and whatever is coming below, that is fine grain soil. Okay. So if coarse grain fraction is more, it is classified as coarse grain soil, case 1. If fine grain soil is more, it is classified as case 2, that is FGS. Now in case 1 also, there are 3 cases. Case 1.1, case 1.2, case 1.3. Understand very full concentration say. Case 1.5, fines are greater than, what is first of all fines? Fines means fine grain soil. Fines means fine grain soil, that is silt and clay. If fines are less than 5%, fines less than 5% means out of the 1000 gram soil, fines are less than 5%. That means 960 gram, 970 gram, 980 gram is gravel and sand only. Only 30 gram, 20 gram is silt and clay. That is 30 gram and 20 gram out of 1000 is 2%, 3%. Okay, so more than 950 gram is gravel and sand. Okay, 20 gram, 30 gram is silt and clay. So here the names are GW, GP, SW, SP. Well graded gravel, poorly graded gravel, well graded sand, poorly graded sand. So when it will be GW, when it will be GP, when it will be SW, when it will be SP. Guys, first letter will be G if gravel is more than, yeah, guys, see, out of 1000 gram, fine grain soil is only bada. Okay, when out of 1000 gram, fine grain soil is only less than 5%, 30 gram, 20 gram, 40 gram, 2%, 3%, 4%. Out of the remaining, if gravel is more, the name will be gravel. If sand is more, S will be there. Because 95% or 96% or 97% or 98% is gravel or sand. So if more is gravel, name will be G. If more is sand, name will be S. And WP on the basis of CU and CC. I told you. If, guys, W and P is on the basis of CU and CC. I hope you remember. Kahan gaya? I hope you remember this. Kahan gaya? CU and CC. So this is how, if C for sand, CU greater than 6 and CC between 1 and 3. If for a gravel, CU greater than 4 and CC 1 to 3, it is well graded. If any of these classification is not meeting, either this or this, any one or both, it is poorly graded. So for sand, CU greater than 6 and CC 1 to 3 is well. For gravel, CU greater than 4 and CC 1 to 3 is well. Okay. Okay. Kahan gaya? Okay. So W and P is just on the basis of CU and CC. Okay. So that is how we'll distinguish GW, GP, SW or SP on the base. So G and S on the basis of gravel is more. So these two. Sand is more. So any of these two. W and P on the basis of CU, CC. Now if fines are little more than 5%, less than 12%. Suppose out of 1000 gram, 70 gram is fines. Fines means silt and clay. 70 gram is fines, 7%. 80 gram, 8%. In that case, the name is GW, GC, GW, GM, GP, GC, GP, GM, SW, SC, SW, SM, SP, SC, SP, SM. Now, This is well-graded gravel containing clay in the gravel. Well-graded gravel containing silt in the gravel. Poorly graded gravel containing clay in the gravel. Poorly graded gravel containing silt in the gravel. Well-graded sand containing clay in the sand. Well-graded sand containing silt in the sand. Poorly graded sand containing clay in the sand. Poorly graded sand containing silt in the sand. These are 8 names. Now first and third letter will be G if gravel is more than sand. First and third letter will be S if sand is more than gravel. That we have to see from the C wellnesses. If gravel is more than S and then first and third will be gravel. If sand is more than gravel, then first and third letter will be S. Simple. W and P on the basis of CU and CC. W and P on the basis of C. If CU greater than 6 and CC between 1 and 3, then sand will be well graded, else poor. If CU greater than 4 and CC between 1 and 3, then the gravel will be well graded, otherwise poor. Okay, and C and M will be judged. Either it is C or M. Either it is C or M. C on the basis of plasticity chart. If point is above, it is clay. If it is below, it is M. Understood? Now, if fines are greater than 12%, out of 1000 gram soil, 130 gram is clay and silt. 140 gram is clay and silt. 13%, 14%. Then the names are GW. Sorry. Then the names are GC, GM, SC, SM. Clayey gravel, silty gravel, clayey sand, silty sand. Clayey gravel, silty gravel, clayey sand, silty sand. Now, guys, first letter will be G if gravel is more than sand. First letter will be sand if sand is greater than gravel. First letter will be C if point is above the A line. First letter will be silt if point is, second letter will be clay if point is above the A line. Second letter will be silt if it is below. Now case 2, when fine grain soil is more, 600 gram is fine grain soil, 700 gram is fine grain soil. Then the name are CL, CH, ML, MI or MH. These are the names. Now guys, let me do you some interesting questions for you. Everyone, guys, do you know this picture? Do you know this picture, guys? Everyone? Do you know this picture? Do you know this picture? Please tell me. This Cricket World Cup 2019 final. This is Cricket World Cup 2019 final. Okay. Cricket World Cup 2019 final. Okay. And let me tell you that the final World Cup, I guess New Zealand made 243, 244. Hi, Akab. And England also made 243, 244. My God, what a coincidence. What a coincidence. Both are making same runs. Both are making same runs. In the World Cup final match, men's international World Cup final. Both are making same run. Suppose 243 New Zealand makes, England also 243. My God. Super over comes in the picture. In super over, the runs made by England and the runs made by New Zealand are same. Oh my God, can you believe this? In a world, I'm not talking of any gully cricket match. It is a World Cup final playing in the Lords. The Makkah of the World Cup, the Makkah of the cricket. And the final match is tied. And moreover, the super over is also tied. Then England is declared as the winner on the basis of more number of boundaries. According to the rule of cricket that time. More number of boundaries, so England is declared as winner. My question. Thank you. Guys, one student Akib come. He has selected in JK, SSB, PW, JE. Your tutors are really helpful. Very much respect. Thank you, Akib. Congratulations to you and your family. Okay, congratulations to you and your family. Well, good. Okay. English ज़्यादा आती नहीं अब क्या बोलूँ well बोल रहा हूँ. Good. Okay. Well done. So, guys, my question is, if number of boundaries are also tied, then what? Match tied, super over tied. If boundaries are also tied, then the 12th class mark sheet of both 11 players will be judged. Those who scored more marks in 12th class, the average of all 11 players, will be awarded the trophy. No, okay, just kidding. So guys, same tie happens in few questions, and one of the question is this, and I will give you the answer. One question is this. Do this, guys. Tie happen here. Tie happen here. Let me tell you how the tie is. I am doing solution here. 51% particles are passing through 4.75 mm sieve. That means gravel. That means gravel is 49%. 51% are passing and 2% are fine. Okay, fines is 2% and sand is remaining 49%. So it is which case? Case 1, case 2, case 3, which case? Which case? Fines is 2%, is this case? Fines is 2%, less than 5%, this case. So the name can be GW, GP, SW or SP. Now, but if gravel is more, we name it G. If sand is more, we name it S. But here both are same. Then what to do? Then what to do? What to do? Both are same. Guys, sand is given as preference. Sand is given as preference here because when gravel and sand are tie, so remaining is fines. BJP and Congress are same. BJP and Congress are same. So the independent parties are more near to this one. When gravel and sand are tie, the remaining is fine. Fine size is near to sand or gravel. The size of fine particles is near to gravel or sand. The size of fine particles is near to gravel or sand. The size of fine particles are near to gravel or sand. The fine particles are near to sand. Gravel is the biggest, na? Biggest, middle brother or younger brother. So younger brother age is more near to middle brother. Okay, so it is near to sand. So S is given as preference. So here the name will be given as S. And CU and CC, it is between 1 and 3 and it is greater than 6. So it will be SW. Understood, everyone? This question I have personally made. You cannot find it any books. Not in India, not in Brazil, not in Argentina, not in Africa, not in Jupiter. This question I made personally. This data. That is why I told you I will be doing some interesting questions in the Geotech Marathon. Okay? Okay. Now, do this. Do this. Those who forgot the formula of A line, let me write them for here. Please. Please. Percentage finer than 4.75, 60%. That means gravel is 40%. That means gravel is 40%. percentage finer than 0.075 mm, that is 75 micron. That is 75 micron. That is fines. Fines is 30%. That means sand is 30%. So which is this case? Case 1.3. Fines is 30%, na? Greater than 12%. So case is 1.3. So case 1.3, the names are GC, GM, SC, SM. Now gravel is more, so S name cannot be there. So either it is GC or GM. Okay. So what is the IP? IP is WL minus WP. It is 8%. Now A line, in A line, IP value is 0.73 WL. Liquid limit is 35 minus 20. Tell me the value of this. 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 10.95. So our IP is lesser. So here the point is 10.95. But our soil's IP. Our soil IP is 0.08 below. So it will be silt. By default we don't go for organic na. So it will be GM. Give me yes or no. Give me yes or no. Everyone please. Everyone please. Got it? Okay, so after this chapter 3 compaction will be doing. Should we do compaction now and then? Because compaction is very less, na? Then we can go to effective stress. Can we do 10 minutes more for compaction? Because compaction is very less, na? Tell me please. Compaction we can complete in 5-10 minutes, na yaar. Not very important for gate. Also, class is going slow. After break we'll do it fast. After the break the class will be going faster. That I promise you. That I promise you guys. After the break it will go a bit faster. Okay. My neck is, I cannot see. Every time you're seeing, I'm seeing like this. I'm seeing like this. The data of the question I'm seeing like this. Because I don't know. Here I slept little wrong, I guess. The pillow and all. So that is why. You have seen that Rohit Sharma in the World Cup. He has a hand like this. He's not able to hold like this. And then suddenly he do. Then he like this. Have you seen that clip? His hand was stuck. He is not able to hold the ball. Okay. Okay. Then suddenly he do two. I have to do something like this in break. Like this. Okay. आप कैंटीन में खोल दो. भीड़ है तो प्लेट यही लिया है. हाँ. सर डोसा मिला नहीं था, चौमीन लिया. ठीक है. तो प्लेट भी ले आना ना. Okay. See, everyone, chapter 3 let us do a little faster. So guys, suppose this is a soil and we apply the load. Why, first of all, why we are doing compaction? Let be little fast. Okay, this is the trailer. Okay. Okay. Guys, this is a trailer how we'll be going after the break. Okay, this chapter will be a trailer how we are going after the break. Okay, guys? Okay. So guys, now let's move forward. This is the soil. Why we are doing compaction? Why we want to do compaction? Because when we are doing compaction, then guys, volume will be decreased. and gamma is equal to density, unit weight is equal to weight by volume. If volume is decreased, then gamma will be increased. By compaction, volume will be decreasing, gamma will be increasing, gamma will be increasing. That means more strength will be coming. Gamma will be increasing, that means more strength will be coming. So when we compact a partially saturated soil, initially what air is removed. Okay, initially water is not removed, initially air is removed. Okay, that is called compaction. When all air is removed, that is actually the chapter number 6 or 7. When all air is removed, then further load is applied. Then guys, water starts going out. That is consolidation. That is consolidation. So we are not going here. We are going only in the first process. So first what happens? Air is removed. Removal of air is compaction. Removal of water is consolidation. When all air void is removed, when all air void is removed, then guys consolidation starts. So first compaction happens. It will, what compaction will be helping? Okay, large settlement will be reduced because we already compacted the soil. So large settlement will be reduced. Large settlement will be reduced. Shear strength will be increasing because density is increased. Okay. ठीक है. Random. Load carrying capacity will increase because shear strength is increased, and now volume change can be controlled because already we have compacted the soil. So this is the difference between compaction and consolidation that I told you guys. Now actually in this chapter we have to do the compaction of clay. In this chapter we have to do the compaction of clay. Guys, this is the speed that I will be taking in after the break. Okay, right now what is my speed? That will be after the break, guys. So compaction of sand is not important. Never it has been asked. It is compaction of clay. But let me tell you very briefly here. If water content is here, compaction I measured in terms of gamma D, dry density. Okay. So for clay, guys, the graph is like this. So 4 to 5% at water content, dry density is less. And apart from that, it is more. Now you may ask, sir, you are writing here water content and here gamma D. What is the link, sir? How gamma D can come in water content? How gamma D can come in water content? Guys, if a soil is partially or fully saturated, gamma D to uska bhi hota hai na. This soil has gamma D. Okay, gamma D means weight of solid upon volume. Gamma D doesn't mean that soil is dry. Gamma D doesn't mean that soil is dry. Gamma D means that when soil will be dry, what will be density? Gamma D means when soil will be dry, what will be the density at that time? Okay, that is the meaning of gamma D. That is the meaning of gamma D. Okay, so guys, at 4 to 5% water content, what happens? Bulging of sand occurs. Okay, honeycomb structure is formed, or bulging of sand occurs. Okay, it is the bulking of sand, or it is called honeycomb structure. Okay, honeycomb structure. At 4 to 5% water content, guys, particles are sucked up. A chain is formed. That is called honeycomb structure. Why this chain is formed? Why it is sucked up? Because of capillary action. Capillary suction, na? So particles are sucked and it forms void. So when void is there, that means volume will be more. When void is there, that means volume will be more. And when volume will be more, gamma D will be less. So at 4 to 5% water content, maximum effect is taken of capillary. So due to capillary suction, particles are sucked. They form voids. Okay, voids means more volume. More volume means gamma D will be less. That process is called bulking of sand, and this structure is called honeycomb structure. But guys, our property is of clay. Okay, we are dealing with clay, guys. Now, clay is important. Here I am writing gamma D. Here I am writing water content. And guys, for clay, the property is like this. For clay, the curve is like this. The maximum density is occurring OMC, optimum moisture content, and here it is gamma D max. Okay, this is called dry of optimum. This is called dry of optimum, and this is called wet of optimum. This is called wet of optimum. Now, why the curve is like this? Okay, here it is becoming flocculent structure, here it is dispersed structure, leave that. Why it is like this? Let me tell you guys. When you add water, adding water, adding water, adding water, adding water, adding water. When you add water, in that case, guys, you are adding lubricant. Okay, when you are adding water, that means you are adding lubricant to the soil. When you are adding lubricant to the soil, that means when someone is applying some compactive effort to compact it, when someone is applying the compactive effort to compact it, it can be easily compacted. Why it can be easily compacted? Because earlier the friction was there. Earlier the friction was there which was resisting it. Earlier the friction was here which is resisting it. Now when we add water, more water, more water, more water, more water, we are adding lubricant. Lubricant addition means reduction of friction. So when friction is reduced, easily the particles can compact. When friction is reduced, easily the particles can compact and they can go in a dense structure. So dense structure means they can go in a dense structure. Dense structure means more density. Dense structure means more density. Give me yes or no, everybody. Yaar. Come on the comment section. Come on the comment section, guys. Have you got it or not? Okay. Addition of more water means adding lubricant. Lubricant adding means reducing the friction. Friction reducing means easily the particles can compact and this will increase. Now, why it is decreasing there? After a certain time, guys, what happens with further addition of water? With further addition of water, guys, there is lot of water that water starts occupying the space. Water starts occupying the space which can be occupied by solid particles to go in a denser state. Already the water is there. Okay, after a certain time, already the water is there, and where the solid particles can compact, there already water is sitting, and we cannot remove water because we are studying compaction, not consolidation. We have not reached to the consolidation process yet. Okay, the soil skeleton is still in the compaction process. Water is not going out. We have not reached consolidation. So there is so much water. That after a certain time, where the particles can go, solid particles can go in a dense state, there already the water is there. Okay, that is why after that, with addition of water, guys, our gamma D is decreasing. Aata gunte na. We need the floor na. Aata gunte na. So when we add less amount of water, density is not more. If in flour, when you are kneading the flour, atta gunte to make chapati, with less water content, it cannot be go in dense state. With high water content, it cannot be go in dense state. With high water content, it cannot be go in dense state. Okay, with the optimum water, it goes in a dense state, na. With the optimum water, it goes in a dense state, na. We cannot knead the flour. Atta nahi gun sakte, kam water content mein density nahi aayegi. Zyada water content mein bhi nahi aayegi. At optimum, it comes density, na. Yes or no? Yes or no? Okay. So moisture content, how it will be varying, we have studied. Now guys, if there are two energies, E1 and E2. Suppose E2 is more. So when we are applying more density, when we are applying more energy, so gamma will be more na yaar. When we are applying more energy, so gamma will be more na yaar. Gamma will be more na, so this graph will be above that na yaar. When you apply more energy, so gamma will be more na. Okay, so here in E1, if this is OMC1, so here it will be OMC2. Okay, gamma D will be more of this higher energy, but lesser water content will be required. Guys, water is actually helping us, and this energy is also helping us to compact. And water is helping us to lubricate, reduce the friction. So when more energy is required, when more energy is done, so less water content will be required na. So this is, we have studied the compactive type of soil. Guys, there are two types of soil. Okay, there are two types of soil. One is the well-graded soil, one is poor. Which can be compacted more? Well or poor? Guys, well will be compacted better na. There are different size of particles. In well, there is different size of particles, so gamma will be more now for them. In poor, voids will be more, so gamma will be less. Give me yes or no. Now, what is zero air void line? What is zero air void line? At a particular energy, the graph is like this, E1. Okay, this is E1. Now I apply a greater energy. Okay, now greater कैसे लिखेंगे? E2. Now we apply a greater energy E2. So more density. Now we apply even a greater energy E3. So again more density. Okay, but if we take a point from here, take a point from here, 1, 2, 3. So 1 will be solid, water, air. 2 points, same water content. Both are at same water content. So water, this is 1.2, it will be lesser air. Lesser air. Suppose I take 3 point, solid will be same, water content same, air will be even lesser. This is 3. Now zero air void line or theoretically maximum dry density is this one, inverted V shape. Inverted V shape. Okay, this is inverted V shape. This is zero air void line. Zero air void line, also called as theoretically maximum dry density. Okay, theoretically maximum dry density. If we take a point from 4, then guys 4 will be like this. No air. No air guys. Zero air void. And when the air will be zero, that time the volume will be least. And volume will be least, so density will be maximum. So here guys, this is theoretically gamma d max. Derivation I have many times we have done. I am just telling you this is G gamma W upon 1 plus WG. G gamma W 1 plus WG. Okay. Now guys, there are various Proctor tests. Na? So let me tell you what is the Proctor test. Everyone see my plate is also coming. Proctor test na. Everyone, suppose first of all data से लिखा है 2.5. Okay, 944 ही है. 944.305. Okay. So guys, we have to make this graph na yaar. So at a water content, we have to find out the density. Another water content, we have to find the density. Another water content, we have to find density. Another water content, we have to find the density. Then only we'll get OMC na. And at site, to get the maximum density, we'll use OMC as the site water content. So this graph has to be drawn to find the OMC. Now what we do? We take a specimen. The volume is, for standard Proctor is 944. Now we take one layer of soil and compact it from a rammer of 2.5 kg, which is falling from a height of 0.305 meter. 25 times, 1 time compact, 2 time compact, 3 time compact, 4 time, 25 times. Then second layer, again compact 25 times by this. Third layer, again compact by 25 times. So this is compacted. And that specimen is taken and find the density. Specimen is taken and find the density. So for one water content, we get one density. Now again do the process for different water content. So we get different density. So this is how we plot. So what is the energy per unit volume? Energy per unit volume. So energy is mgh. What is m? 2.5. M into G into H. 0.305. And this is done 25 times 3 layers. So mgh for one time. But there are 25 times. And such 3 layers upon volume, that is 944. So this value comes to be 594.29 kilojoule per meter cube. This is asked in GATE exam many times. Simply this is another test with different data. Okay, so here it comes 2696.3 kilojoule per meter cube. Simply different data. So here comes the value 593.014 kilojoule per meter cube. And here it comes 2703.88 kilojoule per meter cube. Okay. Okay guys, so we'll do after this break. Okay. So after the break, now we will be doing this. After break. Okay. This is my Telegram group. Yes. Now have a break. Enjoy it guys. Okay. So complete soil plus foundation will be done. Will be done today. Okay. Telegram group is civil by Abhinav sir. This is Telegram. Okay. you can click here for the notes, for the quiz after the class. You can click here for one-to-one counseling session, and you can click here for download the app if you have not downloaded till now, for the free notes by this link which is written after Abhinav Negi. Okay. Okay. Now, thank you class will be resumed at 2:10 हो रहा है ना, 2:50 पे करते हैं. Class resume at 2:50 p.m. Okay, subscribe the channel for more such sessions. Subscribe for more such sessions, and please like the video as well. Okay. After the break, we'll do effective stress. After break, कहीं लिखा है? After break, one of the most important topic, effective stress concept plus numerical. Okay, चलो ठीक है. मैं टेलीग्राम ग्रुप भी लगा दूं. ये मेरा टेलीग्राम. अच्छा 2:50 ठीक है. ओके ठीक है. थैंक यू. हेलो. Get ready, guys. Everyone. फटाफट से शेयर करो. Hello. Hello. Or some PDF is already shared by some student in Telegram group. Yeah. Some PDF is already shared. See my Telegram group. And let me tell you about the maths plan also. है ना? Maths and FT plan. Let me tell you about our maths and FT plan also. Oh, कहाँ गया? Guys, from 22nd. Maths plus FT taken by Dheeraj sir and Richa ma'am. Okay. So it will be 22nd maths, then 23rd aptitude. 22nd maths, 23rd aptitude. Okay, here maths, differential equation and quantitative aptitude. Then 24 again, 24 is what? Calculus. 25th is aptitude. Okay. 26 is matrices. 27 is aptitude. Okay, spatial aptitude. 28 numerical methods by Dheeraj sir. And 29 is verbal aptitude. Then 30 is complex number. And 31 is aptitude. This is by maths by Dheeraj sir. And this is by Richa Gupta ma'am. On YouTube. YouTube Civil plus Mechanical channel. Okay. Formula revision will of course be there, yaar. Formula revision will of course be there. Okay. Soon we'll be sharing this in our Telegram group also. Soon we will be sharing this in our Telegram group also. Okay. Let me share the link. Guys, please share this marathon link, everyone. So, origin of soil is done, soil classification is done. Okay, and guys, soil classification, origin of soil, and compaction is done. Ready for effective stress. Everyone, every commando, every champion. Ready for effective stress? Yes or no? Yes or no? Any doubt till now you want to ask me? Any doubt you want to ask me, guys? You can ask me if you have any. Ready? एक बार शेयर कर दो यार फटाफट सबको. Come on, come on, come on. Come on, everyone. Come on. Share to all so that maximum students can get benefited. Okay. Anything you want to say about speed, about anything? Just a couple of minutes, then we are starting the session, guys. Let more people join in. Okay. So this is the complete marathon, guys. Surveying will not be at 10. Surveying will be at 6 p.m. Okay. The surveying session will be at 6 p.m. This will be tomorrow, guys. 10 a.m. And I'm again telling you guys, यहाँ पे 10 नहीं आना है, 6 p.m. को आना है. 6 p.m. Sunday. Okay. 6 p.m. Sunday. Ready for the effective stress, guys? Everyone. एक बार सबको शेयर कर दो भाई. चलो फिर स्टार्ट करते हैं effective stress. Okay. चलो. Now, guys, effective stress is what? What is effective stress? Effective stress is the contact force between particles. Okay, it is represented by sigma bar. Okay, and this is sigma and U. Sigma is the total stress, U is the pore water pressure. Okay, sigma is the total stress at any level in the soil. Okay, how to find this? And U is the pore water pressure for hydrostatic condition at any height H below. At any height H below, what is the pore water pressure? Gamma W into H. Okay, in static condition. And effective stress is equal to sigma minus U. That is total stress minus the pore water pressure. That is total stress minus the pore water pressure. Now, effective stress is the contact force between the particles, not going into the derivation. But let me tell you, effective stress is more, it is good or bad for us? Effective stress is more in a particular soil, it is good or bad for us? Please tell me. Effective stress is more, it is good or bad? Please tell me. Please tell me, everyone. Everyone, guys, tell me. It is good or bad? If effective stress is good, it is good for us. Okay. If effective stress is less, it is bad for us, because when effective stress is more, okay, because when effective stress is more, that means it is larger interaction between the particles. That means it is the larger interaction between the particles. The contact force is more. That means they will not slide. That means effective stress is more. That means they will not slide here and there. Okay, that means they will not slide. They are in contact. They are loving each other. They will not go here and there. They will not go here and there. Okay, so effective stress is more. It is good for us. Okay, effective stress is light is poor. Why, guys? Now on rainy season it is landslide. Why on rainy seasons there is landslide? Tell me, please. Why on rainy season there is landslide? Tell me, please. In rainy season there are more landslides, because in rainy season, guys, when I am writing the formula effective stress is sigma minus u, so pore water pressure will be increasing. In rainy season, pore water pressure is, because water table is increasing na. Water table is increasing na. So water table is increasing, so that means gamma W into H will be increasing. Pore water pressure is increasing, so pore water pressure is increasing, so sigma bar will be decreasing. Sigma bar will be decreasing means sigma bar represents the physical interaction between the particles. So that means there is less interaction between the particles, not much bonding, not much bonding, it is less bonding. So less bonding, that means it is a shear failure. Guys, if there is contact now in bit, they will love each other, so they will not go here and there. If there is less love, less interaction, so somebody can slide them easily. Okay, anyone can slide them easily, guys. Okay, now let me do some cases, guys. Suppose this is the case. Let me do one by one each case. Here is the ground level. There is no water here. Okay, so what is the total stress at suppose it is gamma D. So the total stress is gamma dH, and as we are going downwards, okay, so stress will be increasing, obviously, because it is more weight. This will not be carrying any weight. Above it is nothing. This will be having this much soil. This will be having this much soil. This will be having total soil. Okay, so as we are going down, stress will be increasing, and here the stress will be, this value is gamma D into H. This is sigma. As there is no water, so pore water pressure is 0. As there is no water, so pore water pressure is 0, and sigma bar is sigma minus u. Sigma minus u is equal to sigma bar. As, guys, u is 0, so sigma bar will also be same. That is gamma D into H. Now this is the ground level. In the second case, this is the ground level, and water comes here. Water table comes here at the ground. Okay, water table comes here in the ground. Now here, guys, this is the case. This is sigma. This is, now water is here, so it will be gamma set na yaar. If water is here, it will be gamma set na yaar. If water is here, it is gamma set na yaar. If water is here, it is gamma set na yaar. So this will be gamma sat into H. Correct or not? This will be gamma sat into H. Yes or no? Yes, sir. This will be gamma sat H, because density, when water will be there, it will be gamma sat. It will be gamma sat. And pore water pressure will be, gamma W into H. The pore water pressure will be at H height, it will be gamma WH. And sigma minus u is equal to sigma bar. Sigma minus u is equal to sigma bar. Okay, this is equal to, starting from 0 here. So it will be sigma bar, gamma sat minus gamma W. Gamma sat minus gamma W is equal to gamma submerged S. Everybody on the comment section, give me yes or no. Everybody on the comment section, give me yes or no. Have you understood this or not? Have you understood this or not? Please let me know. Please let me know. Everyone. Nahi thakta bhai. Everybody, yes. Okay. Now this is case number B. This is case number A. Now let me go to case number C. Twing, 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 twing. Twing, twing, twing. So here is ground level. Here is Ground level up to this point, this is ground level. Above this is water. Above this is water. Wah, 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 wah. Wah, 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 wah. Wah, 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 wah. Wah, 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 wah. Okay, sir, got it, sir. Now here if I am making sigma, so guys, sigma here will be due to weight of water. That is gamma W into H1. And sigma here due to the weight of water, it is gamma WH1 plus due to weight of soil. Of course, below water, this is a flood situation. Water goes above ground level. This is a flood situation like in Odisha and various parts of the country. Okay, it is the water is going above the ground level. So, of course, this will be saturated. Okay, so gamma WH1 plus gamma sat into H plus gamma sat into H. If I draw, this is sigma water. So gamma WH1 and this will be gamma W into H1 plus H. This will be gamma W into H1 plus H. Okay, sigma minus U will be sigma bar. Now guys, here 0 minus 0 will be 0. Gamma WH1 minus gamma WH1. Gamma WH1 minus gamma WH1 will be 0. And this will be sigma bar. Gamma WH1 and gamma WH1 is cancel out. Gamma sat H minus gamma WH is gamma submerged H. Write down an important note in your copy. What is that important note? That guys, here what is the effective stress? 0 and gamma submerged H. Now water goes above this. Okay, water goes above this. This is H height here. Here also this is H height. Water goes above it and see the effective stress is same. 0 and gamma submerged H. Here also the water is same. 0 and gamma submerged H. Here also it is same. 0 and gamma submerged H. That means guys a very important concept from where numerous questions have been asked in GATE till now. From where numerous questions have been asked in GATE till now. What is that? What is that? The thing is this, that sigma bar is equal to sigma minus U. If water table goes above ground level, then guys, my champions, my commandos, whatever is the change in U, same is the change in sigma. Whatever is the change in U, same is the change in sigma. So, same is the change in sigma. So, this is unchanged. So, my friends, if water is at ground level, it is 0 and gamma submerged H. If water is at ground level, effective stress is 0 and gamma submerged H. Here also effective stress is 0 and gamma submerged. And if water goes above ground level in fluctuation, effective stress is not changing. Everybody, I want to see the chat box with red color. If you have got this concept, give me yes or no with the beautiful heart sign. Come on, everyone. Come on, everyone, guys. Come on. Come on, friends. Everyone. Tell me. Please. Come on, my friends. Have you understood? Any doubt? Any doubt? If no doubt, then we'll moving further. If no doubt, we are moving further. सही टिक करके आओगे ना एग्जाम में? We'll put it. Okay. Great. Okay. Now, guys, suppose up to now, in the fourth case, this is C case, this is D case, there is no load. Now, some load is also acting. Okay. Suppose the load is also acting, and this is the water table. And I'm drawing from long time after. Why I'm writing this in the next slide, I'll tell you why I'm writing this. So here, sigma will not start from 0. Even at the top level, the stress is Q. Even at the top level, the stress is Q, not 0. Even at the top level, the stress is Q. It is starting from Q. And here it will be Q to hai. Q plus, this is gamma sat because water table is here. So Q plus gamma sat into H. It is Q plus gamma sat into H. Q is some external load acting on it. Q is some external load acting on it. And due to the self weight of soil, it is gamma sat H. Due to the extra self weight of soil, it is gamma sat into H. Due to the external load, it is gamma sat into H. It is gamma sat into H. Okay. Okay, sir. Got it, sir. Okay, sir. Got it, sir. Okay, sir. Got it, sir. Minus pore water pressure. It will be 0. And it will be here gamma W into H. And sigma minus U is equal to sigma bar. Sigma minus U. So Q minus 0, it will be Q. And here it is Q plus gamma sat H minus gamma WH. It will be gamma submerged H. Okay, it will be gamma submerged H. Have you got it? Have you got it, my friends? Everyone, Mulli Kartik, Dikshit, Manisha, Mayank, Hanish, Rajkumar, Kongani, Anushka Singh. Okay. Now, let me tell you guys. Suppose this is a ground level. Okay. Suppose this is a ground level. This is the water table. Okay. And this is like this. Okay, sir. Got it, sir. I want to write everything at P point. Okay. Now, this is gamma D. This is gamma sat. Okay, sir. Okay, sir. This is H1. And this is H2. This is initially. This is acting on this. So I want to write down. I want to write down at P point. I want to write down at P point. I want to write down at P point. So what is sigma? Okay, what is sigma here? Just before any loading. Sigma is gamma D H1. Okay, plus gamma sat H2. Gamma D H1 plus gamma sat H2. So what is pore water pressure? Gamma WS2. What is effective stress? Gamma D H1 plus gamma sat S2 minus gamma WS2. It is gamma submerged S2. Okay. It is gamma submerged S2. Q plus gamma submerged where? Yes, Q plus gamma plus. Okay. Now, what is happening? Now a load is coming. A surcharge is coming Q. This is added now. Added now. AC चलाते हैं पहले. AC चलाओ भाई. I want AC. I want AC. I want AC. Please see here, guys. Now, just after the loading, when this loading comes, see, this is Q due to load and gamma DH1 plus gamma sat Q plus gamma DH1 plus gamma sat into H2. Q plus gamma DH1 plus gamma sat H2. Now pore water pressure at P point here is Q plus gamma WH2. Let me explain you now. Complete thing, guys. Now understand the logic. Now understand the logic, my friends. Everyone, see the logic. Friends, earlier when no load was there, the piezometer if I insert, earlier when there is no load, and if I insert the piezometer, so it is increased up to this point. The pressure here is gamma WS2 when there is no load. Q was not there. So here the pore water pressure is, the pressure head is S2. The pressure head is S2 when there was no load. Now load is coming. Guys, every time whatever now coming from my mouth, remember this. Whenever load comes, guys, whenever load comes, initially in a saturated soil, all load is taken by water. all load is taken by water. That means when there was no load, the pressure is S2, water pressure is S2. Now the load is coming. Initially the load is taken by the water. So water comes in extra pore water pressure. So UE, how much extra pore water? How much extra pore water pressure? How much extra pore water pressure? Whatever the load you have applied. Whatever the load you have applied, that much extra pore water pressure comes. Whatever the load you have applied, that much extra pore water comes. That is Q. Okay, so this is Q plus gamma WS2. Just after application of load. Just after application of load. So this will be sigma minus U is sigma bar. Sigma minus U is sigma bar. So it is gamma DH1, gamma sat minus gamma W is equal to gamma submerged S2. So guys, that means just after the application of load, guys, there is no change in effective stress, because whatever the change in sigma, that is change in U. Whatever is the change in sigma, that is change in U. Okay. So guys, here there is no change. Guys, a long time after, nobody wants to be in extra pore water pressure. Nobody wants to be in extra pressure, guys. So after a long time, water start dissipating out. Okay, nobody wants to leave in extra pressure. Water will dissipate out. So water will dissipate out, this will come back to its hydrostatic condition. Water home is hydrostatic. Water's home is hydrostatic. So it will come back in its extra, again, its original condition. Nobody wants to be in extra pore water pressure. Okay, so this will be, okay, this will be like this. Nobody wants to, so pore water pressure is come up to here, this point. Okay, this much, but this will dissipate out. So after a long time, when water is dissipated out, okay, so long time, sigma is there, Q is still acting, plus gamma DH1 plus gamma sat S2, but water pressure will only be now in gamma S2. Okay, U excess is now 0. It has been dissipated. So this will be Q plus gamma DH1, gamma sat minus gamma W is equal to gamma submerged S2. Okay, that is why when I was doing here, I have written this long time after. So long time after, water pressure is only this. Otherwise, initially it is Q plus gamma WH. Okay, so this is the case, guys. Now, guys, why I am not a very huge fan of PDF, na? Okay, you all, because guys, I have done so many things here, but in PDF, this final value will be coming, na? In this, I have done this also, I have read this also. That is why watching it live will be helping. And like, guys, this marathon will only be live. Okay. Everybody, please give me a heart sign if you got it. Every time in a saturated soil, all load is taken by water. Every time in a saturated soil, the all load is taken by water. Okay. Give me yes or no. Give me yes or no. Please. Please, guys, please. Got it? Got it? Okay. Now, okay, this is capillary. When we insert the water in thin, it will be going above. Okay, so I'm not going into the derivation. Let me write the total value of capillary. How much the capillary rises. Okay, how much. Again, you can apply the total weight downward upon the total force due to surface tension. You can find out the value of the capillary height, and from here, this H value, the capillary height is 4 sigma into cos theta upon gamma W into D of this pipe. Okay, sigma is surface tension. And what is sigma? What is theta? This one. This is the surface tension, na? Okay. Now, guys, same thing is happening in soil also. Okay, let me give an example from this. You will go. Let me do a question, na? From you will get all the concepts. Let me do that question for you. Okay, from that you will get all the concepts. Let me see who can do this. First, this is 0 meter. Okay. Then at 4 meter there is water table. At 4 meter there is water table. At 0 meter it was ground level. Capillary action was for 1 meter. as in the thin tubes, water rises above. As in the thin tubes, water rises above. So here also, in the thin voids are also very thin, water can rise above. Okay. After that, it is what? For 6 meter, it is sand. Okay. For 6 meter, it is sand. Up to this, it is sand. Okay. Then at 10 meter, up to 10 meter, it is clay. So this is the 4 meter is the clay depth. 4 meter, it is the clay depth. Gamma 18. Here it is 18. Gamma T is equal to 18. Gamma sat of sand is equal to 20. Guys, and capillary region, this is also in saturated. Okay, this is also, when not mentioned, that is also taken as saturated. And gamma sat of clay is equal to 19 kilonewton per meter cube. Gamma sat of clay is equal to 19 kilonewton per meter cube. Okay, gamma sat of sand is 20. Okay, gamma W, if it is not given, you have to take it as 9.81, but here it is given. It is 10. Okay, gamma sat of clay is 19. Draw the sigma U and sigma bar diagram. 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 And tell me the values. I want to see who can do it fastest. Tell me the values in the okay. Tell me the values of sigma U and sigma bar. Now let me tell you effective stress, because this might be your not knowing. Below this is the same. 0 here at the water table. Then 10 into 220. And 10 into, how much is the depth? How much is the depth? 4 to 10, 60. Okay, so it is 20 and 60. But in capillary zone, guys, the water goes like this, in minus. Water goes in minus. Okay, this is the minus. And here it is 1 meter. It is 1 meter, so it is minus 10. Now why minus? Why minus? Why minus, guys? Because understand the logic. Here the pressure is 0. Here the water pressure is 0. And water is moving up. From any 0 pressure, water is going somewhere. Water always goes from high pressure to low pressure. Water always goes from high pressure to low pressure. Water always goes from high pressure to low pressure. And from 0, it is going somewhere. So 0 is high. 0 is high. Okay. Water always goes from high pressure to low pressure. And from 0, it is sucked up. From 0, it is sucked up. So water always goes from high to low. So that means 0 is high. That means 0 is high for this. Because water goes from high to low. That means 0 is high. Okay, from high to low it is going. So 0 it is high. So that means low will be negative. Guys, water always goes to lower pressure. Now, and from 0 it is going somewhere. So what can be lesser than 0? What can be lesser than 0? Negative. That is why it is negative pressure. This is one way of thinking. Other way of thinking, it is sucked up. Sucked up means vacuum. Vacuum means negative pressure. Water is sucked up from here. Okay, sucked up means only sucking is when there is negative pressure, like in vacuum. So water is sucked up here. That is negative pressure. Water goes from 0 to somewhere. So it is negative. Give me yes or no. Give me yes or no. Everyone, please. Everyone, please. Understood? Understood? Okay. Now draw the sigma. and sigma bar. 18 into 3, 54. Then this is 20. 20 into 1 is 74. Then 20 into 40. 40 is 114, है ना? And 114, then 19 into 4 is, this is 19 into 4 is 76. So this is 180, 76, oh sorry, 190. This is sigma. And sigma minus u is equal to sigma bar. Sigma minus u is equal to sigma bar. Draw the values. I want to see who can do it fastest. Tell me the value of sigma bar at all the locations. At all the locations. Tell me the value of sigma bar. Tell me the value of sigma bar. नहीं बताओगे? So this is 0 and 0. 0 minus 0 will be 0. 54 minus. See guys, here this is 0, so 0 it will be 0. Now it is 54 just above this level where there is no water. So it is 54 minus 0 will be 54 sigma bar. Above this level, this point which is not in capillary. This point which is not in capillary. Okay, this point which is not in capillary. The water pressure there is 0. So 54 minus 0 will be 0. Just below this. Now this point. Just below 54 minus 10. It is 64. 54 minus 10. 64. 74 minus 0 will be 74. 114 minus 20. 94. 190 minus 60 is 130. 190 minus 60. अरे लिख लें दो भैया. 130. This sigma bar 54, 64, 74, 94, 130. Have you understood? Have you understood guys? लो मैं साइड हो जा रहा हूँ. Please leave. Please tell me, have you got it or not? Have you got it or not? Have you got it or not? Everyone. Or you want to check it again? You want to check it again? Okay. Can you do this question for me? Can you do this question for me? Which of the following statements is true in the context of capillary pressure in soil? Yes, Shomik, of course. Yes, Shomik, of course it will be mentioned. Which of the following statement is true in the context of capillary pressure in soil? Okay. This is MSQ. This is MSQ, guys. Everyone. Achha, you all know that MSQ already. Already you are aware. Nice, nice, nice. Nice. Yes, it will be mentioned. It is MSQ, MCQ, and it is mentioned, guys, for every question. You don't have to play hide and seek there. So water is tension zone because water is sucked up. Water is sucked up. Okay, pore water pressure is negative, correct? Effective stress increases. Minus U. So it will be increases, na? It will not be more in coarse grain soil. Guys, capillary height is inversely proportional to D. We have seen the formula na. So more diameter, the less height. Okay. So more diameter, the less height, less pressure. Okay guys, capillary is good or bad for stability? For stability, capillary is good or bad? Capillary is good or bad? For stability point of view. For stability point of view, it is good or bad? Okay, good, because effective stress is increasing. Chalo. Now guys, we have done this. We have done this. We have done this. We have done this. Now let us come to the permeability. Okay, this is my Telegram group, Civil by Abhinav sir, and quiz of this is available here. Okay, you can click there. This is the complete schedule. Let me tell you guys, surveying is not at 10, surveying is 6 p.m. Sunday. Okay, this is the surveying schedule, then permeability. Okay, so guys, see here, this is soil, water here is H1 and here H2. Water here is at H1 depth, okay, and water here is H2 depth. Everything in this universe, guys, I am coming to permeability now. Okay, everything in this universe goes from high head to low head na. Please confirm. Please confirm. Everything in this universe, it will be there. Everything in this universe goes from high head to low head. High head to low head. Okay, so here it is high energy, H1, here it is H2 less. So water will be moving. Water will be moving here. Okay. Now, there is a term called I. What is I? I is hydraulic gradient. I is hydraulic gradient. What is I? HL upon L. All loss occurs in soil, guys. All loss occurs in soil. Okay. So what is HL? HL is H1 minus H2. HL is H1 minus H2. So I is equal to H1 minus H2 by L length. Okay. I is equal to H1 minus H2 by L length. Got it? Got it? Everyone? Okay. Now, there is a person called Darcy. Okay. So what Darcy says, that velocity of movement of water from here to here, velocity of movement of water from here to here is proportional to I, and he has not given any big statement. Obviously guys, more is the loss. Okay, everybody wants to go lesser energy, and more is the loss, they will go there. Matter will go there, either solid or either liquid. Wherever there is less energy, it will go. And if it is more less energy, it will go faster. If it is more less energy, it will go very, very fast. Because everybody wants to be in less energy. So less energy is a sweet, is a chocolate. More less energy, more faster it will go. So it is proportional to gradient. More HL, more I, more faster it will go. And this is removed by a constant called hydraulic conductivity or permeability. K is hydraulic conductivity or permeability. Now permeability of sand will be more, then silt and then clay. Okay. Now, everyone, what is Q? Discharge is equal to velocity into area. Okay, what is the total area here? Let the total area be 8. So Q is V is K into I into A. Okay, this is discharge. This is discharge KIA. But then after some years, person says, there is a mistake, sir. There is a mistake, sir. What they told, actual velocity is not V. You are saying that velocity is discharged by area. V is Q by, no. He's saying here, velocity will be discharged by area of voids, na? Because actually the water is, suppose I make this cross section, this yellow cross section. Okay, this yellow cross section. Actually the water is, these are solid. So actually the water is not going from the solid, na? So actually the water is going from the voids only. Water is going from the voids only. So you are saying discharge by area, no, discharge by area voids. Discharge by area of voids. So Q is equal to KIA upon area voids. So multiply by length. So it is Ki into total volume. Area of void into length is equal to volume of voids. Area of voids into length is volume of voids. So it is Ki upon volume of voids by total volume. Volume of voids by total volume. It is porosity. Okay, so this is V upon N. Actually, this is V dash. This is true velocity. This is true velocity. Or it is seepage velocity. And this is discharge velocity. So, the true velocity is, the true velocity V dash or seepage velocity is velocity by porosity. Okay. This is the velocity when true area is taken, area of voids. And this is the velocity by considering the total area. So the true velocity or the seepage velocity is discharge velocity upon porosity. Of course, the porosity is less than 1. So the true velocity or the seepage velocity is greater than the discharge velocity. Of course, it will be greater because here the denominator is smaller. Okay. Now, my friends, V is equal to Ki. V is equal to... Guys, is there some voice issue? Is there some voice issue? Okay. So, V is equal to Ki. Okay. So, okay, V is equal to Ki, this is discharge velocity, and V dash is equal to Kp into I. This is hydraulic conductivity or permeability. This is coefficient of hydraulic conductivity. It is coefficient of percolation. Okay, this is coefficient of percolation. Got it? And V dash by V, where is V? V by V dash tha. Let it be V dash by V. V dash by V is equal to Kp by K is equal to 1 by porosity. Is equal to 1 by porosity. Give me yes or no. Give me yes or no. Everyone. एक मिनट मेरे को ये बताओ which students in marathon नहीं रहने दो उसको मैं म्यूट बंद होने दो बच्चों को सुनने दो मैं क्या कह रहा हूँ कि अगर इस स्मार्ट बोर्ड में गूगल मीट का लिंक दिया धीरज सर और ऋचा मैम को है ना और वो आए, ज्वाइन किया उन्होंने, लिंक हमने मेल दिया, तो उनकी फ़ोटो यहाँ दिखेगी क्या? और उनकी फ़ोटो दिखेगी, आवाज़ भी आएगी बच्चों को, और कुछ चूं 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 तो नहीं होगा, है ना? तो फिर ठीक है, आप दे दो उनको लिंक, आप उनको लिंक दे दो। कैसे दोगे ताकि मेरे को इस मेल में भी दिखाई दे? इस मेल आईडी से दोगे? हाँ ठीक है, तो मैं उनको 5 मिनट बाद, गाइस देयर इज सम अनाउंसमेंट, आफ्टर 5 मिनट्स धीरज सर विल बी हियर, ओके? Okay, about maths and FT. Till then you do this question. Okay, till then you do this question. 4 बजे से उनकी क्लास है धीरज सर की। हेलो 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 धीरज सर, रिचा मैम, आप दोनों फ्री हैं अभी? सर आप दोनों को ना मेल में गूगल मीट लिंक आ रहा है, उसमें ज्वाइन कर दीजिए वो, और मैं जिस बोर्ड में पढ़ा रहा हूँ ना, जिस बोर्ड में मैं पढ़ा रहा हूँ उसी बोर्ड से मैं उसको ज्वाइन करूँगा। तो आप बच्चों को दिखाई देंगे, तो आप जो वो आपने मैसेज भेजा ना रिचा मैम ने, वो एक बार बच्चों को एक बार थोड़ा अनाउंस कर देना अपना। और सर एक और काम करना, आप दोनों में से एक जना को, या दोनों ही दोनों फटाफट से जो पोस्टर है ना वो मैथ्स और एप्टी वाला, मेरे ख्याल से रिचा मैम ने बनवाया है वो, मेरे को तो आइडिया भी नहीं था। हेलो हेलो वो पोस्टर भी सर उसी मेल आईडी में भेज दो ताकि मैं स्मार्ट बोर्ड से दिखा दूं। क्लास कोई बात नहीं मैम, मैराथन में बच्चे इंतजार कर रहे हैं, अभी 5 मिनट लगेगा, अभी भेज दो गूगल मीट लिंक, वो सिंपल लिंक भेज दो, मीटिंग शुरू करने की जरूरत नहीं है। भेज दिया आपको, लिंक भेज दिया है, नहीं रिचा मैम को भी मेल में, richa.gupta, richa.to, रिचा क्या है 3, रिचा 3.गुप्ता या richa.gupta 3? richa.gupta 3 करो, ठीक है मैम, आ जाइए। और उसमें ना एक बार अपना वो भी एच की जगह जी आएगा मैम, उसमें ना अपना वो भी भेज दीजिए, क्या कहते हैं, शेड्यूल पोस्टर, ताकि मैं स्मार्ट बोर्ड में खोल दूं। जिस मेल में आपको गूगल मीट लिंक आया, देखो आ गया है। ठीक है सर, आइए आप ज्वाइन कीजिए सर। हेलो सर, ज्वाइन कर दो, ज्वाइन कर दो, मैं स्मार्ट बोर्ड से आ गया हूँ। पंकज भाई मेल आ गया? किस आईडी? हाँ, इसमें वो भेजो, क्या कहते हैं, पोस्टर, और आ जाओ, मैं ज्वाइन कर दिया हूँ। ओके जल्दी आ जाओ। इसको क्या करना है पंकज भाई? अलाउ कीजिए। हाँ अलाउ, आप क्या करना है इसको ज्वाइन?
ऑडियो पे क्लिक कीजिए।
ऑडियो कौन सा है?
ये वो कौन ऑडियो?
ये गॉट इट।
हाँ वो तो कर दिया, वो ऑडियो का सिंबल बना, गॉट इट ऊपर, अलाउ ऊपर, अलाउ वो ऊपर ऊपर ऊपर। हेलो,
मेरा आवाज आ रहा है मैम? मेरा आवाज आ रहा है? अच्छा आपका नहीं आ रहा, रुको, आप लाइव में अभी दोनों ना यूट्यूब पे, तो वैसे नहीं कि आप धीरज सर से लड़ाई करने लग जाएं। हेलो, नहीं अब हमें आवाज नहीं आ रहा। आप एक बार यूट्यूब भी खोल लीजिए साथ साथ में, और कोई इस मेल में, जिस मेल में भेजा है ना, उस मेल में एफटी वाला शेड्यूल भी भेज दीजिए, जो मैम आपने भेजा अभी।
आपका जा रहा है आवाज?
मेरा आप दोनों को आवाज आ रहा है? पंकज भाई पूछ रहे हैं मैम, ये जो कंघी बना रही है बच्चों को दिखाई दे रहा है? ओके, मेरा आवाज आ रहा है क्या आप दोनों को? पंकज भाई पूछ रहे हैं। अरे मेरे को नहीं आ रहा ना, थम्स अप करके बताओ आ रहा है तो। हाँ आ रहा है, आ रहा है।
उनका आवाज नहीं है ना।
नहीं मेरा फोटो रहने दो, मेरा फोटो का क्या करना है?
नहीं फोटो का तो वही से आएगा आपका।
हाँ
आवाज इससे ले रहा है, ठीक है। उनको उनको जा रहा है इससे
हाँ उनको चलो इससे जा रहा है, पर उनका आवाज,
उसका आवाज नहीं आ रहा है, उसका ही वो करते हैं ना।
उन दोनों का 4 बजे क्लास भी है।
कुछ तो हो यार।
तो एक काम करें फिर, मोबाइल से ले लें उनका आवाज।
अरे रुक जाइए, मेरे पास तरीका है एक। हाँ वो भी कर सकते हैं, आप मोबाइल से भी ज्वाइन कर सकते हैं।
हाँ तो मोबाइल से कर लेते हैं फिर।
नहीं तो मैं ब्लूटूथ ओपन करता, ये कान में डाल देता आपके।
नहीं पर बच्चों को मेरे कान में आएगी ना वो, आज बच्चों को आएगी।
आप उसका आवाज सुनने के लिए,
बच्चों को उनकी आवाज।
हाँ
तो रहने दो, मैं फोन ही करता हूँ। अब वो खोल दो, उनकी फोटो देख लो ताकि।
ये ले क्यों नहीं रहा स्मार्ट बोर्ड?
चलो ये पहले भी कुछ हुआ था, नहीं लेता ये, छोड़ो।
वो वाला आपको भेजना भी तो पड़ेगा।
क्या?
पास थोड़ी है वो।
नहीं नहीं, मैं तो यहाँ से फोन से कर रहा हूँ ना आवाज, फोन से ले लूंगा आवाज।
नहीं नहीं मिसमैच करेगा ना फिर।
नहीं करेगा, ये देखो।
म्यूट कर दो
मैम मैम आप दोनों ने यूट्यूब खोल लिया क्या?
हाँ हाँ खोल लिया है सर।
बच्चों एक बार कमेंट बॉक्स में बोल दो आपको मेरा, ऋचा मैम का। धीरज सर आप भी कुछ बोलना।
हेलो हेलो हेलो
बच्चों एक बार बता दो, धीरज सर का, ऋचा मैम का मेरा आवाज आ रहा है क्या? एक बार कमेंट बॉक्स में बोल दो फटाफट से। क्लियर वॉइस।
एक मिनट यहीं से आता है आवाज।
वो एक बच्चा कुछ कह रहा है, सो क्लियर सेटिंग्स क्या?
उसमें तो जाना ही पड़ेगा, सेटिंग में तो जाना ही पड़ेगा।
जाऊं?
हाँ जाए।
लो
साउंड में जाइए,
साउंड का है ये,
सिस्टम में जाइए यहाँ पहले।
कोई बात नहीं, मोबाइल से आ रही है आवाज। रुको ये लो, अब
ठीक है। इसका ये चूज आउटपुट आउटपुट
आउटपुट
तो सही है। इनपुट ट्रबल शॉट मारे ना,
इनपुट
नहीं ये तो सही है।
हाँ। कोई बात नहीं, ऐसी दिखा दो, उसमें बच्चे बता देंगे।
कीजिए फिर टाइम।
लो हाँ हाँ वो उनके क्लास है। लो उसको क्लोज करो। सर बता दीजिए बच्चों को। मैडम सर
अभी दिख रही हूँ सर, आपने मुझे पहले नहीं बताया।
नहीं मैं आप बता दीजिए, कोई बात नहीं।
ओके आवाज आ रही है ना सर?
आ रही है। मैंने आप फोन का स्पीकर में
हाँ सर मैंने खोल लिया यूट्यूब, अब मुझे पता चल गया। Hello my dear students, I hope you guys are fine and enjoying Geotech Marathon. As we promised, we are coming with complete aptitude, whatever is there in your syllabus of GATE. So this I and Dheeraj sir will be taking aptitude and mathematics sessions alternatively. The schedule, the timetable, each and everything along with the topics will be available to you. Sir will be showing you the whole slides regarding the upcoming classes and the schedule about it. Over to you, Dheeraj sir.
So guys, I feel from many days you guys were asking about this. So I would like to say that from 22nd of January, like on 21st, your marathons would be over. Then from 22nd, we are going to start mathematics and aptitude. So 22nd, we would be having differential equation. We have kept it chapter wise, so that during that time you can also revise your technical subject also, because at the same time you would be having the formula series going on for technical subject. So both should go together. That's why we are keeping it on topic wise, and that will not make hectic also for you. So 22nd differential equation, then quantitative aptitude on 23rd, then 24th calculus, 25th analytical aptitude, then 26th matrices, 27th aptitude, 28th numerical method, then 29th verbal aptitude, then 30th complex number, 31st once again rapid practice. Then first we would be having probability, and third you have exam. So second we will try to keep a practice session of more than 100 questions, and in these sessions we will keep them like concept plus practice both. So be ready. Over to you, ma'am.
Yes, guys. So I guess the energy which you are maintaining right now, we want the same energy to be there for the upcoming classes of GATE and GATE in that aptitude and mathematics, because you know aptitude and mathematics in together will give you 28 marks in the examination. So if now you haven't done practice, so leave it to us, because the upcoming week we'll be making you revise thoroughly and we'll make you practice n number of questions, which will be very, very beneficial for the upcoming examination, that is your GATE 2024. Abhinav sir.
तो सर और मैडम ये बच्चा ये वाला पढ़ सर और मैम बच्चा ये वाला पढ़ के फोड़ देगा 28 में से कितने मार्क्स आ जाएंगे आप दोनों का सारा सेशन लगा दिया तो
सर 28 से तो 28 आ ही जाने चाहिए, बिकॉज इसरो में भी वैसे ही क्वेश्चंस आए थे जैसे कि हमने कराया था एप्टीट्यूड में.
ठीक है फिर मैं भी आऊंगा रोज 10 बजे.
मैम टेक्निकल में सिर्फ एप्टीट्यूड नहीं
सर एप्टीट्यूड अभी मतलब इस पर फर्स्ट टाइम था ना इसरो में एप्टीट्यूड का. एप्टीट्यूड बहुत सारे प्रैक्टिस सेशंस आई हैव टेकन ऑन ऐप आल्सो एंड यूट्यूब आल्सो. तो वैसे ही क्वेश्चंस आए थे, तो होपफुली टचवुड की मतलब एप्टीट्यूड में भी गेट में वैसे ही आए.
So I can see some doubts in the comment section. Probability will be on 1st of February. Maybe on that you are not able to see. And also timing will be from 10 a.m. Like right now marathons are going on, and one thing would be same. The rule is the session will go on till the topic will be over. Okay, that is the rule of technical marathon also. The same will be there for math and FP also. Okay,
सर मैं भी आऊंगा मैथ सेफ्टी पढ़ने.
will definitely help you to crack it.
मैं भी मैथ सेफ्टी पढ़ने आऊंगा.
आप आओगे फिर आप ही सब्जेक्ट आप भी पढ़ाना स्टार्ट कर दोगे. हम लोग इतना अच्छा पढ़ाते हैं ना.
अच्छा तो ठीक है बच्चों को दो
आप बताओ.
मैं भी मैथ सेफ्टी पढ़ के देखता हूँ कि मैं क्वेश्चन सॉल्व कर पाऊंगा कि नहीं, जब बच्चे मेमोरी बेस पे बताएंगे.
हाँ वो आप चेक कर लेना.
अच्छा स्टूडेंट्स, लेट मी टेल यू वन मोर थिंग that on the same day, that is 3rd of February, we'll be doing the complete mechanical analysis, and on 4th of February we'll be doing the complete civil analysis. Of course in the next weekend we'll be doing with the XE analysis also. Okay मैम बच्चे कह रहे हैं कि एनवायरनमेंट के मैराथन में मजा नहीं आया.
किसने का मजा नहीं आया? मेरे को तो सबने अच्छे अच्छे कमेंट्स दिए जबरदस्ती. ये अभिनव सर स्टूडेंट्स मुझसे हमेशा लड़ाई करते रहते, इनकी बातों में मत आना. आज भी देखो इन्होंने मुझे बताया नहीं कैमरा ऑन था.
नहीं आपको बताया ना, एक स्लैक ग्रुप में मैसेज आया था तो बताया.
मुझे पता ही नहीं था. मैं
धीरज सर आपको बताया था कि नहीं बताया था?
धीरज सर सच बोलो. धीरज सर सच बोलो. आप सच का साइड दो. देखो सर मेरे सपोर्टर्स लिख रहे हैं एनवायरनमेंट के बारे में. थैंक यू रत्नादीप. और भी बाकी मेरे वाले कमेंट सेक्शन में आप देख लेना.
मैं मजाक कर रहा हूँ मैम, बच्चे तो कह रहे हैं कि बहुत ही ज्यादा सही था. ओके
हाँ
ठीक है.
अब ये देखो आपके सपोर्ट में आ गया. बताए.
I want to add one thing.
बताइए सर. आप ऐड वन थिंग बहुत करते हैं सर. आप आई वांट टू ऐड वन थिंग बहुत ऐड करते हैं.
1st of February बिकॉज उस सीट में शायद आपको दिखाई नहीं दे रहा होगा लास्ट तक, बट 1st February को है वो प्रोबेबिलिटी.
ठीक है 1st February will be probability, and after this series at least you will be scoring more than 25 marks out of 28. The probability of this is approximately 1. Okay
100%.
ओके मैम एक बच्चा लिख रहा है प्रकाश की अभिनव सर को एनवायरनमेंट पढ़ाना चाहिए, आप बहुत अच्छा पढ़ाते हैं. तो मैम भी अच्छा पढ़ाती है, फिर मैम सॉइल मैकेनिक्स पढ़ाएंगी. ओके
आप सॉइल मैकेनिक्स तो मुझे देने से रहे.
मैम मैं सब आप ले लीजिए, क्या दिक्कत है. सर भी तो सोम पढ़ाते हैं. ओके सर आप गूगल मीट पे इतने गुस्से में क्यों लग रहे हैं?
सर अभी क्लास का टाइम हो रहा है ना.
तो क्लास गुस्से में जाते हैं आप क्लास में?
नहीं सर, मैं ये सोच रहा हूँ
कब एग्जिट होगा. ठीक है ठीक है.
गुस्से में नहीं हूँ, टेंशन में हूँ.
ओके बच्चे थैंक यू लिख रहे हैं सर. थैंक यू धीरज सर, रिचा मैम. दोज क्लासेस विल बी ग्रेट हेल्प. और यहाँ मैं इनको गूगल मीट में बता रहा हूँ, यहाँ मेरे को कोई थैंक यू नहीं.
मुझे पता लगे अपने को, मुझे किसी ने नहीं बोला, मुझे ये बोलेंगे सेल्फ.
सर आपको हमारे जाने के बाद बोलेंगे ना आप.
ओके ओके.
आपको आखिरी में बोलेंगे जब मैराथन खत्म होगा. 12 बज जाएगा ना सर मैराथन में?
क्या प्रैक्टिस?
नहीं, आपका मैराथन जियोटेक.
नहीं नहीं मैम, मेरा क्या नाम है, 9 से 11 विजन में पेड क्लास में क्लास है सोम.
तो आज 8 बजे तक खत्म हो जाएगा.
8 मैम होपफुली खत्म हो जाएगा. ओके थैंक यू सर. Thank you, ma'am.
Okay, guys, we'll be happy. Please join the session for mathematics and aptitude if you want to score 28 out of 28 in the upcoming GATE 2024 examinations. Enjoy Geotech session, and if you haven't subscribed our channel till now, kindly do that also. Thank you.
आपको भी आता है सर इतना लंबा इंग्लिश का सेंटेंस, तो आप भी कुछ गुड बाय सेंटेंस बोल दीजिए.
तभी तो मैं आपको बोला था बोलने के लिए सर.
सर 11 घंटे कर, मैंने 11 में से 45 मिनट हटा दो, मैंने पूरी इंग्लिश बोली है. आज तक का सबसे ज्यादा देर बोलने का इंग्लिश रिकॉर्ड है.
ओके मेरे को तो मैम 256 MB इंग्लिश मिलता है, उसके बाद मैं हिंदी बोलता हूँ. पर डे 256 MB इंग्लिश. ओके थैंक यू मैम. थैंक यू सर.
Okay, thank you everyone, guys.
ओके तो चलो अब बहुत हो गया, ये क्वेश्चन कर लो जरा. अभी नाउ माई वॉइस इज कमिंग नॉर्मल ना? माई वॉइस इज कमिंग नॉर्मल ना? हु इज ब्लॉक? चलो चलो अब करते हैं क्वेश्चन. चलो चलो चलो. What is happening that where is the thing? This is here, this much water, and here the water level is this. Okay, we are inserting a tracer. Anything, what is the time it will take from moving from P? Okay, this is the P point, from P to Q. How much time it will take from P to Q? Please tell me. Time will be distance by speed, correct? Time will be distance by speed. Okay, so time will be, distance is 2500 na? Distance is 2500, and speed will be, guys, discharge velocity or the true velocity? Discharge velocity or true velocity? It will be true velocity. What is V? Discharge velocity Ki. Okay, Ki is HL, that is 55.2 minus 34.1 upon 2500. K is also given somewhere in meter per day. Where is K? This is a GATE 2 mark question, guys. This is 80. This is K. That is I. From there find V. And this V dash, the actual is whatever you find from V divided by porosity, that is 0.25. Put it here, you will get the answer, something 754, but I'm not exactly remembering. This is a GATE 2 mark question. This is a GATE 2 mark question, guys. Have you understood? Have you understood? Everyone. Okay, now what is the equivalent probability, guys, when it is parallel to the bedding plane? That is also called as Kx. It is equal to K1H1 plus K2H2 plus K3H3 upon H1 plus H2 plus H3. This is the Kx. Okay, this is the kx. Okay, that is k equivalent. Okay, now when it is perpendicular, then it is the k equivalent, also sometimes called as ky. It is equal to h1 plus h2 plus h3 upon h1 by k1 plus h2 by k2 plus h3 by k3. And let me tell you guys, this is the arithmetic mean. k1 plus k1 plus k1 plus k1 h1 times plus k2 plus k2 plus k2 plus k2 h2 times plus k3 plus k3 plus k3 plus k3 h3 times divided by h1 plus h2 plus h3. Okay, so this is a arithmetic mean and this is a harmonic mean, and arithmetic mean is greater than equal to harmonic mean. So kx is greater than ky. Okay, kx is greater than ky. Give me yes or no, everybody. Come on. Come on. Come on, come on, come on, come on, come on. Okay. Now guys, there is one more formula, as in you can call it. K is equal to constant, D is the effect. Guys, what is mean dia? Mean dia is D50. D50 is mean dia. What is effective dia? D10. Okay, the effective dia is D10. Now guys, K is equal to C into D square into gamma W, unit weight of water, upon viscosity into E cube upon 1 plus E. This is one more formula for permeability. From here, if temperature is asked, guys, the viscosity, the liquid viscosity is decrease. Okay, so K will increase. So with increase in temperature, guys, K will increase. This is the various values of K. Okay. Now these questions I have done. Okay. Now guys, these are all empirical equations, so I'm not going into that. Okay. The constant head, permeability head, and variable is also, it's okay. Nothing, only the formulas are there that I'll give you. Okay, so now let us go to the seepage. That empirical formulas I'm not going. Let us go to the seepage. Okay. Okay guys. Okay, Prince, यार उसके लिए आप मेरा क्लास देखो ना एक बार. When guys discharge is same, let me tell you when to take the parallel in this. Suppose this is the case. When discharge is same, it has to be perpendicular, else parallel. Like suppose here water is going. So whatever going water, that will go here also, na? That will go here also. Discharge same, it is perpendicular. Okay, whatever water going here, that will go here also, na? So the discharge is same, it is perpendicular. Okay, because here also Q, here also Q. Discharge same, it is perpendicular. Here discharge is not same, different discharge. But head loss from here to here, head loss from here to here, head loss from here to here is same. Okay, because if there is difference in head, this direction also, na? So water will go in this direction also. In this direction, water is not going. In this direction, water is not going. Therefore, all these are having same energy. That is why water is not moving here. All these are having same energy. That is why water is not going here. Water is only going here. Okay. So, parallel, when head loss from one point to other point or one section to other section is same in all layers. And perpendicular when discharge is same. Okay. Now seepage. After this, we are going to seepage. Okay. Ready? Ready or not ready? Ready or not ready? ये क्या है भाई? मिस्टर ओपिनियन कन हेरा, तू पहली बार तुझे देख रहा हूँ. क्या है ये? अच्छा, ओपिनियन. ओके, चलो चलो सीपेज करते हैं. ये टेलीग्राम है, ये हमारा सीरीज है. चलो 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 चलो. Now see guys, some very interesting thing I'm doing that will be helping you in many problems of soil mechanics. Okay, अब this opinion को block कर देते हैं, क्या दिक्कत है? That this opinion, a last warning, I don't want any comment of you. Okay, opinion. Now, any one single comment you will be doing, you will be blocked. Okay. Now guys, some interesting thing I'm doing. Please take care of this. Here is the water. Here is the water. Okay. Now, this is the datum, suppose. Okay, this is the datum, and I am considering few points like this 1, like this 2, like this 3, like this 4 point, like this 5 point, like this 6 point. 1, 2, 3, 4, 5 and 6. These are the 6 points. Okay. Now this is 1 point, then 2, then 3, then 4, then 5, then 6. Toing, 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 toing and toing. Okay. Toing, 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 toing and toing. This is velocity head. Here I am writing pressure head. Here I am writing datum head. And here I am writing total head. Okay. Now, अभी कुछ करेगा तो कर देंगे. Okay. Okay. Now guys, first of all, whenever in soil mechanics you come, close your eyes and put velocity head is equal to 0. In any case, even if the water is moving also, even if guys, any case, even if water is moving, even if the water is moving, then also the velocity will be 0. Why? Why velocity will be 0? Because if even the water is moving, then guys, the speed of velocity of water is very, very less. The speed of velocity of water is very, very less. And it is less in such a way. The speed of water is less in such a way. The speed of water is less in such a way that it can be taken as 0. Because speed of water is 10 ki power minus 6 here. 10 ki power minus 7 meter per second, 10 ki power minus 6 meter per second, 10 ki power minus 8 meter per second. Very, very slow. Very, very less. So even if water is moving, then also it can be taken as 0. Now datum head is the height from the datum. Now datum is this. So 2, 3, 4 and 5. 2, 3, 4 and 5. These points are at datum only. These points are at datum only. So if these points are at datum only, then guys, height of these points will be 0 from the datum. Height of these points will be 0 from datum. Okay. Now what is the height of 1 point from the datum? H1. And what is the height of 6 point is H2. Now pressure head. Okay, I am not considering the atmospheric pressure. So at 1 it is 0. At 2 it is H1 below. So pressure is H1. 2 and 3 are at same level. So pressure is H1. 6 the pressure is 0. 5 the pressure is H2. And at 4 also the pressure is same. So it is H2. Now guys, before I come here, everyone see the pressure. You just listen many times, na, that the pressure at same level is same. You listen many times that pressure at same level is same. Okay, you listen that. But guys, see, pressure at 3 and 4 are not same. Here it is H1, here it is S2. But yes, pressure at 2 and 3 are same, H1, S2. Pressure at 4 and 5 are same. So guys, pressure in water at same level is same. Pressure in water at same level is same. Okay, एक काम करो, इसको ब्लॉक करो और इसका वो भी कर दो, वो साइबर क्राइम वाला कर दो, डाल दो फॉर्म, डाल दो दैट दिस ओपिनियन का दोनों डालो इसका। ब्लॉक तो कोई बात नहीं, ब्लॉक तो बहुत छोटा है, वहाँ क्राइम ब्रांच में इसका साइबर क्राइम में इसका रिपोर्ट कर दो। वो आईपी एड्रेस देख के खुद इसको कॉल कर देंगे, जिस भी एरिया का होगा वहाँ कर दो। वो खुद पुलिस वाले खुद कॉल कर लेंगे। उसको लग रहा है मजाक चल रहा है, 3 कमरे का बायजूस है, ब्लॉक करना ही आता होगा उनको सिर्फ। ओके, इसको ब्लॉक करना ही आता होगा सिर्फ, ठीक है। और ब्लॉक करने का मेरा कुछ नहीं होगा, सिर्फ इनको ब्लॉक करना ही आता होगा। अब इसका क्या क्या होगा वो खुद ही वो पुलिस वाले बता देंगे। फॉर्म भर दो, मैं कह रहा हूँ ना, भर दो, कोई कुछ नहीं, वो खुद निपटेंगे। इसको क्या पता, हमारा रोज का काम है। That this opinion before you block, after 30 seconds let me tell you, some police person from the cyber crime, okay, we have, because guys in one day in BYJU'S there is banking classes, civil services classes, IT JE classes, Akash, I guess more than 2000 classes goes in a single day. Okay, out of those 2000 classes it is just one class, and various people are spending and doing some rubbish thing. So for them, the only option is not block. Block is a very single thing. There is some online procedure that it is very routine for us. For you, it takes more time for doing all these things, but because it is a routine process, we just have to click. Okay, so there will be some person calling to you from your IP address. It is very, बच्चों का काम है उनके लिए, आपका ID देख के, IP address देख के नियरेस्ट ऑफिस से आपको कॉल कराना है, क्राइम ब्रांच पुलिस स्टेशन से। सो वहाँ पे आप रिप्लाई कर देना, ठीक है। और अगर आपकी उम्र 18 साल से कम है तो फिर वो आपके पेरेंट्स को भी लूप में लेंगे, ठीक है। और अगर कुछ सॉरी कहना हो कि सर मेरे को पुलिस से ऐसा कुछ कॉल नहीं चाहिए, तो मेरे को abhinav.negi@byju's.com पे कह देना। एक बार तो जाएगा ही क्योंकि मैंने कह दिया है, अगली बार के लिए मैं उनको मना कर दूंगा, ठीक है। abhinav.negi@byju's.com पे एक बार तो अब जाएगा ही कॉल आपको, कि वो अपन ने क्लिक करवा दिया उससे, है ना। अब हमको वो केस वापस करना है, वो देख लेगा, एक बार तो चला गया, है ना। और हो सकता है ना भी करें, हम करते रहो एजुकेशन। और ये बताऊं क्या फ़ायदा, बताता हूँ। 2 तरीके के चैनल होते हैं, एक जो पैसा कमाते हैं, हमारा तो ऐड फ्री कर रखा है हमने, तो ऐड फ्री में तो कोई और बंदा ऐसा और भी नहीं कर सकता, ऐड वाले में कर सकता है, ठीक है। तो हमको वो फर्स्ट प्रेफरेंस पे हमारा केस लेते हैं, ठीक है। ओके, चलो। सो velocity head will be 0. Velocity head will be 0 even if water is moving. Datum head, we measure the height, and pressure head. Guys, now you have heard that pressure is same at all points in a same level. Okay, pressure is same in all points at the same level. You have heard this. Okay. But guys, this is not the correct statement. This is incomplete statement. Pressure at same level is same. Pressure at same level is same only when we can go to those points from water to water. Okay. So 2 to 3 point we can go from water to water. So pressure is same. H1, H1. Okay. 4 to 5 we can go from water to water. So pressure is same. But from 2, 3 to 4, we cannot go from water to water. There is some other medium. So when other medium is coming between, the pressure is not same. Okay. So pressure at same level in water is same is incomplete statement. Pressure at same level in water is same or in liquid is same when both the points can be traveled from the same liquid. Some other medium is not coming. So here the total energy is H1. The total energy is H1. 0 plus H1 plus 0 is H1. Here it is H2. Here it is H2. Here it is H2. Okay. So if I draw the total energy, here it is H1. Then there is a loss in soil, and again here it is H2. This is total energy line. And the loss is, here it is H1, here it is H2. Loss is H1 minus H2. See guys, here there is no loss. I made a constant because in 2 and 3 there is same energy. Here also I made a constant because 4 and 5 there is same energy, S2, S2. 4 and 5 there is same energy, S2, S2. Okay, so loss is here in the soil. So loss never occurs in water because as we are going down, datum is decreasing. Datum is decreasing H1 to 0, but pressure is increasing by same amount. As we are going down, datum is increasing from H1 to 0, but pressure is increasing by same amount. Okay, so there is always loss in soil, not in water. Now, as there is less energy, so water will go. Now, many people ask what is the difference between seepage and permeability, guys? Same. Permeability is just the representation of speed. Permeability is just the representation of speed. And guys, permeability is representation of speed and seepage is the representation of discharge. Seepage is representation of discharge. Okay. Now, guys, one more thing. The total head is pressure head plus datum head plus velocity head. Now, velocity head is equal to 0 in soil. Velocity head is 0 in soil, and pressure and datum has had one more name, piezometric head. Piezometric head is summation of pressure and datum head. So guys, total head is piezometric head. Okay, total head is piezometric head in soil mechanics. Okay, Sophia, first of all, velocity head has to be 0 at every point. Velocity head is 0 at every point because even if water is moving in soil, we have to write 0 because speed is very, very less. Datum head, 2, 3, 4, 5 are at datum. So the datum head is 0. What is the height of 1 point from datum? H1. Okay, what is the height of 6 point from datum? H2. Okay, pressure head, here there is no pressure. At 2 the pressure is H1. At 2 and 3 at same level, so pressure is H1. Similarly, here there is no pressure, 0. Here the pressure is H2, and this are the same level, it is H2. So total head is summation of this is equal to this. So it is H1, H1, H1. Here the pressure is H1, H1, H1. Here the pressure is S2, S2, S2. Okay, and in soil there is a loss. Okay, total head is pressure head plus datum head plus velocity head. Velocity head is 0 in soil mechanics. Pressure head and datum head is called as piezometric head. Pressure head and datum head is called as piezometric head. So total head is piezometric head. Okay, got it? Okay. Now, what is quicksand condition? Guys, see, everybody now understand for next 5 minutes. Important. For next 5 minutes, please do understand whatever I'm telling you. Okay? Whatever I'm telling you, please try to understand for next 10 minutes. Guys, kahan gaya? Everyone, see, sigma bar net is equal to sigma bar old plus minus HL into gamma W. First of all, what is this yaar? What is this yaar? Sigma bar is the effective stress. Sigma bar is the effective stress. Sigma bar old means, what is old? Old means we have studied earlier. That is assuming hydrostatic condition, no seepage. Assuming hydrostatic condition, that is no seepage. Because guys, when you are assuming hydrostatic condition, when you assume hydrostatic condition, na, what you write? When you assume hydrostatic condition, what is the pressure at H height? What is the pore water pressure at H height? Gamma WH, na? So gamma WH only you can write when there is hydrostatic condition. Okay, when there is hydrostatic condition, then only at H height you can write gamma WH. Otherwise, if water is moving, then you cannot write the pressure as high gamma WH. It will be something else. Okay, it will be something else in that case. Okay, it will be something else in that case. Got it? Okay, so at H height, pressure is gamma WH only in hydrostatic condition. When water is moving, it is not gamma WH. What is it? I will tell you. Now understand, guys, for next 10 minutes, if you understood me very clearly, na, everything will be cleared. For next 10 minutes, if you understood me clearly, na, everything will be cleared. Now see, sigma bar old is hydrostatic condition. Plus means for downward seepage. Minus means upward seepage. Y for plus downward and Y for minus upward. That also answer I have. See here, everyone. Guys, this is Abhinav Negi. So there is some contact pressure between me, my foot and floor. Suppose somebody is pushing me downward. This contact pressure will increase or decrease? Somebody is pushing me downward. My contact pressure between my floor and foot will increase or decrease? Contact pressure between my foot and floor will increase or decrease? If somebody is pushing me downward, increase na. So sigma bar increases for downward pressure, downward seepage. Suppose this is again Abhinav Negi, and here is the contact pressure between me and my foot, and somebody is pulling me like this. Somebody is pulling me like this. Somebody is pulling me like this. Okay, so my contact pressure will increase or decrease? My contact pressure of my foot and the floor will increase or decrease? It will decrease here. So for upward seepage, it will decrease. It is decrease. Now, guys, what is critical? Upward or downward? Critical case is what? Upward, because I don't want to be minus, na. I don't want sigma bar to reduce. I don't want the sigma bar to reduce. Okay, I don't want sigma bar to reduce. So I don't want minus here. Okay, suppose this is a soil. Okay, suppose the length of the soil is Z, and suppose it is upward seepage. Now, what is sigma bar net at this point? Old. In old case, it is gamma summa Z. When it is hydrostatic, it is gamma summa Z. When it is hydrostatic, it is gamma summa Z. Okay, minus upward seepage minus HL gamma W. HL into gamma W. So it is gamma summa Z minus I is HL by L, na? I is HL by L. Length is Z here. And let it be IC. It is the critical gradient. IC, HL is IC into Z. IC into Z into gamma W. Why I am saying critical? Because it is that gradient when effective stress is becoming 0. Okay. This is IC when effective stress is becoming 0. Okay. When IC is becoming 0. IC is that gradient when it is becoming 0. That is what is special, critical gradient. Z to Z is cancelled. IC is gamma summa Z upon gamma, Z to Z will be cancelled, na? Gamma summas upon gamma W. Gamma summas I told you G minus 1 upon 1 plus E into gamma W. So it is G minus 1 upon 1 plus E. So critical gradient is G minus 1 upon 1 plus E. E can be written as N upon 1 minus N. If you solve this, this will be G minus 1 into 1 minus N. This is the critical gradient. And what is this critical gradient significance? This is that gradient when this becomes 0. Okay, this is the gradient when this becomes 0. Okay. Tell me. IC is that gradient when this becomes 0. Okay, IC is that gradient, S is that critical gradient when it becomes 0. Got it? Everyone? Got it, everyone? Please tell me. Okay. No. Now, factor of safety is IC by I. This is called critical gradient, busting gradient, floating gradient. Okay, IC by I is factor of safety, because if I is lesser, if I is less, factor of safety will be more. Because if this gradient is lesser, this minus value will be lesser. If this minus value will be lesser, this will be more. It is good for us. Okay, this I is less for general case, but it is not IC, it is normal I. It is less, this will be more positive. So it is good. So when I is less, this is factor of safety will be more. And guys, this IC will be near about 1. Whenever you are doing calculation in GATE or any competition examiner, this has to be 1. If it is not coming around 1, that means you are doing some mistake. If it is not coming around 1, that means you are doing some mistake. Okay. Why it is coming around 1? Because G value is around 2.6 to 2.7. G value is around 2.6 to 2.7. And E value is around 0.6 to 0.7%. Okay, so 2.6 to 2.7 near about and minus 1. That means it is 1.6 to 1.7. And E is 0.6 to 0.7. So it is also 1.6 to 1.7. So value will be near about 1.91, 1.1 in this range. Okay. Now, moving forward, everyone, okay, moving on, everyone, how, guys, here this formula is also valid. If water is moving, the seepage, considering it not to be moving, considering a hydrostatic plus minus HL by gamma W, this is valid. Otherwise, this is also valid. This is still valid. This is still valid, guys. This is still valid. But here you have to written actual U, not the hydrostatic. If water is moving, you have to write the actual U, not the hydrostatic U. Give me yes or no. Give me yes or no. Everyone, please. Okay, no. Effective stress 0 means, let me tell you how this will be looking like. Okay, let me tell you. This is how this is looking like. This is looking like this. This is quicksand condition. Sigma bar this. Sigma bar is 0. Particles are having no interaction. Contact force between the particles is 0. This is quicksand condition. Now guys, my second question is, why it is quicksand condition only? Why it is quicksand, not it is quick clay? Why it is quicksand, not quick clay? why it is quicksand or not quick clay? Okay, because guys, in quick clay, everyone, in quick clay, everyone please listen. In quick clay, even if effective stress is zero, even if it is effective stress is zero, still there is some attraction due to cohesion. Still there is some attraction due to cohesion. So we cannot say it is zero strength. Even if effective stress is zero, even if there is no force between the particles, even if effective stress is zero, even if there is no force between the particles, still there is some attraction between the particles due to cohesion. So we cannot say that the strength is zero there. Have you got it? Have you got it? Have you got it? Okay. Now guys, see. Suppose, let me tell you, this is a dam. This is a dam. And in this dam, suppose water is here. And here the water is here. Now water goes from high head to low head. These are the flow lines. Waters go from high head to low head like this. Okay. Now guys, here it is good. Here it is good. It's downward seepage. Downward seepage. Sigma bar is equal to sigma bar old plus HL into gamma W. It is very good, yeah. Good. Downward seepage is good. It is increasing the strength. But here when it is upward seepage, in upward seepage, oh my god, here it is sigma bar old minus HL gamma W. Here it is a worry of concern. Here there may be a failure. Okay, because of upward seepage. That is why we put a sand bed filter here. That is why we put a filter here. And this filter is such a way that from here it is applying a downward weight to resist the soil, not for soil to quicksand failure or a piping failure. It is protected weight, applying the downward weight. And it is such that water can pass through this. Water can pass through this. If water is not passing, it is creating pressure, cumulative pressure. So water is passing through this, but soil particles cannot pass. Otherwise, there is erosion. Okay, such particles, aggregates are put in it. So it is having some weight, but water cannot pass from it. Okay. 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 Okay, so guys, either a protective bed or some sheet piles are also used. If we are using sheet piles, then water has to move very large distance. In this case, the water has to move large distance. So energy of water at that point is less to cause erosion. The details of the protective, the drainage filter is made up of material. Okay, the D15 of filter means from which the material is made. D85 protective material means our soil. Our soil D85 and filters D15 should be in this range, like these other specifications. Okay. Now guys, here it is tan alpha 1 by tan alpha 2 is equal to K1 by K2. Okay. So K1, K2 is given, alpha 1 is given 30 degree. So alpha 2 can be find out. Alpha 2 can be find out. Now do this. Do this. This is not, this is 0.65. 0.065, this much small void ratio is not there. This much small void ratio is not there. Factor of safety is equal to IC by I. Okay. So what is I? G minus 1 upon 1 plus E. So 2.65 minus 1 upon 1 plus 0.65. So 1.65 upon 1.65 is 1. Okay. So, and what is I? I is HL by L, na? HL by L. So what is HL? Under a total head difference of 2 and 4. So 2 and length is 4. So it is 0.5. So 1 upon 0.5. So it is 2. Answer is 2. Answer is 2, guys. Have you got it? Have you got it? Everyone? Everyone, please. Okay. Now, what is the liquid limit of the soil? What is the liquid limit of the soil? For liquid limit, we'll put n is equal to 25, na? So that will be liquid limit. Correct? Correct? When n is equal to 25, that is the liquid limit. Okay? Now do this. Guys, for variable test, when the time is same, 0 to 10, 10 minutes, 10 to 20 is also 10 minutes. 0 to 10 is 10 minutes, 10 to 20 is also 10 minutes. Then H2 is equal to H1 plus H3. If this is satisfying, then this will be consistent. Okay. If it is not satisfying, it will be inconsistent, which may be MSQ, guys. Please check. So, these is, please check, is 32 square is equal to 40 into 25.6. Please check. Is 32 square is this? Please check. Is it this? Okay, for B, please check if 30 square is equal to 40 into 22.5. For C, please check is 20 square is 40 into 12. Is 36 square is 40 into 32.4. So which is matching? It is not matching. C is not matching. C is not matching, you are saying. So okay, A, B and D, MSQ. Okay, do this. Do this. Everyone. Come on. Please do this. Okay, when the head is doubled and length is used, this discharge will be Q is equal to KIA. So KI is HL by L into A. Now what is happening when the head is doubled? So 2 times and length is half. So discharge will be 4 times. 2Q. Shaumik, please check. When the head is doubled and length is half, the discharge will be 4 times, na yaar? Okay. Okay. Let's move forward now. Let's move forward. Everyone ready? Please tell me. Please tell me. Okay, because discharge velocity or true velocity is the actual velocity. Permeability more means velocity is more. Okay. Permeability more means velocity is more, but actual thing is represented by velocity or true velocity only. Okay. Now, okay, yeah, flow net. Guys, see, suppose water is here up to this level and water here is up to this level. So from high head to low head, water will be going now like this, like this, like this. Actually, one flow line is this also. Okay, why it is going? Water goes from high head to low head. Okay. Now, guys, in all these points, this blue one is the flow lines. This one is flow lines. Also represented like this. Now there is equipotential line having same head. Guys, all these yellow points having same head. Datum is same, all are at same level. Pressure is same, whatever is the height. Okay, and velocity head is 0. Similarly, this is same head, this is same head, same head. All these points are at same head, all these points are at same head. So this is equipotential line. Equipotential line means same energy represented by phi. Now, how many flow lines for this figure? How many flow lines for this figure? 1, 2, 3, 4, 5. Actually, this is like this. 5. Okay. And how many equipotential lines are here? 1, 2, 3, 4, 5, 6. Of course, this is also equipotential line. This is also equipotential line having same energy. So 1, 2, 3, 4, 5, 6, 7. So this is 7. This is 7. Okay. Now, my friends, what is drop? Number of equipotential drop. Number of equipotential drop. That is ND. Okay, see, water is going from here to here. So 1 drop. Water is going from here to here. 1 drop. Water is going from here to here. 1 drop. Water is going from here to here. 1 drop. Water is going from here to here. 1 drop. Water is going from here to here. 1 drop. This is same energy. Then this is same energy. So from here to here, 1 drop. Then 2 drop. Water is going like this now. Water is going like this now. Water is going like this now. So 1 drop, 1 drop, 1 drop, 1 drop. So 1, 2, 3, 4, 5, 6. So here also 1 drop from here to here. Then here to here 2 drop. Water will go like this. 1 drop. Water will go like 4 drop, 5 drop, 6 drop. 1, 2, 3, 4, 5, 6. So it is 6. That is actually number of lines minus 1. And there is one more thing, that is number of flow fields. Number of flow fields is equal to NF. Okay, so water will go either from this putty, this strip. Water will go either from this strip. Water will go either from this strip, or water will go either from this strip, either from this. So it is 4. So it is again 5 minus 1. And not going the derivation, guys, but the discharge, the water going from here to here, the water going from here to here, that is K into H. H is the head loss. This is HL, the difference of head here, into number of flow fields upon number of drop. Okay, number of flow fields and divided by number of drop. Give me yes or no. Everybody till here, give me yes or no, please. Please. Any doubt? Okay. Let me tell you one, even if you want to go more deeper, na, if I put piezometer here, if I put piezometer here, if I put piezometer here, okay, so piezometer will be rising the water up to this, but in this point piezometer will be rising to same points, same level, because they are at same equipotential line. So head has to be same, they will rise to the same level, and that loss is total loss upon number of drops. Okay, loss will be there na, from here to here loss, 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 from here to here to here loss. So loss from this line to this line, there are total how many, in how many steps the loss is happening? 6 steps. Total loss is HL. So from here to here this much na, here the water is rising to this level, here the water is rising to this level, both same. This and this point both has to be same because it is at same line. So this loss is actually head loss divided by 6, because in total loss is HL and has to be done in 6 drops, that is ND. So again from here to here there is HL by ND loss. Yes, Anwar. Okay, so this क्या कहते हैं, this flow net ना, this is called flow net. The lines, flow lines and potential line, the combined is called as flow net. This has been come from this Laplace equation. Okay, now that phreatic line is not coming in gate, so I'm not telling you this. Yes, do this. This is 3 meter. Do this question. Phreatic line wala cheez and that transform equation I'm not doing here. Do this please here. Tell me. So क्या बताना है? Factor of safety against piping failure. So piping will be of course here na. Okay. The piping will be of course this upward. Okay. So what is I? G minus 1 upon 1 plus E. So what is I value? Tell me please. Should be coming around 1. Should be coming around 1. Tell me the value of I. Tell me the value of I. 0.38 cannot be there. Na? I has to be near about 1. Yeah, I just told you. If I is not coming as a final answer, you are saying. I is 0.918. Okay, sir. Okay. Now, here, what is I exit? I exit is head loss at the exit upon length of the exit. So length of the exit is 3. Now what is the head loss from here to here? Now guys, tell me the NF here. Number of flow lines. Either the water can go here from like this, like this, like this, like this. So NF is 4. Okay. Either the water can go like this from here, from here, from here, or from here. 4. What is ND? From here to here, 1 loss. 2, 3, 4, 5, 6, 7, 8. From here to here, 1 loss. Then second, third, fourth, fifth, sixth, seventh, eighth. Okay. So, guys, there is total loss of 10 minus 1.5. That is 8.5. Total loss is 8.5. And that 8.5 loss is occurring. 10 minus 1.5. That is 8.5. This 8.5 loss is occurring in 8 drops. So, in every drop, this is the loss. Okay, the total loss is 8.5. Now from here it is 10, and here it is 1.5. So 10 minus 1.5 is 8.5. So total loss is 8.5 in 8 drops. 1, 2, 3, 4, 5, 6, 7, 8. So from here to here, in every drop loss is assumed to be same. In every drop loss is assumed to be same. So from here to here, what is the loss? 8.5 by 8 upon length is 3. What is I exit? What is I exit? What is I exit? Tell me on the comment boxes, everyone. Everyone. Point 354. This is 0.354. And factor of safety, what is the factor of safety? Is equal to IC by E. This is 0.918. IC by I. At exit it is 0.354. So what is this value coming? What is this value coming? Please tell me. What is this value coming? 0.35. How it can be 0.35? Yeah. Acha, 0.35 you are telling me this value. I am saying 2.59. So this you are saying 2.60. Everyone got it? Everyone got it? Please let me know, yaar. Come on. Okay, this phreatic diagram is not much required. That is why I am not teaching that. Okay. And guys, here can you find discharge? Can you find discharge? Yes. Q is equal to K. Q is equal to K. K is given. What is H? What is H? Head loss 10 minus 1.5, that is 8.5 into NF by ND. Into NF by ND. So Q also can be find out. Okay. Okay. So guys, vertical stress is only formulas here. Vertical stress is only formula. Means if I am doing this and you are reading from the notebook, it is same. Okay. Let me tell you. The Poisson Q is also, guys, at a Q point at Z distance below, R distance away. There is some formula for finding the vertical stress. That is KB into Q by Z square. Okay. KB value is this. Okay. One special case occurs here. If the R value is 0, that means the point is exactly below the point load. That means that the point is exactly below the point load. So if R is 0, then the KB value is 3 by 2 pi. Okay. So exactly below it is maximum stress, and as you are going farther, it is getting lesser. So here it is purely empirical formula, guys. So then Westergaard has given its own formula. That was KB into Q by Z square. It is KW into Q by Z square. Okay. Then comparison. Okay. So one is like this. At 1.5, both the values are same. Okay. At one is KB, one is KW. Okay, KB is 0.47 and KW at R is equal to 0 is something 0.318. At 1.5, both the values are same. So again, one more formula for this. One more formula for this. Okay, when it is a Q load acting on a rectangular, then the corner of a rectangle and at Z distance below. What is sigma vertical at point? It is Q into I sigma. I sigma is a function of M and N. I sigma is a function of M and N. M is L by Z, N is B by Z. Okay, and this is the function of I sigma. Okay, this is the function of I sigma. So of course I sigma will be given. So this formula, that sigma vertical at any point P is I into sigma. Okay, the sigma vertical at any point P is Q into I sigma. Now this I sigma is a function of M and N. M is length by Z, length of this and width of this. Of course, that this big formula is not required. Na? So when point is this formula, na, that I into sigma, this formula I into sigma, Q into I into sigma is only valid for the corner. Is only valid for the corner. Suppose the point is not at the corner. Okay, in this Q load is acting and it is asked here. So we divide this in 4 rectangles. So Q into I sigma 1 of this, Q into I sigma of this, Q into I sigma of this, Q into I sigma of this. When point is outside, stress is only acting here. The point is here. So then make a imaginary. Okay. So Q into I sigma of this, minus this, minus this. This is 2 times minus, so 1 time plus. Like these kind of empirical things are coming. Okay. Okay. So guys, almost 70% is complete. Okay. Now we are going here in the consolidation of soil. Now we are going in the consolidation of soil. Any doubt till here? Please tell me. I sigma is a constant that depends on M and N. Okay. ब्रेक चाहिए यू आर सेइंग तो एक पोल करा लेते हैं एक पोल आया होगा उस पे कर देना एग्जिट ग्रेडियंट इज एच एल बाई एल ना एक बार रिवर्स करके समझना जो डाउट है मेरे से पूछ लेना कमेंट पे एग्जिट ग्रेडियंट इज द ग्रेडियंट एट द एंड ओके इनमें से एक बार है ना मैंने पोल टेलीग्राम पर भी डाला है आपको अपन तो पढ़ेंगे सबसे ज्यादा दिक्कत किस में आती है इन विच यू फाइंड मोस्ट डिफिकल्टी इन विच ऑफ दीज यू फाइंड मोस्ट डिफिकल्टी प्लीज टेल मी बता दो। सबसे ज्यादा दिक्कत। और एक बार पोल का रिप्लाई भी कर दो, एक बार पोल का रिप्लाई भी कर दो। ब्रेक का आई पुट अ पोल अबाउट ब्रेक ना। आई पुट अ पोल अबाउट ब्रेक। I didn't get भाई। ओके 60% सेइंग यस। ओके पर स्टिल अच्छा अच्छा लिख दिया बच्चे ने टॉपिक। बच्चे कह रहे हैं कौन कौन से टॉपिक कह रहे हैं? स्टेबिलिटी, shear strength, स्टेबिलिटी, अर्थ प्रेशर एंड shear strength, shear strength। ओके ओके स्टेबिलिटी में तो फॉर्मूला ही है यार, स्टेबिलिटी में ज़्यादा कॉन्सेप्ट है ही नहीं, स्टेबिलिटी वाले में ज़्यादा कॉन्सेप्ट है ही नहीं यार। Okay, this is Telegram group, Civil by Abhinav sir. This is Richa ma'am's class tomorrow, hydrology and irrigation. And consolidation will start. तो टॉपिक ठीक है, ब्रेक के बाद करते हैं, ब्रेक के बाद करते हैं। Let us take a 15-minute break. 15 मिनट ब्रेक लेते हैं, ठीक है? ब्रेक, resume at 5:25 करते हैं, 5:25 PM. Guys, please be watch it complete, only live session. Okay. ओके ओके, मैं एक नंबर भेजो, मैं आपको फोन पे करता हूँ, व्हाट्सएप पे भेजना, लेकिन व्हाट्सएप पे फोन पे नंबर भेजो। ओके 5:25 मिलते हैं। ओके थैंक यू। हेलो 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 5:25। Hello. Hello. Okay, guys, ready? कर देंगे. We'll do it. We'll do it. चले. Consolidation पढ़े. Let's start consolidation. Voice clear? Everyone, please. Everyone, guys, keep sharing. चलो. Ready, guys? Survey I'll take. So let's start with the consolidation. Now see, guys, first of all, when it is a partially saturated soil, that is solid, water and air, and you are applying a load on it. Okay, you are applying load on a partially saturated soil. So due to application of load, first air void is removed. Okay, the air voids are removed. First it takes, I also told you in compaction chapter So when, guys, you apply the load, first of all air void is removed, and if sufficient load is applied of sufficient magnitude, then all air voids are removed. This is compaction. This is called immediate settlement. It is very fast, instantaneous. Okay, no, you started from here only. This is the first slide. Okay, when you apply the load in a partially saturated soil, so first air void is removed. Okay, and air void is removed. If sufficient amount or magnitude of load is applied, then all air voids are removed. That is the immediate settlement. Okay, now, guys, if further load is applied, then water is also removed. Okay, then water is removed. That is called consolidation. This is compaction, and removal of water is called as consolidation. Okay, removal of water is called as consolidation. So it is compaction, air void is removed, and then water is removed. That is consolidation. It doesn't take time, it is immediate. It takes time taking, and the reason is very simple. Because the movement of water is not like Usain Bolt. Water moves slowly. So it takes time. So it is primary consolidation, removal of water, and secondary consolidation. Okay, primary consolidation is SC also, this is SS also. Okay, so total settlement is immediate settlement, that is removal of air voids. First air voids are removed, then when all air voids are removed, soil becomes saturated, then water is removed, that is called consolidation. Primary consolidation, secondary consolidation. What is primary, what is secondary, I'll tell you. Guys, unless mentioned, consolidation in this chapter is primary consolidation. Unless mentioned, consolidation in this chapter is primary consolidation. Consolidation in this chapter is primary consolidation, that is removal of water. Okay, whenever I will be saying consolidation, that means primary consolidation. In primary consolidation, water is removed. Okay, may not be all water, but some water. Okay, it will take 3 years, 5 years, 8 years. Now, what is secondary consolidation? First of all, guys, it is significant only in plastic soils like clay. Significant in plastic soils. Okay, plastic soils is clay. The secondary consolidation is, suppose there is some very viscous, very thick, very viscous liquid. Okay, someone is very thick, very viscous liquid. If that very thick, very viscous liquid is going out of the system, if that very thick, very viscous liquid is going out of the system, then guys, if very thick and very viscous liquid is going out of the system, then that is called as secondary consolidation, or rearrangement of particles in a more denser state. Rearrangement of particles in a more denser state, or very thick liquid is going on, that is secondary consolidation. That is very small amount. Okay, so majorly the normal water which is going, that is primary consolidation. Major settlement is due to primary consolidation. This is only significant in plastic clays. Otherwise, that very thick liquid going away or particle is going into more dense state in a plastic soil is only significant in clays, and that also not very, very high. Now, the immediate settlement is given by this formula, and the notations are written. Okay, Q is the, what is the pressure acting on this, B is the width of the foundation, mu is the Poisson ratio, ES is the Young's modulus or modulus of elasticity, and IF is the influence factor. Okay, ES is modulus of elasticity, IS is the influence factor. Now guys, moving forward, there is a term OCR. OCR is pre-consolidation stress and present stress. There are two types of soil, NCC and OCC. NCC soil means the OCR value is less than 1, and OCC soil means overall consolidation ratio is greater than 1. NCC soil means that today's stress, whatever acting on the soil, is maximum. Today's stress, whatever acting on the soil, is maximum. Present stress is maximum. Okay, in history, pre-consolidation means history, that much stress has never been applied. At the earlier stress, the history soil is maximum, so it is less than 1. In OCR, guys, today's stress is very, very less. This is very, very less. In history, the soil is acted by a large amount of stress. In history, the soil is acted by a large amount of stress. Okay, today's stress is not that much. Today's stress is not that much. Okay. Now guys, if there are two soils, tell me on the comment box. If there are two soils, NCC and OCC, and you are applying the load, in which soil there will be more settlement? In which soil there will be more settlement? NCC or OCC? In which soil there is more settlement? NCC or OCC? Guys, the settlement will be more in NCC, because here OCC, you are applying stress today is very less. Already in history it is acted by large amount of stress. Already it is settled. Okay, already it is settled. Today's stress is very, very less, so it will not settling more. But in NCC soil, earlier the very less stresses are acting. Today the stress is maximum, so it will be settling more. So more settling, and here it will be less settling, because OCC is already acted in history. It is already settled. Okay. Now, guys, I am not going into derivation, but delta V by V naught, change in volume upon the original volume, is delta H upon H naught, that is the original thickness, and delta E upon 1 plus E naught. Okay, delta is change in void ratio. Already I have derived this many times, but not here. Guys, this derivation is very easy, because soil is considered to be semi-infinite. Always guys, soil is considered to be semi-infinite. That means area is infinite. Area is infinite. depth is finite. So area is not changing. We are never, guys, see, you have heard that water table is 3 meter below. You have heard that water table is 30 meter below. You have heard that water table is 50 meter below. But you never heard that water table is 50 meter below for 100 kilometer square area. Okay, so only we are considering depth. You have heard that sand is 3 meter. You have heard clay is 4 meter. You have heard dry sand is 7 meter. You have never heard that dry sand is 7 meter for how much distance? So area we are never considering. We are taking that as infinite. Even the water movement also we are considering. Okay, we are assuming that water movement is also in the vertical direction. Okay, so although total change in volume is only due to height. Okay, delta V is delta H into A. Okay, V naught is also H naught into A. So A cancelled because area we are not considering to be any change. Okay, delta E upon 1 plus E naught I have derived, not going here in the derivation. Now guys, if I make a curve of E and sigma bar, then the curve is like this. Okay, with less stress, more void. When the stress is more, so voids are reduced. It is compressed. So this slope is called as coefficient of compressibility, represented by AV. What is the stress? Y2 minus Y1, E2 minus E1 delta E upon change in effective stress. Now, what is coefficient of volume change? MV. MV is AV upon 1 plus E naught. Okay, coefficient of compressibility upon 1 plus E naught. What is coefficient of compression? This is valid for NCC soil. If I am making void ratio and sigma bar curve, then it is a curve. But if I am making void ratio and log sigma bar, if I am making void ratio and sigma bar, that is a curve. But if I am making void ratio and log sigma bar, that is not a curve, that will be a straight line for a NCC soil. Okay, and slope of this is CC. Slope of this is CC. So here it is E1, E2. Here it is a log sigma 1, log sigma 2. Okay, so what is CC? Slope of this? That is Y2 minus Y1 delta E upon log X2 minus log X1. So log X2 minus X1 is log B by A. Okay, that is log B by A. Now, my friends, my commandos, my champions, everyone on the comment section, this can also be written as delta E upon, guys, log sigma 1 sometimes represented as sigma naught bar. Here you represented sigma 1 bar, you represented by Alia Bhatt, you represented Vidya Balan, you represented by sigma bar, you represented by K, you represented by dollar, you represented by dinar. It's your choice. Okay, so sigma 1 is sometimes represented as sigma naught bar. And sigma 2 is represented as sigma naught plus something. Guys, two variables, you can take it as X or Y. Okay, or you can take it as X and Y you can write down as X plus something, X plus delta. Ultimately there are two variables, na? Either you take two variables as X and Y, or you take two variables as X and instead of Y you can write it X plus delta X. Delta X can be positive, negative, anything. Okay, got it? Got it, everyone? Okay. Now, guys, CC is a better thing than AV because AV is a slope of a curve. AV is a slope of a curve. Okay. So, slope of curve changes at every point. But CC is slope of a straight line. CC is slope of a straight line that has to be same. CC is slope of a straight line that is same. Okay. Okay. Okay, guys. Everyone, please tell me. Everyone, please tell me. Okay. This is for NCC. Guys, for OCC soil, where the today's stress is not much, but in history, a very huge amount of stress is applied. Even for that, for OCC soil, which is already acted by in history by a large amount of stress, OCC soil, even I make it log, it is not a straight line. In OCC soil, even I make it log, it is not straight line, it is like this. And guys, slope of this is CR. And this is a very flat slope. I already told you guys that the CR, the flat line, The flat line. Why? Because OCC, I told you, na, the stress will not be much. Guys, OCC, I told you, na, the settlement will not be much here. Okay. OCC, I told you, na, the stress will not be much. Oh, sorry, settlement will not be much. Guys, OCC soil means that is already acted by a large amount of stress. In history, today's stress is very, very less. So settlement will not be much. Guys, if undertaker has already settled some किसी बोरी में आटा था, there in some polythene there is some floor. If undertaker has already applied the load, if now today I am applying, I cannot much settlement, because already the settlement of that floor in the polythene is done by a very heavy weight champion. So if I am applying stress today, it will not be much settling. So void ratio is not changing drastically. Guys, in NCC soil it is changing very fast. It is changing fast. But OCC soil is already acted by lots amount of a big load. So it is not much settlement. So it is CR is the coefficient of this, and that is 1/5 to 1/10 of CC. Okay, so these are slope you have to find. What is AV slope? Y2 minus Y1 upon X2 minus X1 positive you can find out. Okay, this is for OCC soil. Okay. Now again, guys, for flexible footing, na? For flexible footing, contact pressure is same. Okay, but settlement will be different. For rigid, settlement will be same because it is rigid. But contact pressure will be different. Okay. Now, suppose this is flexible footing over granular soil, that is sand or gravel. Flexible, contact pressure is same. X, 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 X. Pressure here, here, here is same. See, these are two parallel lines, na? Parallel curves, so distance will be same. But settlement is different. In flexible, settlement is different. Here it is more settled, inside it is less settled. Okay. Suppose it is flexible. Flexible means contact pressure is same. See, X, 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 contact pressure is same. But in clay, settlement is more at the center and less at the edge, given in IS code. Rigid, settlement is same. So this comes here, settlement same everywhere. But contact pressure is different. Okay. And rigid on clay, settlement is same, but contact pressure is different. More at the center, less at the corners. Okay, so this is the permissible value of the settlement written. Okay. Now, yes. Now two formulas are important here, from which 90% questions are coming from these two formulas. Okay, the 90% questions are coming from these two formulas. What are these two formulas now? Okay, what kiska phone aa raha hai? What is these two formulas? Everyone. One is TV is equal to CV into T by D square. Now, first of all, guys, understand that suppose here is rock and this is a saturated soil. So all water will go here. This is a single drainage. And if it is H, the drainage path is equal to H. Okay. Now, suppose this is a soil and here it is sand. Sand means it is permeable, and here also it is sand. Sand, and this is H. So upward also, below also permeable. Upward also permeable, below also permeable. And water cannot go here. Water can only go in vertical direction. Water can only go in vertical direction. So half of the water will go here, half of the water will go here. This is double drainage, and here the drainage path is only H by 2. Here the drainage path is only H by 2. Okay. Here the drainage path is only H by 2. Okay. Okay. Now D is the length of drainage path. For single drainage, it is H. For double drainage, it is H by 2. So D you understood. Now understood, guys. For next 10 minutes now, whatever the words are coming from my mouth, every single word try to understand with full focus. Every single word try to understand with full focus. Okay? Every single word, try to understand with full focus. Okay? Now, here in single drainage it is H, in double drainage it is H by 2 I given here. What is CV? CV is coefficient of consolidation. CV is coefficient of consolidation, also given by permeability into K by gamma W into MB. Now, CV depends on soil. This is a function of soil, guys. Means if it is sand, then for either it is single drainage, it is double drainage. Just consolidation started, consolidation had end, consolidation has end, consolidation is end process, consolidation is in between. CV will be same. CV depends on soil, nothing else. It is single drainage, double drainage, nothing to do. CV depends on soil particles. Okay. Now TV is a time factor represented by TV or TU. Now what is TV? What is TV? Understand please. What is TV? TV is time factor and this depends on degree of consolidation. Okay. So if degree of capital U is degree of consolidation. Capital U is degree of consolidation. If degree of consolidation is less than 60%. Guys, what is degree of consolidation? Let me tell you. Leave all this. Leave all this. What is degree of consolidation? Let me tell you. What is degree of consolidation? If total settlement of a soil will be 10 centimeter. If total settlement of soil will be 10 centimeter. Okay. If total settlement of soil will be 10 centimeter and it has settled till now 4 centimeter. That means 40% consolidation has done. If total settlement of a soil is 30 centimeter, if total settlement of a soil is 30 centimeter and till now 15 centimeter has been done. So it is 50% consolidation. If total settlement of a soil has to be 10 centimeter and till now it is 0, only started. So degree of consolidation is 0%. If total settlement of a soil has to be 10 centimeter and it has settled 10 centimeter, so 100% consolidation is done. Okay, so U is degree of consolidation, 30%, 40%, 50%, 80%, 90%. That means how much consolidation has done. Now, if U is less than 60%, this is the formula. Suppose U is 40%. So TV is pi by 4 into 0.4 square. Suppose U is 75%. Oh, sorry, U is 32%. So pi by 4 into 0.32 square. If U is 70%, then U by pi by 4 into 0.7 square will be wrong because this is valid only up to 60%. For more than 60%, suppose U is 70%. So you have to apply this formula, putting U is equal to 70. If U is 62, you have to apply this formula and get the value of TV. So TV depends on U. For 30% consolidation of sand, for 30% consolidation of clay, for 30% consolidation of silt, you have to apply here pi by 4 0.3 square, pi by 4 0.3 square. So TV will be same. Now CV depends on soil. TV depends on consolidation. 30% of sand, 30% of gravel, 30% of silt, 30% of clay. Formula will be same. Formula will be same. Okay. Formula will be same. Now, sir, CV I have understood, it depends on soil. Sir, TV I understood, depends on consolidation. For 60% less, this formula. For more than 60%, this is formula. D I understood. Sir, what is this T time? Sir, what is this T time? T is the time of consolidation. But sir, which time? If you are writing the TV for 30% consolidation, pi by 4 0.3 square, then this time will be corresponding to time taken by soil to complete 30% consolidation. If TV you are writing for 80% consolidation, then this T, by putting here 80, then this T, small t, is the time required for completing 80%. If this TV you are writing for 54% consolidation, this time is the time required for 54% consolidation. Have you understood? Have you understood now each and everything of this formula? Have you understood now each and everything of this formula? Okay. Now guys, there is a very big error. The T in single drainage is 4 times of T in double drainage. It is absolutely wrong. Or T in double drainage is equal to T in single drainage by 4. This is absolutely wrong. This is absolutely wrong formula. This is absolutely wrong formula. How? Let me tell you. How? Let me tell you. Everyone. Guys, you write the formula for single drainage. For single drainage, TV is equal to CT single drainage upon D square. You write the formula for double drainage. TV is equal to CT double drainage upon H by 2 square. This is 1. This is 2. So 1 divided by 2, you got T of single drainage is 4 times of T of double drainage. This is only valid. Only valid when you cut this and this, na. That means U is equal to same. Okay. So thickness H and H, thickness is equal to same. Okay. And CV and CV you cancel, na. So soil is equal to same. If this is the thing, then these two formulas are correct. Understood? So randomly we cannot say that in single drainage the time will be 4 times of double drainage, or in double drainage time will be 4 times lesser than single drainage. Randomly we cannot say. Randomly we cannot say, because it is coming when you are cancelling this and this for same degree of consolidation. 30% in single drainage and 30% in double drainage. For same soil, if we are talking 30% single drainage of clay and 30% double drainage of clay. For same thickness of soil, then time will be 4 times less in double drainage or 4 times more in single drainage. Everybody give me yes or no. Everybody give me yes or no. Everybody give me yes or no. Please. Please guys. So not always, but for what I told you, only for that. Give me yes or no. Give me yes or no. Everyone. Same from if you have to find TV from here, na. Kalyan ready. Okay. Okay. And one more thing student do mistake. Guys, total settlement or final settlement has nothing to do with single drainage or double drainage. If suppose here 300 ml of water is there, if I put one ched here, one hole here or 2 hole here, total water will go down, will be same. That is 300 ml. So single drainage and double drainage has nothing to do with ultimate settlement. Single drainage and double drainage has nothing to do with ultimate settlement. Okay. So ultimate settlement will be nothing to, in single drainage will be late, will take time. Double drainage will be faster, but total settlement has to be same. Anwar, difference between permeability is speed. Permeability is speed of water. Okay, consolidation is change in the volume, change in the thickness. Okay, so this is nothing. The ultimate settlement earlier was 10 centimeter. When we are thinking it is draining from top and bottom both. However, detailed surface reveals that there is no drainage at bottom. Earlier we think that there is a double drainage. Earlier we think it is double drainage. But later on we found it is single drainage. But ultimate settlement will be same, na? Ultimate settlement has nothing to do with this. Ultimate settlement has nothing to do with single drainage and double drainage. Okay. So now the same thing. Acha. Now this is consolidation settlement. Guys, if nothing is mentioned, which consolidation? Primary consolidation. S1 degree, not SI. S1 degree. If nothing is mentioned, it is consolidation settlement or S1 degree. Sir, my doubt is when U is less than 60, TV is directly proportional to 1. I am not getting. क्या कह रहे हो? क्या कह रहे हो? क्या कह रहे हो? क्या कह रहे हो? My doubt is when U is less than 60. Okay. Then TV is directly proportional to T. हाँ. तो by the given equation, if U is greater than TV, क्या कह रहे हो? मेरे को समझ नहीं आया भैया. If TV is less than क्या 60, TV is directly proportional to T. This formula is valid for less than 60, greater than 60, both case यार. Both case it is valid. किसी को समझ आया तो बताना मेरे को. Okay, now these are the formulas for the consolidation settlement. Either you can use this MV into delta sigma into this or this. Any of these three formula you can use. Now which formula is to be used, that depends on what is the condition. If MV is given, you have to use this. If CC is given, you have to use this. Okay, so if OCC soil is this, then instead of CC we will be using CR. Instead of CC we will be using CR. So either you have to use this depends on what data it is given. But one more thing, guys, suppose this is clay, this is sand, and some footing is here. Some footing is here. Okay, and I want delta H of clay. So suppose this is H1 height, this is H2 height, this is H3 height. So if I want delta H of clay, so suppose it is NCC soil, it is NCC. So I will use CC. If it is OCC, I will be using CR. H0 is the height of that soil for which I want to find settlement. I want to find settlement of clay. So I will not use H1, I will not use H3, I will use H2 upon 1 plus E0 into 1 plus E0 into log initial stress here when the building was not there. What is the stress? And the stress after that when building is here. Now first of all, guys, stress where yaar? Stress at every point is different, na? Here. So we have to write these values of stress. Either any of these formula here, delta sigma. We have to write these values of stress at the center of clay layer. So it is H2 by 2. So this P point. So we have to write these stresses at P point. Okay, initial stress, that is sigma 1 bar or sigma naught bar, should be written because here stress everywhere is different, na? So we have to write at H2 by 2, that is the thickness mid of this. Suppose this is due to this PA. If nothing is given, we take 2 vertical is to 1 horizontal. Okay, so what is delta sigma? This is written like this, na? Or delta H of clay is equal to CC height of clay E0 of clay log initial stress at mid depth upon sigma naught bar at P plus delta sigma. Delta sigma is coming due to this building at P point. Suppose this area is A. From 2 vertical is to 1 horizontal, you can find out the area A. So this is P by A. This is sigma naught bar. Sigma 1 bar I am writing as sigma naught bar, and sigma 2 I am writing sigma naught plus something. That same concept. Here two variables are x or y or x plus delta x. So sigma naught bar and sigma naught bar plus delta sigma. So delta sigma is P by A. P here, A, because area everywhere will be different, na? Area here will be different. Area here will be different. So we have to find out the mid depth. Got it? We are taking it because everywhere it is different, na? So whenever we in SOM, where we do? In SOM, when it is a linear variation, suppose in RCC it is sigma, if CBC it is 0. Okay, and this sigma is T by M. Suppose this is neutral XA, this is B, this is XA. So what is the force? Stress into area. Area is B into XA. What you write stress? Here you write stress. No, here is something else. Here is less, here is less, here is less, here is 0 at neutral axis. So what you do? Sigma CBC plus 0 by 2, na? Same concept, everything is same, different. Delta sigma here will be P by A of this. P by A of this, P by A of this, P by A of this. So where you will write P of area of blue na? Okay. Okay guys, so this done, this done. Okay, foundation आज ही करना है कि नहीं? You want foundation today? Okay, okay. कितना घंटा हो गया क्लास लिए हुए सुबह से? आज ही करेंगे. कितना सुबह से कितना टाइम हो गया अभी तक? Okay. 8 hours 2 minutes. In 8 hours, how many chapters? 1, 2, 3, 4, 5, 6, 7. Okay. So guys, here is a form where you can click for one-to-one option of counseling. This is for your, in the description box of this video, this is the quiz that will be opening after the class, and from this link, Abhinav Negi, and this link you can go to the app. Okay, so now tomorrow is the hydrology class by ma'am. Then surveying class is not 10. Surveying class is on Sunday, that is 6 p.m. Okay. Okay. इसी में कर देंगे यार, देखते हैं. क्लास तो 9 to 11 है, सोम क्लास. So guys, whatever is the case na, the failure in soil that you have seen in social media, you have seen in YouTube, it is always a shear failure. Neck pain तो है यार ऐसे. हाँ, इधर तो मोड़ पा रहा हूँ, इधर है दर्द, इधर नहीं मोड़ पा रहा हूँ. आज ही करेंगे, ओनली लाइव होगा ये. ओके, दिस इज ओनली लाइव सेशन. मजा आ रहा है कि नहीं एक बार बता दो यार. सब्सक्राइब कर लिए चैनल. जल्दी बताओ अभी तक मजा आया कि नहीं आया. No, not with surveying. एक बार 3 काम, 3 कौन से काम करेगा वो? Have you enjoyed till now? Okay. Now whatever the failure in soil, it is a shear failure. Okay. Whatever is the failure in soil, it is the shear failure. Okay. Okay. Now for no failure, of course, the shear strength, for no failure, the shear strength should be greater than shear stress at every plane. At every plane, whatever is, at every plane, whatever is the shear strength, that should be shear greater than shear stress. Okay. But at every plane, whatever is the shear strength, that should be greater than shear stress. Before I come to this chapter, let me tell you, although we have taught in more circle chapter, but let me tell you here also. Okay, guys, if this is a body and this is on the floor and P force is acting on it, so normal stress is coming on the body or shear stress is coming? Normal stress is coming on this or shear is coming? Normal stress is coming or shear stress is coming? Come on everyone. Normal or shear? Normal or shear? Normal or shear? In XX plane, only normal stress is coming, P by A, and there is no component of P which is tangential to this. So tau XX is equal to 0. Okay. And in YY plane, normal stress will also be coming. Okay. In YY plane, guys, this P force has two components. One is P1 and one is P2. So in YY plane, normal stress is P1 by area of that plane, and shear stress on YY plane is P2 upon area of that plane. Correct? 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 So in YY plane, normal and shear both will be coming. In YY plane, the normal and shear both will be coming. Yes or no? In YY plane, both normal stress and shear stress will be coming. Correct? Correct? Okay. Now, how many planes are there? How many planes are there in this body? How many planes are there in this body? Please tell me. There are infinite planes. Okay, one plane can be this, one plane can be this, one plane can be this, one plane can be this. Okay, so there are infinite planes in this body. Infinite planes will be having infinite normal stress and infinite shear stress. Correct or not? Infinite planes will be having infinite normal stress and infinite shear stress. Correct or not? Correct? Infinite planes will be having infinite normal stress. Infinite planes will be having infinite normal stress and infinite shear stress. Okay. Now, this is a Mohr circle. How many points are in this Mohr circle? This. In the circumference, there are infinite planes. In the circumference, there are infinite planes. So when infinite planes are there, infinite points are there, and every point has an x coordinate and a y coordinate. Every point has an x coordinate sigma and a y coordinate tau. So there are infinite points. Now what these infinite points are representing? In this body there are infinite planes having infinite normal stress and shear stress. at a point there are infinite planes having infinite normal stress and shear stress. At a point there are infinite planes having infinite normal stress and shear stresses. Those infinite normal stress and shear stresses are represented by these points. Those infinite normal stress and shear stress are represented by these points. Those infinite normal stress and shear stress are represented by these points. Yes or no? Yes or no? Everyone, those infinite points are represented by these points. Now, out of those infinite planes having infinite normal stress and shear stress, this point is the maximum normal stress. This point is the maximum normal stress, that is called principal stress, sigma 1. And this point is the minimum normal stress, that is sigma 3. In soil mechanics, we call it sigma 3. In SOM, we call it sigma 2. And these are principal stresses. At principal stresses, which is maximum, this is major principal stress, this is minor principal stress. At maximum principal stresses, that is bigger and one is major principal stress, minor principal stress, shear stress is 0. Shear stress is 0. And this is the point of maximum y coordinate. So this is tau max. Okay. Okay. Now let us come to the shear strength chapter. Now, shear strength is we got from two things, C and phi. Shear strength of a soil is coming from two things, C and phi. C is helping us two ways. Electrostatic attraction. When there is electrostatic attraction between the particles, they will be bonding together, having more cohesion. More cohesion, so they will not shear. Na? More cohesion, if they have more cohesion, they are attached to each other. That means they will not be much shear. Shear will not be there. Shear will not be there. Okay, so they will not be doing like this. They will not be doing like this. They are closely attached to each other. They are closely attached to each other. Okay. So it will provide strength. And C is also coming from apparent cohesion. C is also coming from apparent cohesion. Okay. What is apparent cohesion? Guys, sometimes there is negative pore water pressure. Sometimes there is negative pore water pressure. Negative pore water pressure, pressure means suction. Suction means two particles are joined. So actually this is not cohesion. Due to negative pressure it is sucked up. Due to negative pressure it is sucked up. It is not cohesion. But they are acting like a cohesion. They are attaching each other. Okay. प्यार कर रहे हैं एक दूसरे से. They are attacking each other. They are coming closer each other. That coming is not due to cohesion but due to negative pressure. So it looks like apparent cohesion. Similarly guys, the friction is also with two things. One friction is due to interlocking. Two particles are of different shape and interlocking, causing friction. And one is the two particles are sliding with each other having rough face. So rough face means they will not slide. Rough face means they will not slide. So it is good. They will not slide means shear failure will not be there. So actually this phi is not the friction. It is not the coefficient of friction. But yes, if anything is rough, if anything has more coefficient of friction, the phi will be more. Now, from here, the strength will be C plus sigma tan phi or C dash plus sigma bar tan phi dash. C and phi are total stress parameters. C dash and phi dash are effective stress parameters. C and phi are total stress parameters and C dash and phi dash are effective stress parameters. Now, what is the difference between them? For that, give me 5 minutes. Till then, see this, forget this, I have not taught you this. Understood like this. Okay. Now, for clay, for pure clay, phi is equal to 0. So that means tau is equal to C plus sigma tan 0, that is C. So shear strength is due to only cohesion. Shear strength is only due to cohesion. For sand, guys, C is equal to 0. For pure sand, C is equal to 0. Pure sand and also NCC clay, normally consolidated clay, that also behaves like a sand. C is equal to 0. So for that, tau is equal to sigma tan phi. Okay. Now, everyone please see, if I make a curve like this is tau and this is sigma. So usually the curve will be like this. Tau, this is the curve of more failure envelope. This is strength. More failure envelope. Okay. This is strength. This is strength. More failure envelope. This is strength. Okay. Now, when sigma is 0, so the y coordinate is C. And if I consider this as y-axis, this is x-axis, this is C, so this will be m. So m is tan phi, so this is phi. But this more failure envelope, which is strength, this is tau, this is sigma. For clay it is this, because phi is 0. For clay is this. Okay. And this is tau, this is sigma. For sand, okay, for sand, tau is equal to sigma tan phi. C is 0, na? So C is 0 to start from here. For sand and NCC clay, it will be like this. Give me yes or no till here. Give me yes or no till here, guys. Come on, everyone. Come on, everyone. Come on, everyone. Come on, everyone, guys. Please tell me. Please tell me. Everyone. Please. Please. Everyone. Okay. Got it? Get it and ungot it. Okay. 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 Now, मैं नए पेज में पढ़ाऊंगा. मैं ये पहले से लिखे हुए. I will not teach in already written. I will teach in new page. New slide can I make? Yes, I can make. Okay. Now, everything will be clear, guys. Everything. Suppose this is soil. Okay, and from all around, actually it is put on a triaxial test, triaxial cell, and from water is applied. Water, it is put in triaxial cell, and in triaxial cell water is applied. I have done this in IIT lab because I have done MTech in same subject, na, soil mechanics only. So all around is water, or sometimes we put engine oil also. Okay, so we put in triaxial cell. So when you put in triaxial cell, na, when we put this in triaxial cell, now, so for all around, the water is applying the pressure that is called as confining stress. That is sigma C or sigma 3. Okay. Now, this is sigma C or sigma 3. We add vertical stress only from vertical. This is only from vertical. Okay. We applied the vertical stress only in vertical direction. Sigma D. Sigma D. Okay. So, when we applied the vertical stress only in the vertical direction, so here, this is sigma C or sigma 3. Okay. And I apply sigma D here. So it is sigma 1. Sigma 1. Sigma 3 plus sigma D is sigma 1. Major principal stress I am writing with sigma 1. Major principal stress I am writing with sigma 1. So finally, my specimen is that here it is sigma 3. Here it is sigma 3. And here it is sigma 3 plus sigma D, that is sigma 1. Sigma 3 plus sigma D, it is sigma 1. This is my soil. Okay. Now guys, this is sigma, this is tau. Now, my shear strength more failure envelope is this. Tau is equal to C plus sigma tan phi. this is more failure envelope, and this is also strength. This is strength. Now guys, there are how many planes here? Two into infinite planes. Infinite planes will be having infinite normal stress and shear stress. Okay. Difference between sigma d and sigma 3. Matlab, from sigma 3 is already acting, then we apply sigma d on that. Now there are various planes. In various planes the stress will be like this. I am showing only the top part of Mohr circle, although it will be there also, but it's okay. Like this. So this is sigma 3, and here it is sigma 3 plus sigma d, that is sigma 1 major principal stress, minor principal stress, sigma 3, and this is my major sigma 1. Sigma 1 is bigger. So this horizontal plane, sorry, this vertical plane is minor plane because minor stress is acting. This vertical plane is minor plane because minor stress is acting. And this horizontal plane is major plane because major stress is acting. Horizontal plane is major plane because major stress is acting. So this is like this. So no failure. No failure. Because stress is less and strength is more. This is strength. Tau is equal to C plus sigma tan phi. No failure. Now I apply a bigger sigma d. A bigger sigma d. I apply a bigger sigma d. So sigma 3 is same. Bigger sigma t will be like this. No failure. Strength is more, stress is less. Now I apply a bigger sigma d. Bigger sigma d, so sigma 1 is more now. And sigma 1 is more now like this. Now it is a failure. When strength and stress will be there. When strength and stress are equal. So now there is failure. And this is the failure point. This is the failure point. This is sigma 3, this is sigma 1. Center is sigma 3 plus sigma 1 by 2. Now guys, this angle is phi. Okay, this is 90. So this is 90 minus phi. And this is 90 plus phi. Yes or no? Yes or no? Okay. So this is the failure plane. Guys, see, this is the plane of maximum shear stress. This is the plane of maximum shear stress. Here no, there is no failure because at the plane of maximum shear stress, even strength is more. This is the more failure envelope, not strength. This green one is strength, more failure envelope. Okay. And this red one is stress. Even when stress is maximum, there is no failure because strength is even more there. Okay, strength is even more there. Sigma 3 is only by adding sigma deviator in vertical stress, we get sigma 1, Lakshmi Narayan. Okay, so this is strength and this is stress. This is strength and this is stress. So strength is more than the stress. Strength is more than the stress at this point. So no failure, here is failure here. Now guys, from minor and maxima are at how much angle? 90 degree na? But in Mohr circle, the minor and maxima are 180 degree na? So Mohr circle, everything is doubled. Everything is represented doubled. So angle between minor and failure plane and angle between major and failure plane. See, angle between minor and failure plane is 90 minus 5. So in real life it is half. Angle between major and failure is 90 plus 5. So in real life it is 45 plus 5 by 2. Everybody please put a heart sign if you got it. Everybody please put a heart sign if you got it, guys. Come on everyone. Come on everyone. Now this is the process you have understood. Now guys, sir, how I will be finding C and phi, sir? Sir, how I will be finding the C and phi? Sir, how I will be finding C and phi? I'm not getting this, sir. Guys, very important, I told you. Okay. Okay. Okay, now I take one sample. How to find C and phi? Because this will be drawn one C and phi unknown, na? So one sample. This is sigma 3 1. First sigma 3 minor of first, and this is sigma 1 1. Matlab sigma 3 plus sigma d. Sigma 3 plus sigma d. Sigma 1 1, and this is sigma 1 1 at the time of failure. So sometimes it is in F also at the time of failure. Means I am not drawing these small circles. I am not drawing these small circles. I am not doing this small circle. I am drawing the circles at the time of failure. Okay. So I take sigma 3 1 and sigma 1 1. The first experiment at the time of failure, it will be like this. Sigma 3 1 and sigma 1 1 at the time of failure for the first sample. Okay. Then same soil, sigma 3 of second experiment of second sample of same soil, and sigma 1 of 2. Now guys, if sigma 3 2 is bigger, if sigma 3 2 is bigger, then for breaking this soil sample I have to apply a bigger stress, na? If sigma 3 1 is small, I'm not confining much. So even a lesser stress will fail it. But when sigma 3 2 is bigger, sigma 3 2 is bigger. So a bigger stress is required now for failing it. Correct or not? Okay, so sigma 1 2 is bigger. This more circle will be coming bigger. Because when we are confining more, so a bigger diabatic stress will be required. So this more circle will be bigger. Okay, because this is sigma 1 1 and sigma 3. Difference is diabatic stress, na? So when more confining we are, so then a bigger diabatic stress is required for failure. Okay, and the common tangent, because these both are the failure case, the common tangent will be the strength. This is the more failure envelope. This is the strength. Okay, we draw the common tangent. So this will be C and this will be phi. This is how we find C and phi. And instead of, if I'm writing here sigma 3, we're getting C and phi. If I write effective stress, then we get C dash and phi dash. If we are plotting in terms of total, we get C and phi. If we plot in terms of effective stress, it is C dash phi dash. There is minor variation. Okay, so both have you understood now? Have you understood now? Guys? Come on, everyone. Please, my friends. Please, my commanders. वो wow, so beautiful. कौन सा गाना है वो? So wonderful. क्या है? So beautiful. Just like a wow. So cute. क्या है वो? कुछ तो है. क्या है? So wonderful, so cute, just like so beautiful, so wonderful, just like a wow. नहीं, so beautiful, so पता नहीं. Common tangent. Vishwa, common tangent. 2 experiments, 2 circles. Then draw the common tangent. Okay, and relation between sigma 3 and sigma 1 is this. Sigma 1 is this, or same can be written as like this also. Okay. Now, this 1 plus sine phi and 1 minus sine phi, which is also written like nq or n phi, is actually tan square 45 plus phi by 2. This everyone knows. But only few people knows that this is cot square 45 minus phi by 2 also. So beautiful, so elegant. Huh? 45, because tan theta is cot 90 minus theta, na? So tan theta is cot 90 minus this. Cot 90 minus this is 45 minus phi by 2. Cot 90 minus this is 45 minus phi by 2. Okay, so this can be written as tan square 45 plus phi by 2 or cot square 45 minus phi by 2. And 1 minus sine phi, 1 plus sine phi is equal to tan square 45 minus phi by 2 or cot square 45 plus phi by 2. Tan square 45 minus 5 by 2 or cot square 45 plus 5 by 2. Have you got it? Have you got it? Have you got it? Have you got it? Okay. Now everyone. Guys, see, C and phi are not inherent property of soil. C and phi are not the inherent properties of soil. That means for the same soil, under different testing, C and phi can be different. Yes, you heard me correct. Guys, how many hours I'll be teaching is not constant, na? On different series, on different time. This is the exam time. Students need us. So we are taking marathons. Even I have a class from 9 p.m. to 11 p.m. but I'm taking marathon. Let me tell you guys in last 48 hours, na? Okay, how I am living, I only know. In last 48 hours, how I am living in this earth, only I knows. Okay. Okay. Now, please see, C and phi are not the inherent properties of soil. No surveys. It will be only here. Prince from Talwara Township. Okay. See here. Everyone. Everyone. Please see. Yeah. Okay. Please listen. Listen. Everyone. C and phi are not inherent properties of soil. C and phi are not, they depend on type of testing. Okay. नहीं break नहीं अभी. Break will be now before foundation. C and phi are inherent properties of soil. Depend on different testing. Depends on different case. C and phi for same soil will be different. So we have to test them under the same condition in which it is in the field. Okay, now sir, I have not understood. I also have not understood what I am saying. I also don't understood what I am saying. Okay, let me tell you. Guys, sand should be tested in drained condition, because actually in field sand is in drained condition. Sand should be tested in the drained condition because in field it is in drained condition. Now sir, what does this drained condition means? Drain condition means that when you are doing all this, applying sigma 3 and sigma 1, applying sigma 3 and sigma 1, applying sigma 3 and sigma 1, let water go out. Because guys, for the same soil, when you are doing this experiment, sigma 3 and sigma 1, sigma 3 and sigma 1, and sigma 3 and sigma 1 and finding these values, sigma 3 and sigma 1, when you are doing sigma 3 and sigma 1 and finding these values, sigma 3 and sigma 1 and finding these values, and sigma 3 and sigma 1 finding these values, guys, these values will be different. These values will be different if you allow the drainage and not allow the drainage. In one case, you are not allowing the drainage water to go out from sample by putting some impermeable member here and impermeable member here. You are not allowing the water to go out. Okay, impermeable member here, impermeable member here. You are not allowing the water to go out. And do these experiments. There will be some C5. Now, in second case, you are allowing the water to go out. When you are applying stress, water can go out. When you are applying stress, water can go out. When you are applying stress, water can go out. When you are applying stress, water can go out. Drained condition. In that case, CN5 for the same soil will be different. That means that for a same soil, CN5 depends on type of testing. Guys, I am like, my engine is like a bullet, yaar. As class goes on, my energy will be increasing, yaar. So, for the same soil, when you're allowing the water to go, C5 will be different. When you're not allowing the water to go, for the same soil, CN5 will be different. Now, sir, where the same soil, depending upon the condition, we are getting different CN5. So, what we have to do? We have to simulate the field condition. If in field it is sand, generally it is in drain condition. Water is going out. So we should be doing the experiment. By allowing the water to go down. Generally in clay, it is undrained condition. Permeability is very, very less. So undrained condition. Okay. So here also we put some members there, so water is not going down. We put some members there, so water is not going down. Water is not going out. So we can simulate the field condition and get CN5 related to field condition. Because CN5 will be different here upon the type of testing. So sand should be done this and clay should be this. However, for the worst extreme exceptions, suppose Mayawati is Chief Minister of UP and Mayawati is going to come to a village. So suddenly a Mayawati sculpture or murti has to be made. What is murti in English? The statue of Mayawati has to be made suddenly. Because to show the Mayawati, the Pradhan, the Sarpanch, the head of the village wants to impress her. So suddenly the murti has to be made. So in that sudden construction, even sand can be in undrained condition. So exceptions are there. And might be the construction is so that one brick I am putting today, one brick I am putting after 3 months, one brick I am putting after 3 months, and 200 years it will take to construction. So even clay can be a drained condition. But usually, generally it is like this. So we should do testing, allowing the water to go out or not according to this. Now let me tell you one more beautiful thing. Guys, if excess pore water pressure is positive, so testing stability should be checked. Should be checked immediate after construction. Stability should be checked immediately after construction. What is happening? Because sigma bar is equal to sigma minus U. U is U hydrostatic plus U excess. So U excess is positive now, so sigma bar will be less. And we should check in the least sigma bar. If whenever it is least sigma bar, it is stable there. So it is anyhow stable later on also. So if U excess is when maximum positive, okay, initially, later on, after some time it will be dissipating, now it will be 0. So initially it is maximum, so it is minimum. So we should check initial stability of that building. If U excess is negative, so initially sigma bar will be more. Because extra pore water pressure is negative. After some time when it becomes 0, then sigma bar will be reduced. So when u-axis is negative, we should check the long-term stability because initially it will be stable, na? U-axis is negative, so sigma bar will be more. It is good. It is stable. So when u-axis is negative, we should check after a long time. Everybody, please put 2 heart signs on the comment box if you got it. Everybody on the comment section. अब बैठने में ज्यादा थक लगती है, बैठने में ज्यादा थक लगती है. Understood or not? Do this. अच्छा, यही करना है, यही करना है. Now guys, everyone, please see how to find C and phi. Guys, this arrange, this is कहाँ गया? कहाँ गया? These equations are there, na? So if these equations are rearranged, if these equations are rearranged, then this equation is written as sigma 1 minus sigma 3 by 2 is equal to sigma 1 plus sigma 3 by 2 into sin phi plus c cos phi. That same equation I told you, na? If you write like this, it can be rearranged at like this. Now sigma 1 minus sigma 3 by 2, that is q. This is q and this is p. This is q and this is p. So this is p, x-axis, and this is y. Now you take one sample for sigma 1. You find sigma 3 for this and sigma 1 for this. So you got a point. X-axis will be sigma 1 1 plus sigma 3 1 by 2, and y-axis will be sigma 1 1 minus sigma 3 1 by 2. For the same soil, take this second. Find new sigma 3 and find new sigma 1 for failure. New sigma 3 and new sigma 1 for failure. So we get one more point. Sigma 3 1 plus sigma 3 2 by 2 and sigma 1 1 minus sigma 3 2 by 2. Draw a line here like this. Draw a line here like this. Okay. Draw a line here like this. Okay. Everyone please tell me. Everyone here please tell me. Draw a line like this. Okay. So now what is this intercept? This intercept is alpha, na? So what is intercept here? Y is equal to m x-axis plus c. So this is the intercept alpha. Okay. And suppose when you draw the graph, you will get a slope beta. So slope tan beta is equal to, this is slope m, y is equal to mx plus c. So sin phi. So phi is equal to sin inverse tan beta. So from here we can find phi. And alpha is equal to c cos phi. Alpha is equal to c cos phi. C is equal to alpha by cos phi. Okay, alpha from here, cos phi from here. Everywhere. Give me yes or no. Give me yes or no, please. Please, 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 please. Please, please, please. Okay. Shear. Triaxial test. Triaxial test. अच्छा ठीक है. अब देखो इसके आगे टेस्ट बचा है. टेस्ट बचा है ना. तो टेस्ट के लिए मैं आपको वीडियो दे रहा हूं. टेस्ट के लिए मैं आपको वीडियो दे रहा हूं. कमेंट बॉक्स पे ही रहेगा वो, या डिस्क्रिप्शन बॉक्स पे लगा दूं ताकि हमेशा के लिए काम आए. डिस्क्रिप्शन बॉक्स पे लगा देता हूं, हमेशा के लिए काम आ जाएगा. ठीक है. इसमें ना, क्योंकि मैं उसमें बहुत डिटेल में पढ़ाया है. उसमें बहुत डिटेल में पढ़ाया है. उसमें ना बहुत डिटेल में पढ़ाया है. ठीक है. और ऐसे ही मैं अर्थ प्रेशर की भी दे दे रहा हूँ. फिर हम करेंगे ब्रेक के बाद फाउंडेशन इंजीनियरिंग. ओके, वो आराम से जब मर्जी हो पढ़ लेना. जब मर्जी हो पढ़ लेना. टेलीग्राम नहीं, डिस्क्रिप्शन में लगा देता हूँ ना. टेलीग्राम में लगाऊँ? चलो टेलीग्राम में भी बोल देता हूँ. टेलीग्राम में भी बोल देता हूँ. टेलीग्राम में भी बोल देता हूँ. उसके बाद पढ़ेंगे ब्रेक के बाद फाउंडेशन. मजा आ जाएगा. ब्रेक के बाद पढ़ेंगे फाउंडेशन. ब्रेक के बाद पढ़ेंगे फाउंडेशन. मजा आ जाएगा. मजा 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 मजा. ओके, तो वो ट्राइक्सियल वहां पे ज्यादा डिटेल में मैंने पढ़ाया है ना, तो आपको टेलीग्राम पे भी दे दूंगा. एंड ये अर्थ प्रेशर वहां से आप देख सकते हैं. हम पढ़ेंगे ब्रेक के बाद शैलो और डीप. और शैलो डीप में मचाओगे क्या? शैलो और डीप में मचाओगे क्या? ओके, यहां पे लिख देता हूं shear strength experiment plus earth pressure video in Telegram and description box. Okay, and after break we are going for shallow foundation plus deep foundation. After break we are going for, अभी बताता हूँ ब्रेक कब तक है. रुक जाओ यार. कहाँ गया सिविल बाय अभिनव सर? सिविल बाय अभिनव सर. सिविल बाय अभिनव सर. देखो टेलीग्राम पे मिल गया. मिल गया टेलीग्राम पे. ओके, लाइक कर दो भाई वीडियो को. मैक्स जोन्स कौन है? हु इज मैक्स जोन्स? सुबह से कौन देख रहा है लगातार? बताओ भाई, कौन है इतना खाली? अनवर, सोफिया, ओके ग्रेट. प्रिंस, सरवन, हनीशा, संगता, रणदीप, मयंक. ओके. हेलो शशिकांत. क्या कहते हैं, मैं लाइव हूँ अभी मैराथन में. कैसा है आपका कंधा? कैसा है? प्लास्टर चढ़ गया कंधे में? अच्छा, बताया नहीं आपने. कितने दिन तक का प्लास्टर है? अच्छा, तो अभी लिंक विंक मतलब कर लोगे कि कैसे? अच्छा, मैं ये कह रहा हूँ कि ना शियर स्ट्रेंथ एक्सपेरिमेंट और अर्थ प्रेशर के 2 चैप्टर है ना. ये चैप्टर का वीडियो मैंने आपको उसमें दिया है व्हाट्सएप में. इनको डिस्क्रिप्शन बॉक्स में लगा दो, है ना. उसमें लिख देना शियर, जो टाइटल है वही लिख देना, है ना, जो उन वीडियो का टाइटल. फिर ब्रेक के बाद ये 2 टॉपिक मैं नहीं पढ़ाऊंगा, डायरेक्ट लास्ट उस फाउंडेशन पे आ जाऊंगा. ओके ओके. कितनी देर का ब्रेक करें? मेरे को लग रहा है ब्रेक ज़्यादा हो रहे हैं, पढ़ाई कम हो रही है. 7:20. ओके ठीक है, 15 मिनट्स ही समझे उसको. चलो भाई रेडी हो जाओ सब, 7:20 पे स्टार्ट करेंगे 3-4 मिनट बाद। Hello. Ready? Ready, guys? For the foundation engineering? Everyone? Ready? Okay. Hello. Toggle fast. Okay. Okay. चलो एक बार लाइक और शेयर फिर से कर दो यार, एक बार फटाफट से लाइक और शेयर कर दो. Everyone please like and share, guys. Come on. Okay. All are ready. Okay. Ready? चलें? Okay. Please like and share the session to all so that all can join. I don't want कि किसी का मिस हो जाए. I don't want कि किसी का मिस हो जाए. फिर फाउंडेशन एक गाड़ी चलेगी तो this now no break, now class will end. Okay. I have shifted my class by 15 minutes. Instead of 9 p.m. I'll be going there at 9:15. Okay. Guys, you know that how much marks you have to score for IIT MTech? Okay, for MTech in IITs na, approximately in general category your rank should be less than 1200. For OBC it is less than 1500 and SC/ST it is around 3500. Okay, rank. But of course in 1200 rank for general and 1500 for OBC and 3500 or 3200 in SC/ST, you will not be getting IIT Delhi structures or IC Bangalore structures. Okay. Okay, for that you should be getting the top ranks like 200, 300 in that. But yes, in IIT MTech, even old IITs I'm talking of, 1200 for general, 1500 for OBC and 3500 for SC/ST, it will help. Okay, so you should be scoring general candidates more than 62 marks, here more than 58 marks, and they should be scoring more than 50 marks, guys. Okay, for PSU, guys, your rank for general candidate rank should be 250. For OBC it should be around 320, and for SC/ST it should be around 900 for PSU. Okay, guys, so that means that IIT MTech can, even with around 60 marks or 50 marks, will even be, you can get it, even IIT you can get it with 70% or 80% of the syllabus. And also guys, these two videos, shear strength of soil and earth pressure, I have put on the description box. Okay, it is already updated. Okay, now guys, first of all we'll be doing shallow foundation and then we'll be moving to the deep foundation. Okay, first of all guys, why foundation is made? Okay, why the foundation is made? Suppose there is some load of the superstructure, the P load. Now that P load cannot be directly transferred to the soil. That P load cannot be directly transferred to the soil because the bearing capacity of soil is not as high as concrete. Concrete is carrying some loads of the superstructure, the column, the beams, the slabs. When that is transferred below, So ultimately all the load has to be put to the soil. But soil is not as high bearing capacity as concrete. So larger area is required. Because stress will be forced by area. So the permissible stress of soil is not as the steel members in the building or beam in the building. So area has to be increased so that stress is decreased, and this stress should be less than the permissible value. This stress should be less than the permissible value. Okay. Now, if this is DF, that is depth of foundation. This is B. Usually people call it that if DF by B is less than 1, it is shallow foundation. Else it is a deep foundation. But guys, it is not correct. Even DF by B less than 2 can be a shallow foundation. DF by B less than 3 can be a shallow foundation. But yes, as per Terzaghi, if we want to apply the formula of shallow foundation for Terzaghi, then DF by B has to be less than 1. Okay, then DF by B has to be less than 1 for application of shallow foundation formula. For application of shallow foundation for formula for Terzaghi. Otherwise, even someone can develop its own formula and can say that DF by B less than 3. Then it's fine. So as per Terzaghi, DF by B less than equal to 1 is shallow foundation, and we can apply his formula. Now there are various footings. Strip footing is then when one dimension of footing is more than 5 times the lesser dimension. Okay, when one dimension of footing, that is length, when one dimension of footing, that is length, is more than 5 times the width dimension. When it is more than 5 times the width dimension. Okay, so L is greater than 5B, then it is called as a strip footing. Okay, L is greater than 5B, it is a strip footing. Isolated means one column, one footing. One column, one footing. One column, one footing. That is the isolated footing. Now, the combined is when two or more columns has a common base, has a common footing. Two or more column has a common, that it is a combined footing. Now, raft is when for the whole area concrete layer is put and all the columns are put in that is a raft. Strap will do later on. When all the area, all the plan concrete is poured and all the columns are put on it, that is a raft footing. Now when raft is used, suppose this is the plan of the foundation where all column has to be put, and there are various columns, there are various columns. Okay, there are various columns, and if we apply the footing for each column, if we apply the footing for each column, if we apply the footing for each column, if you apply the footing for each column, if you apply the footing for each column, if you apply the isolated footing for each column, then it is more than 50% of the total area. If it is more than 50% of the total area, then instead of this, making footing for individual column, in one go we can make all the layer. In one go we can make all the layer. Okay, in one go we can make all the layer of concrete. That is called as raft foundation. Okay, then there are certain terms. One is gross pressure or gross load intensity, that is represented by QG. Okay, Q gross. Okay, now what is Q gross? It is the total stress due to the load. So due to P, if it is dimension is B into B, this is the stress B into B. Okay, P by B into B or B square. This is due to the superstructure load P plus due to the self weight, it is gamma dF. Due to the self weight, it is gamma dF. Now one is, this is QG. Okay, one is Q net. Q net is how much extra is coming, the difference of after construction and before construction. It is the difference of after construction, before construction. Like what was the load? This is gamma. What was the load before construction? Gamma dF. Now this is the load now. So earlier it was gamma dF, now it is like this. So what is the difference? Now it is this. Earlier it is this. So it is P by B square. Okay. Now suppose earlier it is gamma df, earlier it is gamma df, earlier it is gamma df. Okay, and now it is P by B square. Now soil is not placed back. So now it is P by B square only. Gamma df is not there. We are not putting the soil back. We are not putting the soil back. It is only P by B square. Okay, so now it is P by B square. Gamma df is not there, and earlier it is only gamma df. So what is the difference? P by B square minus gamma df. This is when soil not placed back. Soil not placed back. Guys, these terms that you are learning, like you are cramming for your BTech, next 5 minutes that the concepts will be clear forever. In next 5 minutes, these concepts will be clear forever. Now, ultimate bearing capacity is QU. Okay, if soil is loaded, then the maximum shear stress at which soil will be failing. Okay, ultimate bearing capacity is the maximum load. Okay, it is the maximum load at which the soil will fail. Okay, it is the maximum gross intensity. It is then the maximum gross intensity. It is the maximum gross intensity. Maximum QG at which soil is failing. It is the maximum QG at which the soil is failing. What is the net ultimate bearing capacity? Q and U. So Q and U is the maximum net intensity. It is the maximum net intensity at which the base of soil foundation will fail. Okay. Now nets, guys, let me tell you, I will link everything. I will link everything. What is the net safe bearing capacity? Net safe bearing capacity is QNS QNU by factor of safety. What is gross bearing is? Gross bearing is QS is equal to QNU by factor of safety plus gamma df. Now see the link that you have never ever seen earlier. Now see the link that you have never ever seen earlier, guys. See. This white color. This white color is the total load coming. Remember thing, this white, you have never interconnected them. You just learn it like it. This white load is the total load coming including the sulfate of soil. This white one, ultimate bearing capacity, QU is the total load that can come for failure. QU is the total load that it can come so that failure is not. The maximum load that can come, the maximum gross load that can come so that no failure. And this white one is the maximum gross load with factor of safety that can come. Of course, in gamma df, we are not applying the factor of safety. So guys, of course, this is the minimum because it is factor of safety. Then more than that is this one. Okay. And of course, this should be the least so that there is no failure. Even this Q gross should be less than this. Okay, Q gross should be less than this. This is the coming. How much is coming? This is how much total is coming. Total is coming. This is how much total can come. This is how much total can come with factor of safety. So coming should be less, na? This should be least. I'm again saying this is how much total coming. Coming. How much total coming? This is how much total can come. This is how much total can come. QU. This is how much total coming. Total means load of superstructure plus soil. How much total is coming? This is how much total can come. This is how much total can come. And this is how much total can come. This is how much total can come. This is how much total can come with this is how much total can come with factor of safety. This is how much total is coming. This is how much total can come. This is how much total can come with factor of safety. Give me yes or no. Similarly, this is how much net. Net means the difference of earlier, before construction and after construction. The difference of before construction and after construction. This is how much net is coming. This is how much net can come with the, so that failure is not there. This is how much net is coming. This is how much net can come. And this is how much net can come without failure. With factor of safety. I'm again saying this is how much net is coming. This is how much net can come. This is how much net can come with factor of safety. Understood? Understood? Understood the link? Okay, this is the total load coming. This is how much total load can come. This is how much total load can come with factor of safety. This is how much net is coming. This is how much net can come. This is how much net can come with factor of safety. Understood, guys? Okay. and safe bearing is, that is QPS. So that settlement, this is on the base of settlement. Maximum not without settlement does not exist. And actually, we don't want settlement to exist. We don't want failure. So Q allowable is minimum of settlement wala case also and the load wala case also. This is settlement wala and this is net wala case, load wala case. Have you understood? Now general shear failure of soil is like this, and suddenly it fails. Whenever guys relative density is more, relative density more than, let me check, 70% it is. Relative density 70%. Yes, relative density is more than 70%. I hope you remember relative density. Relative density is E max minus E upon E max minus E minimum. Relative density is more when E is less. So when relative density is more, that means voids are less. Okay, that means it is stiff. It means stiff means it is sudden failure. Sudden failure here. This is general shear failure. In general shear failure, the whole this footing is tilted. Whole footing is tilted, and the heaving, the soil failure comes to the ground level. Okay, the soil failure comes to the ground level. We can see that it is failed. Local shear failure is, this is general shear failure. Local shear failure is when relative density is, you can say 35 to 70%. Relative density 35 to 70%. And guys, phi value is generally less than 29 degree. Okay, here guys, when phi value is 36 degree, it is local shear failure. Here the phi value is 28 or 29 degree. Okay, and relative density is 35 to 70. Okay, so here, this is general shear failure. It is not, relative density is less here. So voids are more. So voids are more means it is not stiff. So here the failure is not sudden. It is like this. With a predetermined value, we can find out the failure. Here also guys, tilting of foundation is not there. Foundation is not tilted. Yes, failure is here. Here, little bit soil comes above, that is little bit heaving, but failure is not coming to the ground. From ground, we cannot see that it is failed inside. From ground, we cannot see that it is failed inside. Okay? Okay guys, punching shear failure, this is general shear failure. Okay, this is local shear failure. Punching shear failure is maximum settlement. Okay, here in punching shear failure, it is the maximum settlement. Here what happens, that the footing goes below. Okay, the footing goes below, maximum settlement. Okay, it is the maximum settlement. No heaving, no tilting. Here there is no heaving and no tilting. Now guys, there is Terzaghi formula. Everyone please see. Understand my words for next 10 minutes. And shallow bearing, shallow foundation is almost 30%, more than 50% complete. Understand my words for next 10 minutes or so. And if you understood, the shallow foundation is almost 70%, 50% complete. What are those words? Everyone, please see. Suppose this is a footing. Okay. In this footing, the load is coming here, P. This is suppose ground level. I am seeing this as zone A from here to here. And from below the footing, I am seeing as zone B. Okay, sir. Now, my friends, let this be DF. Okay. And let this be B. Okay. Got it? Understand my words for next 15 minutes. Everything will be cleared. This is DF and that is B. Okay. Let this be gamma A. And let this be density of this zone is gamma B. Okay. Density of that is A. Density of this is B. Okay, sir. Okay. What is Shravan in that Hanuman movie? Now, the ultimate bearing capacity. Guys, first of all, Q and U is QU minus gamma DF, na? Because net in total the soil weight is not taken. In total the soil weight is not taken. In net guys, sorry, in net soil weight is not taken, only the difference. Understood? This, you have understood this? Let me tell you here. So this is ultimate bearing capacity and net. Ultimate means total. Ultimate means total, and net ultimate means other than soil weight. Okay, this is ultimate. Net ultimate means QU, total minus gamma DF. Gamma DF is not taken in net ultimate. Okay. Now, guys, this gamma DF is also called as small q. What is the load on this footing? What is the stress on this? Small q. And small q is gamma DF. Guys, this is negligible here. This is negligible. So from here to here also DF, from here to here also DF. This is also DF, this is also DF. So that is gamma DF. Okay. So from here we can say Q and U is total load, QU. QU is ultimate, total. Total how much it can carry. Minus small gamma DF, that is called as small q. Okay. Now the Terzaghi says that total bearing capacity QU. Terzaghi says that the total bearing capacity QU is summation of 1, summation of 2, and summation of these three terms. What is first term? First of all, what is NC, NQ, and gamma? NC, NQ, and gamma are function of phi. NC, NQ, and gamma are function of phi. And if by any means phi here is different, phi here is different. Okay, so phi of zone B. If any means phi of here is different, phi of here is different. So we have to find out NC, NQ, and gamma corresponding to this phi, phi of zone B. Okay. Okay, sir. Got it, sir. NC, NQ, and gamma are of function of phi, and any means if phi here is different and phi here is different, then we have to take phi of zone B. Okay. Then we have to take phi of zone B. Got it? Okay, sir. I got it, sir. Okay, sir. I got it, sir. Now, friends, commandos and champions, everyone, if first term is CNC, okay, so CNC is the cohesion below the footing. CNC is cohesion, accounts for cohesion below the footing. Of course, guys, if CNC is more, if cohesion is more, leave NC, NC is a constant, depending on phi. If C is more, then guys, bearing capacity of soil will be more. Na? Ultimate means how much total load it can resist. Net ultimate means how much extra load it can resist other than the weight of soil. How much extra is coming. Okay, QU means how much total load it can resist. QNU means how much extra load it can resist. So guys, if this is first term and first term is justified, I've justified the first term. If cohesion at the base of footing is more, that means if the cohesion at the base of footing is more, that means guys, it can, the soil is strength, soil has strength, soil has cohesion, particles are bonded. Okay, so CNC is accounting that thing, cohesion. If cohesion is more, so bearing capacity will be more. Second is Q into NQ, leave NQ, Q. Q is the gamma DF. If it is more gamma DF, so it is allowing, it is more gamma DF na. If it is more gamma DF na, it is not allowing the footing to tilt. It is not allowing the footing to tilt. It is not allowing the footing to tilt. Okay? It is not allowing the footing to tilt. It is not allowing to footing to tilt. Okay? So footing cannot be tilted here. The footing cannot be tilted. If more load is there, it is compressing it na. B as it is. So second term is accounting that. Okay? Second term accounts for the surcharge loading. And what is this written? I am telling you. Second term is accounting for the surcharge loading. So if Q is gamma df, na, where it is this? Q. So which is gamma A or gamma B? It will be gamma A, na? So load is applied by the top footing, na? Load is applied by the top footing, na? Load is applied by the top soil, na? So that is gamma A. That is gamma A. That is gamma A. Yes or no? Yes or no? Please tell me. Please tell me. Got it? Got it? Got it? Everyone? Everyone? Okay. Now, leave half and N gamma here. B gamma. B gamma is the extra stress here. At B depth, what is the extra stress apart from this? Gamma into B. Only due to this soil. Apart from the top gamma df, what is the extra stress? Gamma B. So in this, gamma of which zone? Gamma of B zone. This gamma is of B zone. And here it is gamma df. That gamma is of A zone. Now what is this? Why this term is there? Because crack starts propagating from here. The crack starts propagating from here. So if gamma B is more stress here, so it is holding the soil. It is holding the soil. It is holding the soil. So crack doesn't start propagating from here. Crack doesn't start propagating from here. Okay? Crack doesn't start propagating from here, guys. Okay? Crack doesn't start propagating from here. Okay? So this is, have you understood how these three terms are helping in QU? Okay, this is cohesion. More is the cohesion, more is the ultimate bearing capacity. If more is a Q, it is holding the soil. So footing cannot tilt. It is holding the soil, footing cannot tilt. And third is the gamma B here. It is holding the soil here, it doesn't propagate. And guys, Q and U is equal to QU minus small q. So minus small q here. So it is C and C plus Q and Q minus Q. So it is Q and Q minus 1 plus half B gamma into N gamma. Half B gamma into N gamma. Have you understood? Have you understood? So every time in ultimate bearing capacity, this is like this. In a net ultimate bearing capacity, first and third will be same. Second will be this. Everybody, please put a heart sign on the comment box if you got it. Everybody, please put a heart sign on the comment box if you got it, guys. Come on, everyone. Okay. Now, guys, see the assumptions of Terzaghi. Footing is strip footing. And general shear failure is occurred. These two are the most important assumptions. These two are the most important assumptions. That footing is strip footing and it is general shear failure. Footing is strip footing and it is general shear failure. Okay. So, guys, that means if footing is strip footing and it is general shear failure, then these formulas are there. But, guys, for phi less than 28 or 29 degree, it is the local shear failure. Phi less than 28 or in some books it is 29, it is local shear failure. So this formula is not valid there. This formula is not valid there. So we have to do certain modifications. So there we have to use, instead of C, we have to do some modifications. So instead of C, we will be using CM. Okay. What is CM? 2 by 3 of C. Instead of phi, we will be using phi m. Okay. Tan phi m is equal to 2 by 3 tan phi. From here, find the value of phi m. Now, NC, NQ, N gamma dash. The values of NC, NQ, N gamma should be corresponding to phi m, not corresponding to phi. Now, final answer will be, for local shear failure, the final answer will be QU is equal to CM into NC. What is CM? 2 by 3C into Q and Q. But it should be Q and Q dash. Here also NC dash plus half B gamma N gamma dash. So we should not be using NC, NQ, N gamma. We should be using NC dash, NQ dash, and N gamma dash. We should be using NC dash, NQ dash, and N gamma dash. Everybody! Got it? So this is because these formulas are for general shear failure. Right? If it is local shear failure, we have to modify like this. Okay. Now, guys, कोई question है क्या? Okay. So you have to use NC dash, NQ dash, and gamma dash. Now, guys, NC, NQ, and gamma are function of phi. NC, NQ, and gamma are function of phi. So phi is equal to 0 for clay. For clay, phi is equal to 0. Then as NC, NQ, and gamma are function of phi, then guys, the value of NC should be something for phi 0. The value of NQ should be something for phi 0. The value of N gamma should be something when phi is 0. So here NC is equal to 5.7, NQ is equal to 1, and N gamma is equal to 0. So for phi 0, that is clay, the Q and U is equal to 5.7 NC. Okay, sorry, 5.7 into C. I hope you understood. Simple formula for clay. Because Q and U, NQ is equal to 1 for phi 0. So the 1 minus 1 is 0. N gamma is 0. So this third term is 0. The second term is 0. C into NC. NC is 5.7. Everybody got it? 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 Now this is for this case because assumption is general shear failure. For local shear failure, we have done this. Now, guys, these all formulas are for strip footing. Suppose footing is not strip footing, it is square footing, rectangular footing. Then we have to in the same values, na. Either you do the formula of QU or QNU. It is 1 point. Sorry. What is QNU? For strip footing, CNC plus Q NQ minus 1 plus what is the formula for strip footing? QNU is equal to CNC plus QNQ plus half B gamma N gamma. What is the formula for strip footing? QNU is equal to CNC plus QNQ plus half B gamma N gamma. What is the formula for strip footing? QNU is equal to CNC plus QNQ plus half B gamma N gamma. Now, if the footing is not strip footing, it is some other shape, then we have to add shape modification factor. For square, here in second term we are not adding anything. Second term is same. And here we will multiply 0.8 into 1 by 2. Okay. Shape modification factor is 0.8. For rectangular, it is 1 plus 0.3 B by L. So B and L are same for square, na? So it becomes 1.3. No change here. Here it is as it is. And here it is 1 minus 0.2 B by L. So B and L are same, so it is 0.8 for square. It is 0.8 for square. For circular, guys, this is 1.3 CNC. No change in second. And here it is 0.3. That means 0.6 into this. This is the shape modification factor. In circular, B is diameter. Okay. Of course, this is for local shear failure. Sorry, general shear failure. For local shear failure, C has to be changed by CM. And NC, NQ, N gamma has to be changed by NC dash, NQ dash, and gamma dash. Got it? This is circular, na? This is circular. This is rectangular, and this is square. Okay. Got it? Got it, guys? Okay. Now, guys, suppose there is water table. Again, guys, those who have understood my three things, the three terms. Okay, those who have understood my three terms, they have nothing to do here. They don't have to remember anything. Suppose dW is here. This is dF. This is B. So guys, we only write the stresses up to this zone, na? So here nothing effect. So QU or QNU, whatever you want to write, CNC, okay, plus gamma T into DF, that is Q, into NQ, plus half B gamma T of this zone, half B gamma N gamma. No change, because water table is here. So here we don't write anything, na? Here we don't write anything, na? Okay. Now, case 2, this is ground level, dW is here, this is dW, and water table is here, this is dF, and this is B. Let this be gamma T1, this may be different soil, gamma T2, and this will be gamma set. Now how to write QU? CNC plus QNQ. Q is the load here. So QNQ. What is Q? Gamma T1 into DF plus half is same, half and gamma. We have to write B gamma. What is B gamma? B gamma is the stress here. Let this be X distance. So B gamma is the stress. Out of that B distance, na, suppose this B distance, X is this density, gamma T2. And we have to use submerged weight, gamma submerged into remaining, that is B minus X. Okay, gamma submerged into B minus X for this distance. Everybody give me yes or no? Okay, we have to, guys, CNC plus Q and Q. Q is this, plus half B gamma N gamma. So half N gamma constant, and we have to write stress, B gamma. So that is extra stress is B distance. So extra stress is gamma T2 into X plus gamma submerged into B minus X. Everybody! Everybody! Yes or no? Yes or no? Okay. Third one. Okay. This. So this is ground level. Okay. Now, here. Water table is where? Here. dW. Water table is here. Okay. So if this is dW, what is this distance? This is dF minus dW. And we have to go further B distance more. Okay, let it be gamma T1. Okay. Now, Q and U or whatever I was writing, Q and U or QU. Let it be QU. CNC plus NQ minus 1, na? No, it is QU only, so no minus 1. Plus half B, it will be gamma submerged here. It will be gamma submerged here. And this NQ, Q is the stress here. So stress here is gamma T1 into dW plus gamma submerged into, this distance. Total is dF, so this is dF minus dW. This is dF minus dW. Got it? Water table correction factor I am not doing here, that you can do. Lakshmi, sir, in third term, B gamma and gamma means? Yes, this is N gamma is a constant. This is one total term. N gamma is a one value, not N into gamma. Guys, give me yes or no. Should I repeat it again? Guys, see, first term is CNC. First term is CNC. Third term is half B. This whole is gamma submerged into N gamma. Now here, is Q into NQ. So what is Q? Q is the load here, na? So do gamma T1 for this, gamma T1 into dW, gamma T1 into dW plus this one. So what is this one? What is this one? What is this one? That is gamma submerged into this distance, that is dF minus dW. Gamma submerged into dF minus dW. Give me yes or no. Give me yes or no. Give me yes or no, everyone. Everyone. Everyone, please. Everyone, please. Enjoying or not enjoying, guys? Can you please tell me? Are you coming on survey Sunday 6 p.m.? Are you going for survey marathon? Are you coming for survey marathon Sunday 6 p.m.? Okay. Okay. Now this is done. Acha, Scampton. Now, guys, see. Everyone. If a question is coming na, then 80% chances question is coming from Tarzagi. 15% chances the question is coming from Scampton. 5% chances the question is coming from Mayerhoff. Everyone has given its own value for finding out the bearing capacity. Q and that and NQ minus 1 na, everything will be same. Surcharge load will be same, yaar. Only have to do NQ minus 1. Load will be same. Okay. Now guys, Scampton has given very easy formula. Scampton says my formula is QNU is CNC. That's it. That's it. And first of all, it also says that my formula is only for clay. I am not interested in finding the Q and U value for sand. It is saying my formula is only for sand. Don't apply, only for clay. Don't apply for sand. For sand, you can go to Terzaghi. And NC is a function of depth. NC is a function of, dF by B and shape. It is a function of dF by B and shape. Okay, it is a function of dF by B shape. Now for different footing, NC value is given. For different, NC is given. For different, NC is given. Understood? That you can do, yeah. So why I should watch Hanuman? I am not getting the reason. I have not ever watched Bahubali. I will watch a match. From yesterday, the match have been started. South Africa T20. I even watched domestic match. Leave Big Bash. I even watch South Africa domestic matches. Yesterday, I know one team has made 207 runs. You can check. Empty. 207. Okay, and other team has made in 18 overs something around 16 overs, 16, 17 overs. They have made 170 and 180, and they won by Duckworth Lewis by 18 runs. Okay, Khalasin has made, I guess, 70 to 80 runs in 35 balls. Henry Khalasin. Deacock was out just by putting 1-4. Okay. Puran has also made some runs. Okay. So I watched that match also. Okay. So for different NC values given. Okay. This Scampton. Okay. Now Mayerhoff gets given the different formula. It is saying that my ultimate bearing capacity will be CNC. NC is a constant, C is a quotient. Gamma DF NQ, like Terzaghi, that is, this is Q na, Q and Q, plus half B gamma and gamma, same like Terzaghi. This is Terzaghi, this is Terzaghi, this is Q into NQ, this is Terzaghi. But he has given 3 other terms. Okay, yes, that also. India versus Afghanistan. 3 other terms also I have seen. He has put. Where SC is the shape inclination factor, D is the depth inclination factor, I is the S is the shape modification factor, D is the depth modification factor, I is the inclination factor. Okay. Now this is Peck-Hansen, but not much important. Other formulas. Now guys, we find SPT number. How to find SPT number? We put a hole. Okay, we excavate the soil. We excavate the soil up to which level? We excavate the soil up to the level of footing. If footing has DF level, up to that we excavate. Then from 65 kg weight and from a height of 75 centimeter, we put the load 65 kg from a height of 75 centimeter. Sorry, this is 75. This is 75 centimeter. We put a load. So how many blows are required for first 150 are not taken? How many blows are required on this split? This is split spoon sampler. In this 65 kg, 65 kg, 65 kg. For first 150 mm, there are some blows that are not counted. But for next 150 mm, this is not taken, but next 150 mm, that is 300 reading is taken, and that is taken as SPT value. That is taken as SPT value. Okay, like this. How many number of blows? For first 150 mm, it is not taken. For first 150 mm, how much it is required, that is not taken. For next 300 mm, it is taken. Okay. Now, after this value taken, suppose from here, the value comes, suppose N0. So, N0 value. So, this N0 is now refined. Okay. So, first is overburden correction. Overburden correction is applied and N1 is equal to N0. N0 is what we obtain from field. Okay. Into 350 upon sigma bar plus 70. Okay, and that is because these values are not reliable. Maybe once we excavate, so here the soil is disturbed. Here the soil is disturbed, so we not get the correct value. Okay, sigma bar plus 70. So sigma bar if should not be greater than 280. If sigma bar is greater than 280, if it is effective stress at the level of test, then this correction is not required. Okay, so we apply the correction and not is the value we obtain from field. How many number of hits are required for 300 mm. Then N0 we refined N1. This is the first correction. Then second correction is dilatancy correction. From N0 we got N1. Then N2, that is the final SPT value, is 15 plus half into N1 minus 15. Okay. So guys, this is applied. It is only applied. This correction only applied when N1 is greater than 15. If N1 is not greater than 15, we don't apply. Okay. So, I'm again saying, first we got from here N0 value. N0 value is refined as N1 value. N1 is refined as, N1 is putting here and we get the N2 value, that is the final value. Now, here our syllabus is over. Okay. Here the syllabus is over. Our syllabus is over. Gate point of view, AC point of view, state point of view. Our syllabus is over here. Okay, our syllabus is over here. We don't have to do anything here. We don't have to do anything here. Okay, our syllabus is over. Okay, our syllabus is over here. Okay, but as when I was student, I was curious, guys. We find the N value, but what to do with this? What to do with this N value? This N value is applied in some Tanks formula. Okay, there are some Tanks formula that like Terzaghi, Meyerhoff, Skempton, they have given own formula for Q and U. In that formula, this N value is required. In that formula, that N is required. But of course, this is not to be learned. Okay, this is not to be learned. But you should be knowing that why you are finding the N value, because in that formula, we can apply. Now, this is the plate load test. Okay, so we put a plate at the level of foundation DF. Okay, the plate is with BP. So the value excavation is 5 times of BP. Okay, now guys, here we put load on the plate and find the settlement, and we put the load here, we put the sandbags here. Okay, we find the settlement of this plate and we find that how much load it can take. Okay, so settlement, this is formula for, this is SF by SP, this is for sand. Okay, so we find the settlement of plate by dial gauge. So settlement of foundation will be given by this formula. Settlement of foundation will be given by this formula. SP we can calculate by the test. There is a dial gauge. So by putting the load, dial gauge will get reading. So we can get SF from this formula. BF is the width of foundation, BP is the width of plate. For clay, SF by SP is equal to BF by BP, width of foundation by width of plate. This is for clay. Okay. Similarly, guys, if we want the ultimate capacity, so for foundation, QF, Q ultimate of foundation and ultimate capacity of plate is equal to 1. Okay, QUF by QUP is equal to 1 for clay, is equal to 1 for clay. And QUF by QUP, QUF by QUP is equal to QUF by QUP is equal to BF by BP, is equal to BF by BP. This is for sand. Ultimate capacity of foundation upon ultimate capacity of plate we can find out from test, that is for sand. If the this test and these formulas are accurate when we do testing at the level of foundation. If we are not doing level of foundation, we are doing at some other depth. Okay, we are doing at some other depth, then settlement should be corrected by this factor. Okay, this correction is not required if we are doing the test at the foundation level. But if we are doing at some other level, this test should be corrected. And D2 is the difference of depth of foundation and where we have done the test. Okay, do this. Do this. Do this. Okay, कहाँ गया? First 150 is not taken ना? Next is taken 18. हैं? First 150. Got it? Got it, guys? Everyone. Please tell me. Please tell me. Okay. Okay, guys. Long class. And what you will do at 9:15 p.m. And can you please again, yeah, again, one small request. We are correcting it, na? We are refining it. N1 and N2 are correction. Dilating correction is due to some fine present, and overburden correction is due to that because actually at shallow depth we underestimate the value. That N value, whatever we take, if we don't correct it, then at shallow depth our formula, whatever the Tank's formula is now, we get lesser value than the actual value, and at more depth we are getting the higher value. Okay, so that is why the corrections are required. Okay, so guys, what? Of course, we are not finished yet, but yes, just I'm asking to you all, what you will be doing after class, because I have another class ना. प्रैक्टिस सेशन आज ही होगा मयंक, ये मतलब फिर प्रैक्टिस सेशन के बाद एम्बुलेंस भी ले आना भाई एक. You want practice session, then we can do. If you want practice session, guys, we can do. And it is not 10 hours, yeah. I guess how many hours? 10 hours. 10 hours, 19 minutes. What you will do after the class? N is greater than 15, it is applied. You want practice, then we can take at 11 p.m. 11 p.m. my that vision class is over. Soil is going on. Vision 2025 English batch. It is 9 p.m. to 11 p.m. but today it is at 9:15 to 11. Everyone, guys, please write down your cities. Everyone, 11 to 12. And write down your cities. And one more thing. Write down that you are watching in mobile or laptop or tab. I want to see. I want to see. Computer good. Sophia in Delhi, which place? I am also in Delhi. Coimbatore mobile. Okay, Talwara mobile. Hyderabad mobile. Hyderabad. Okay, Aman, how are you? I'm good, yeah. How are you, Aman? Our old student. How are you, Aman? Computer, Silva, laptop. Hi, Sanbuk, how are you? Sanbuk, I heard that you have cleared some examination. Someone is telling. Congratulations. Mangalore TV. Okay, yeah, TV is also nice. मैं टीवी में भी आता हूँ क्या? I come in TV also. Have you ever seen my ads that you have to skip ad na? Digital marketing, that skip ad. Have you ever seen? Okay, Ashti will do this. In Chetapunji or Cherapunji? Cherapunji. Sanbuk, you are that person who have cleared engineering services? Because one student, our student cleared engineering services also. Fine, sir. He is also from Meghalaya. Nellore from laptop. I am from Varanasi. Okay, Aman. Okay, Sanbuk, you are engineering services student. Though that who has cleared engineering services, I have taken that this mock interview. Achha, I cleared PSC. Okay, okay, Sanbuk, congratulations. Which PSC? $144 पे क्यों अनवर? वसंत विहार कहाँ? सीबीआई कॉलोनी. वसंत विहार तो हमारा अड्डा ही था भाई. ओके, वसंत विहार तो हमारा अड्डा ही था यार. स्कूल आर के पुरम से पढ़े हैं, केंद्रीय विद्यालय से. सोफिया सीबीआई कॉलोनी. योर फादर इज इन सीबीआई. वहां तो हम क्रिकेट विकेट खेलते थे यार. सब जानते हैं वहां मेरे को. So from which school and college you are, Sophia? आगे एक SBI CBI के आगे एक हरीश पान की दुकान है, कालू की दुकान, राइट से सेकंड नंबर वाली, जानते हो? I have been every week there. उसको जानते हो आप? कैसे? How? From which college you are? From which school you are? You are a boy or a girl? Because many students change the name. You are a boy, na? Okay, in college. And guys, all of you please reply how you manage the data. Good, Sandbook. Good, Sandbook. One of my student, I will not tell the name. He is from mechanical actually. I taught him Som in Dehradun. Okay, let me tell the name also. Suvansh Duggal. Oh, you can see him in my Facebook. Okay. है ना? He first year he got 108 rank in mechanical. He I guess joined basic steel. Then he cleared 30 rank, है ना? And he cleared BIS, Bureau of Indian Standards. Now he is in scientist in BIS. Suvansh Duggal, you can check in my Facebook. One time he got 102 rank, then he got 32 rank next year in mechanical. I taught him some in offline in Dehradun. So he also has one ID, Lovely Priya name. So I asked him why the name is Lovely Priya. Somebody messaged me Lovely Priya and say I am Suvansh Duggal sir. I say why you change your name Lovely Priya? He says that because there are many groups in Facebook. That time it was not much Telegram. That zamana. Sophia, please tell your college name, na. And right now you are in which year? So I asked him why you change your name Lovely Priya. So that time it was not Telegram was not there I guess or not much famous. So there was some Facebook pages of GATE and ESE preparation. So he says that sir when I asked doubts to all the students and I asked something with my name Suvansh Duggal nobody reply. From which college Sophia? Nobody reply. Okay. But when I ask from this name Lovely Priya, then more than 10 people reply for every doubt of mine. More than 10 people reply for every doubt of mine. Okay. So that is why he says sir I changed my name. So I guess Sophia is the same case. Okay. Now guys, let us go for the pile foundation. Guys, shallow foundation, why we are going to pile foundation? So ultimately in shallow foundation, we are transferring the load here. We are transferring the load here. Okay. Delhi Engineering College means DC, that Bhavana. DT you are saying Bhavana. That Bhavana you are saying. ओके एक बार आप सोफिया मेरे को ना मेरे मैसेज करना abhinav.negi@byju's.com में abhinav.negi@byju's.com में ओके सी नाउ कहाँ गया मैं हाँ so in shallow foundation load is transferred here but suppose this soil is slurry okay it has not much bearing capacity so we cannot transfer the load here okay we cannot transfer the load here so then we have to go at a larger depth okay then it is pile foundation used or when the property boundary is like this and one column is this so I cannot go make the column like this na so in pile foundation lesser width is required in that case also we use pile foundation pile foundation Now these are the piles. Okay, like this. Piles are generally used in square fashion. 1, 2, 3, 4. Here also 1, 2, 3, 4. Now, guys, first of all, if capacity of one pile is QU, then capacity of 3 piles will be how much? 3QU or not? Then capacity of 3 piles will be 3QU or not? So guys, see, if one pile pressure is here in this much zone, pressure is pressure bulb. Pressure bulb is where the stress effect is there. So if one is Q, the capacity here will be 3QU. The capacity will be 3QU because stress of this is not intersecting with the stress of this. Stress of this is not intersecting with the stress of this. So it is 3QU. But here, the pressure bulb is intersecting. So here the capacity will be less than 3QU. Okay. Now, guys, this chapter is very simple, guys. Total load in the pile. How much total load we can apply? This is a pile. Pile may be of square cross section, maybe of circular cross section. QU is the total load from the structure. Okay. And load from the ground is QP. That is end bearing. And if this pile wants to go downward, if this pile wants to go downward, so it will be upward force QF. It will be upward force QF. Correct? There will be the upward force QF. Correct? If this wants to go downward by QU, so there is the upward force of QP and QF. Correct? Correct? Correct, guys? Give me yes or no. Wait. Okay, so the total load downward is QU, and from ground it will be getting a reaction QP. And since this pile wants to go downward, so it wants to go downward, so upward will be QF. Okay, friction will be acting on this. So total load downward, this is resisted. This is how much load it can carry. So it can carry this plus this, because our helping thing which is resisting the load is QF and QP. And in fact, the Q allowable is QU by factor of safety. If factor of safety is not given, we take it 2.5. If factor of safety is not given, we take it 2.5. Okay? Okay, guys? If factor of safety is not given, we take it 2.5. Q allowable is equal to QU by factor of safety. And the things which are helping us is QP. Things which are helping us is QP. And here it is QF. Here it is QF. Got it? So QU is the ultimate capacity of pile. QF is the frictional capacity. QP is the point bearing capacity. For some pile, QF is very, very greater than QP. It is a friction pile. For some piles, QP is very, very greater than QF. It is a point bearing pile. For some piles, QF is very, very greater than QP. It is a frictional pile. For some piles, QP is very, very greater than QF. It is a friction pile. Got it? Okay. Now, moving forward, QU is equal to QF plus QP. Now, what is QF and QP? Now, QF and QP, let me write it here for sand. This is single pile capacity. Okay. So QU is equal to QP plus QF. I am writing for single pile in sand. Single pile in sand. Okay. Suppose this is the pile. This is the QU acting here. This is QP here. And this is QF. So this load QP is some stress into area. This load QP is some stress into area. Yes? Yes? So stress is equal to QP for this. क्या कहते हैं इसको? For sand. Okay. For sand it is equal to Q into NQ plus half B gamma N gamma. This is the stress into area in which it is acting area base. For circular it is pi by 4 d square. For circular it is pi by 4 d square. For circular it is pi by 4 d square. Okay. So if generally guys 99.999% N gamma is not given, so we take it 0. Okay. N gamma is not given, we take it 0. NQ is a constant which will be given. NQ is a constant which will be given. And what is Q? Q is the effective stress at base. Q is the effective stress at base. Now guys, for loose sand, effective stress variation is up to 15D. After that we'll be taking constant. 15D for loose sand. And for dense sand, effective stress is varying up to 20D. Up to 20D effective stress is as it is. After that we have to take constant. Guys, actually effective stress is varying like this. So we are taking lesser value, na? We are taking lesser value of sigma bar. We are taking lesser. We make it constant. We are not increasing. It is constant. After 15D we are making constant. Actually it will increase. In dense sand after 20D we are making constant, not increasing. Okay, so we are taking lesser value of sigma bar, lesser value of Q. So our capacity we are taking less. So we are safe, na? Now why we are doing this? Due to arcing effect. Might be the pile can slender like this. Okay, so we are taking lesser capacity. So with that we will apply lesser load. Okay. Now QF is equal to K into sigma average into tan delta into A surface. Okay, this is the frictional. So this is the stress into area. This is the stress into the area. This is the stress into the area. So what is K? K depending on different materials. K depending on different material, loose or dense sand and different materials. It is like this. And sigma average is the average stress over the pile. And tan delta is like this for the value of delta into A surface. That is, suppose it is circular pile. So it is pi d into L. Now guys, suppose it is like this. So we have to apply 2 times. One here. What is sigma average here? 0 plus this value by 2. And for this region, the sigma average is this. And guys, might be the constant region is not coming. Might be the, suppose it is loose sand. And might be the length of pile is smaller. Less than 15D. Length of the pile is less than 15. So only linear variation will come. So if the pile is bigger, then after 15D it will be constant. Na? So this is QP and this is QF. Everybody give me yes or no. Okay. Now this is for single pile capacity of sand. Now single pile capacity of clay. Single capacity clay. Okay, load carrying capacity in clay. Okay. Now for clay. This is QU. This is QP. And this is QF. So the load which is from above QU is equal to upper load QP plus QF. So what is QP? Some stress into area. So point is acting at the base. Point is acting at the base. So area base into stress here is CNC. If NC is not given, we have to take 9. And if it is the toughest problem and C is changing, see here is different, here is different, here is different, here is different, here is different. So which C will take? We'll take C at the base because this formula is for the base. and QF is again some stress into area where friction is acting, friction is acting at the surface. So it is AS. For circular pile, it is pi d into L. For circular pile, it is pi d into L. This is pi d. This is pi d for L length. This is pi d for L length. Everybody, okay. And this is alpha Z. So this is stress into area. Alpha is adhesion factor and C is cohesion. Suppose for the weirdest problem, suppose for the most difficult problem, see here is changing. See here is changing. For this friction, so we have to take average stress. Let me give you example. Suppose stress C is 20, 30, 40, 50, 60, and C here is 70. So for this C, base wala C, we have to take 70. And this wala C, friction, we have to take average. Suppose it is linear relation, so 20 plus 60 by 2. Everybody. Now guys, give me yes or no in the comment section. And everybody, my dearest friend from school time, who is topper of our maths class also. In maths, me and Desraj is topper. Everybody please welcome. Now he is running one of the biggest businesses in Gurgaon. So welcome Desraj Shekhawat, my friend. Of course, we are the football players as well. एक बार स्वागत कर दो यार देशराज का. Everyone, one of the finest businessman in the Gurgaon. पर मेरे को लोन नहीं देता है भाई ये. मेरे को सुल्तान भाई को ज्यादा नहीं देता, थोड़ा ही देता है. ओके प्लीज वेलकम यार, कम ऑन यार, बचपन का दोस्त है यार. टेल हिम फ्रॉम हाउ मेनी टाइम वी आर स्टडिंग हियर. टेल हिम फ्रॉम हाउ मच टाइम वी आर स्टडिंग हियर. लक्ष्मी भाई आप वो एमसीडी वाले हैं क्या? मैं आपको स्टूडेंट समझता था. ये फोटो नहीं दिख रहा आपका. Okay, so from 10 a.m. and Mr. They start saying after this class na 9:15 again I have a paid class of strength of materials. लक्ष्मी भाई आप एमसीडी वाले हैं क्या? मैं तो आपको समझता था कि आप एमसीडी वाले हैं क्या? तो बहुत अच्छी बात है. आप तो बहुत सारी क्लास में आए ना फिर मेरे. अच्छा नहीं, ओके. नहीं आपने भाई लिखा ना उसको, तो मेरे को लगा कि आप जानते, आप स्टूडेंट. अच्छा ओके, सो ये समझ गए क्या? एवरीबडी गॉट इट गाइज. प्लीज टेल मी. Okay. Now guys, these all formulas, ये करो जरा, are for single pile capacity. We have not seen. Actually, pile is used in groups. Pile is used in groups. Pile is used in groups, not single. So what is the group capacity? We'll see it now. And those who have not liked the session, guys, please like. Come on. अच्छा क्या आ गया? Resistance due to skin friction QF is equal to stress into AS. What is AS for circular pile? This stress is different for clay, different for sand. This pi dl, so it is per LD. Got it? Got it or not? Got it or not? Got it or not? Okay. Now, guys, piles are always used in group. Till now, we are seeing the single pile capacity. Till now, we are seeing the single pile capacity. Okay. Now, everyone, but pile is used in groups. Pile is used in groups. Okay. So, these are the piles, and generally it is square fashion. Okay, like this. Suppose spacing, center to center spacing is S. Okay, center to center spacing is suppose S. So what is this total distance? S, 3S plus D. How 3S plus D? Because S is from center. So D by 2 here and D by 2 here. Total D. Similarly, this will be also 3S plus D. Now guys, if group efficiency will be this here, very simple. Suppose one pile capacity is 100. So there are how many piles? 16. And total capacity of this assembly is 1600. Okay. Suppose the capacity of one pile is 100. Suppose the capacity of one pile is 100. And there are 16 piles. So capacity of 16 piles is 1600. So it is efficiency is 100%, na? QUG 1600 upon 16 into 100. 1600 upon 16 into QU is the capacity of one pile. So it is 100%. Now guys, due to intersection of pressure bulbs, na, efficiency can be reduced also. Because when there are more piles, in that case, might be there is intersection of pressure bulbs. Okay, if the spacing is not appropriate. So we can have a lesser capacity also. The group cannot take 100, 100, 100. All cannot take 100, 100, 100. Individually they can take 100. But when they are coming group, because of this 100, some stress is coming which may cause failure in between some soil. Because this also 100, this also 100. So in between some failure can be there if there is intersection of pressure bulb. Okay. If there is an intersection of pressure bulb, there can be a failure. Okay. 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 So, and guys, listen. Listen. It is not like that. It is not like that. It is not like that. That efficiency will decrease only. Efficiency may be greater than 100%. Can anybody tell me how it is greater than 100%? Can anybody tell me how it is greater than 100%? Can anybody tell me how it is greater than 100%, please? How it is greater than 100%? Can anybody tell me? Okay, guys, it can be 100% because when we are inserting one pile, so nearby soil densifies, na? Nearby soil densifies, na? If I inserting one pile, the nearby soil will densify because some volume is occupied by the pile material. So voids will decrease because solid solids has to be same, na? So when this is the thing, when there is no, this is the space, when there is no pile, there is some voids. When we are inserting the piles, so voids will be reduced, na? And when voids will be reduced, might be the strength is more, bearing capacity will more. When the voids are reduced, might be the strength will more because the bearing capacity increase. And in that case, if pressure bulb is not intersecting, might be the strength of one pile is QU, but due to insertion of many piles and increasing the density of soil and increasing the bear capacity, the capacity of The capacity of 16 piles may be more than 16 QU na? Maybe more than 16 QU na? Give me yes or no. Give me yes or no. Everyone. Everyone guys, come on. It can be more than 16 QU na? Everyone please. Yes. So guys, now for sand efficiency is taken as 100%. Okay, so for sand nothing to do. QU formula we know, number of piles. So QUG for sand is simple. QUG is N into QU for sand. Okay, QUG is N into QU for sand. QUG is N into QU for sand. Tell me. Tell me. Tell me. Tell me guys, everyone. नहीं मैं तो खुद ही नहीं लाया ना, मैं इनसे लूंगा पेन टैब वीडियो टीम से।
मैं ले लेता हूँ, मेरे से ले लेना। 9:30 आपका
979। Okay guys, is it hello? Okay, got it? Okay, now for sand it is N into QU, simple. QU you know, multiply by N. But for clay, okay, for clay also I'll tell you a simple technique. For clay also I'll tell you simple technique. For clay also I will tell you simple technique. For clay also I will be telling you a simple technique. Suppose okay. Suppose center to center spacing is S. Okay. And center to center spacing is S and diameter is D. So what is this total area? 2S plus D. What is this total area? 2S plus D, correct? Correct? And suppose length is L. So now guys please see, what is the formula for QU for clay? Apply that same formula. Apply that same formula by assuming not these 9 piles or 16 piles or 25 piles. Assuming it to be a single cuboidal pile. Same answer will be correct. By assuming this as a single cuboidal pile. This is a cuboidal pile. So what is QUG? It is QF plus QP. Now what is QP? Area, this is C and C. NC is taken as 9 into area base. NC is taken as 9, area base. Area base is 2S plus D whole square. What is QF? QF is stress into area. What is this? 2S plus D into L. Okay, this is 2S plus D. 2S plus D into L. And how many such surface? 4. 1, 2, 3 and backside 4. 1, 2, 3 and backside 4. There are 4 surfaces. This is area and alpha C. Alpha C. Alpha is 1 here. That is the key point. Because here guys, adhesion, when this whole surface is failing with respect to the nearby soil. So mostly it is soil and soil contact, na? Because in this pile will be very small, na? Mostly it is soil and soil, soil and soil, soil and soil. So that is why it is not adhesion, actually it is cohesion, same particles. So it is taken as 1. Okay, so there you can find QUG. For sand it is very simple. You know QU, multiply by the number of piles, you will get QUG. For clay, assume it same, it is whole as a single pile, cuboidal pile, and get the answer. Give me yes or no. Now these are some other formulas that are empirical formulas. Okay, negative skin friction is, guys, suppose na, usually what you do, Q is equal to QU plus QF. But suppose a recently filled soil is there, recently. Okay, so this soil is going downwards na. This soil is recently placed. So recently new fill soil. So due to some settlement is going downward. So it is applying negative drag to the pile. So it is negative friction. It is negative friction because it's going downward, applying negative drag. Applying the negative drag. Okay. So do this. Do this, guys. So guys, it is developed when the pile is driven through recently deposit, and this is all sudden drawdown. Okay. B will not be there. It is developed when pile is driven through a layer of dense. Why dense sand? Dense sand is already settled na. Recently placed fill is settled. Now guys, sigma bar is sigma minus U. When drawdown of water happens, sigma bar increase. When drawdown of water happens, sigma bar increase, and sigma bar increase when soil settles. Suppose I am applying compaction. I'm applying compaction. So when I am applying compaction, so soil settles na. When I apply compaction, soil settles na. So soil settles, that means it is going down, so applying a negative drag. So that is soil exposure only. It is area ratio you have to study from here, na? This area ratio is asked. Okay. One very famous question of shallow foundation was there. And leave it, let us calculate for deep only. Famous question of deep, where it is? Where it is? Where it is? This one. Pile foundation. Okay. Do this. There are 9 piles arranged in square pattern. Find the spacing between the piles so that group efficiency 1. Neglect and bearing. Neglect and bearing. This question, guys, who can do na? Who will do it fastest? Who will do this fastest? Then guys, whenever he wants. Not today, might be his. If UCS is 100, then C is equal to 50. Okay. Though that student who do it fastest, okay, will get a chance to have a video call with me anytime. For anytime he can have a video call with me. Apart from that time, my class will not be there. Maybe tomorrow, maybe day after tomorrow. Not today also, because I have class after 9:15. So though that student who will do it fastest can have a call with me anytime. Okay. So guys, this is clay or sand? Clay. So efficiency is 100% na. That means QUG is n times of QU. So QUG is A times of QU. let me see the first comment of the correct answer. Whoever will be giving free call, video call anytime with me. Okay, so what is QU? QU is equal to QP plus QF, but end bearing has to be neglected. So this is 0. Okay, 8 meter long piles are in a column in a uniform deposit is this. There are 9 piles. Okay, the number of piles are 9. And length is 8 meter. D is equal to 0.2 meter. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay. So we want what? Find the spacing between the piles. Acha, S. We want this S. We want this S. So what is this total? S plus D by 2 and D by 2. So S plus 0.2 na? This is S plus 0.2 na? Sorry, 2S plus 0.2. This is 2S plus 0.2. Similarly, this is 2S plus 0.2. Okay. This I am writing for single pile. This I am writing for single pile. That student who did it fastest will get it. Come on, everyone. Come on. Everyone. Chalo. Okay. So this is QF. I am giving you some tips also after this, na? Tips of the GATE exam. Okay. So QF is equal to alpha into this. For single pile, alpha will not be 1. So alpha is 0.1. Oh, sorry, 0.9 into C is 50 into AS is pi into D. D is given 0.2 into L is 8. So what is this QF? 226.194. 226.194 kilonewton. So this is 8 into 226.14. Sorry, 9. Why I have written 8 here? This is 9. So this is equal to 2035.75. 2035.75 kilonewton. 2035.75 kilonewton. Okay. Okay. Now leave this. Leave this. I am writing now QUG. I am writing QUG. So end bearing has to be neglected. Only QF will be there. End bearing has to be neglected. Okay, so whose first answer is point? Only answer correct is Ratnadeep Rajkumar. Anytime you can mail me abhinav.negi@byju's.com. We'll be having a video call. I'm giving you some tips also. QP 0, alpha is 1, C is 50, AS is 2S plus 0.2 into 8 and 4 such surfaces. Okay, and this is equal to 2035.75. Okay, so from here the S value for 100% efficiency is 0.536 meter. S value for 100% efficiency is 0.536 meter. Okay, got it? Everyone, please tell me. Any doubt to anyone? Any doubt to anyone? 0.6 nip, this is this. Okay. Now guys, done. You can join me in Telegram group. Here I am putting the PDF. Civil by Abhinav sir. Let me put the link in the comment box. Okay. Now this is the marathon. Quiz will be available here, guys. Okay. You can attempt the quiz whenever you are free in the night. So for question practice, you can attempt here in this. For any one-to-one interaction with our counselor, you can click there. And for guys downloading the app from where you can get the notes of technical and non-technical subjects and PYQs of BARC and all, you can do here. Prince lateral pile capacity will take a separate topic. Okay. So that you will do for that. एक बार याद दिला देना mail पे है ना. So that you can do here. Now guys, tomorrow will be the marathon of hydrology and irrigation. Okay, this will be tomorrow, and surveying will be, no, this is wrong. Surveying will be at how much time? Surveying will be 6 p.m. Okay, Sunday. Okay, this is Sunday only. 14 Jan is Sunday only. Okay, this is 6 p.m. Sunday. Okay, and this is HMM's class will be 13th. Now, this is QR code. If you want to scan, you can pause it and scan it. Okay, otherwise, without scanning also, now from here also you'll get the same quiz. That QR code is for quiz. Now we'll meet on Sunday. Obviously, we'll meet on Sunday. Let me tell you, guys, everyone, every commando, that till from today na, what is the date today? Today is 12th. Today is 12th. From 12th Jan to 4th Feb, approximately the days you are having are approximately, you can say, 20 days. Okay. Okay. Guys, GATE exam was never a 100-meter sprint. It is a long marathon. So when it is a long marathon, not to give you any false motivation, the large effect will be of that you have done in previous few months. Okay, the maximum effect will be of that thing that you have done in previous 6 to 7 months. But guys, these 20 days will also be very, very crucial. Let me tell you, these 20 days are not bigger. Suppose you have studied for 150 days. So this 150 days preparation will have a larger impact than these 20 days. That 150 days preparation will be having a greater effect on your marks than these 20 days. This is a fact. This is a fact. But one more fact is that in those 150 days, any 20 days you take, in last 150 days, any 20 days you take, that will be less than effective than these 20 days. These 20 days means 12 Jan to 4 Feb. Little bit complex I am going. I hope you are understanding. These 20 days means 12 Jan to 4 Feb. Okay. Suppose you have done 150 days preparation. You are getting this, what I want to say here. Suppose you have done a 150 days preparation. That 150 days preparation will be putting a greater effect on your marks, on your score, on your rank than these 20 days. But in 150 days, now you take any 20 days, even the best of the 20 days. Even the best of the 20 days cannot produce that much effect than these 20 days. Even let me tell you, here whatever the best 40 or 50 days are, na, that will be these 20 days. That means these 20 days will not make you from 0 to 100 or will not make you from 90 to 0. But these 20 days can make you or can increase or decrease your marks that here 50 days are done. Okay. 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 So Mohammed Salahuddin, वो तो आपको पता करना पड़ेगा. कॉन्सेप्ट में फॉर्मूले में दिक्कत नहीं होती है. फॉर्मूला तो एक दो बार में याद आ जाएगा. सॉल्व नहीं कर पा रहे तो कॉन्सेप्ट में ही दिक्कत है, और सिर्फ फॉर्मूले में दिक्कत है तो रिवाइज करके हो जाएगा. बट आई गेस जहां तक ज्यादा बच्चों का कॉन्सेप्ट में ही दिक्कत रहता है. सो नाउ व्हाट टू डू इन दिस 20 days to make it more effective? First of all, guys, delete a myth from your mind that you have to study 19 hours, 18 hours, 17 hours in these 20 days. Every day, if you study 12 to 14 hours, if you can, that is more than efficient, guys. Even I guess 10 to 11 hours will also be fine. Every day. Okay. Watch your classes, select your videos, watch any free videos or paid videos selectively. It should not be like that. There is various free content in YouTube here, millions of hours. You cannot watch everything. So you have to selective in that. Is that teacher is good for you? Is that channel is good for you? And if some of you are preparing for engineering service preparation also, and you're thinking that after GATE hum de denge, okay, and you might, some of you might drop it, the idea of giving the exam, better to drop it now only. Why? To reduce your efficiency for the GATE exam. Okay, why to reduce your efficiency for GATE exam? If you are preparing for engineering services in such a way that you may drop that idea at any point of time, might be 26th of January, might be 3rd of February, might be 4th of February, or might be 10th of February. So better drop now only. Okay, जो subject अभी तक नहीं पढ़ा है, whatever subject you have not done till now, and you feel very, very tough that subject, leave that. उससे नहीं आएगा कुछ भी. उससे नहीं आएगा कुछ भी, ये मान के छोड़ दो. You have to control your nerves, guys. Between India and Pakistan, na, when 11 players are selected from Pakistan and 11 players are selected from India, guys, I'm not saying that India has a better player or Pakistan has. There are some eras when Pakistan have a better player. There are some eras like now when India has a better player. But guys, never these intensive matches are of showing your skill. This is about handling the pressure. Same is this last 20 days and those 3 crucial hours. That will not be about your skills. Skills are mostly developed now. This is about handling the pressure. This is about those 3 hours. That is why various brilliant of the students are getting ranked sometimes 2,500, 3,500. And sometimes those who utilize these 20 days properly, have a focused mind like Mahendra Singh Dhoni, deliver the best there in those 3 hours. Might be the students who are deserving rank 5,000, 3,000, 2,000 are getting sometimes rank 750, 1120. Guys, it should not be that our aim should be rank 5, rank 10, rank 200. Accordingly, whatever you deserve, you can improve that. And sometimes this happens in last 20 days. That suddenly the student is very focused that I have not to do this and I have to do this, and in that focused environment he developed its brain like that those 3 hours he produced the best of his life. And such students who are earlier in test series getting 2,000, 3,000, 3,500 rank suddenly come up that, sir, I'm selected and I will be getting IIT degree, IIT from old IIT's MTech, because I got rank 750, I get 1100. This kind of transformation happens usually in last 20 days and of course by the output of those 3 hours. Okay, so I hope you enjoyed this. You enjoyed this session, guys? You not enjoyed, you got benefited from this? Have you or not? Thank you, guys. I have another session. I have another class from 9:15 to 11:15 in the app. Okay, thank you. Thank you, guys. Take care. It was a wonderful day with you all. Hats off to your energy, guys. A lot of dedication has been shown by you all. Many of you are starting here from last 11 hours, guys. Thank you, guys. Take care. Wish you all the best. Before the exam, before the exam, after the exam, we will be with you. Okay. Thank you, guys. It was a wonderful 11 hours with you. Thank you, guys. Take care. Thank you all. मैंने कर दिया होगा नहीं